My name is Andreas, and in this video we'll build a HeyGen clone with features such as turning photos into speaking videos, translating videos automatically, and replacing the audio of videos. Try listening to these samples.
I got the idea to start.
I'm on vacation right now. Let's do business. I am a real photo.
नमस्ते, मैं आंद्रेस हूँ.
This is a product demo.
I am a fake photo.
To turn a photo into a speaking video, here is what you do. First you open up the photo to video pop-up in the dashboard, and then you should be able to select a photo. You then crop it to the area that you would like the final video to contain. You then write the script the video should say and pick the voice. Let's try this one.
I got the idea to.
That's all good, so we pick the voice and click generate video. The generation item is added to a queue and its status visible in the dashboard. Whenever it is done, we can click refresh up here to refresh the status and check out the final results.
My name is Andreas.
This looks pretty good to me, so let's download the video so we have it on our local machine as well. The AI model we just used is one that we are going to self-host, but we actually also integrate with a third party so we can use that AI model as well. And instead of putting in a script that should be read aloud by the person in the photo, we can also let the user record audio directly in his browser. You can also just upload an audio file. So let's use this one.
Hello from Modal. This is a test.
And now we just click use this audio. Then with this external AI model, we can also set the expressiveness in the video and also control the resolution of the output video. So let's click generate, and then the video is added to the queue. And when the video starts to get processed, we can click refresh up here to check its new status. After a few minutes, we can check out the finished results.
Hello from Modal. This is a test of Chatterbox.
We can also test out the translate video feature. Here we first select the video we would like translated.
Hello from Modal.
And next we select the target language it should be translated to. So let's try out Portuguese and then hit translate. The job is then added to the queue out here in the dashboard, and we can refresh for the final results.
Olá do Modal. Testando o Chatterbox.
Then we also have the change video audio feature. Here we also need to specify a source video we would like to change the audio for. Then we can upload a new reference audio that should replace the existing audio in the video. We can just test it out here.
I got the idea to start.
And that sounds like it should. So what this feature does is that it replaces the audio and also synchronizes the lift movements with the new audio. And the results we can check out here.
I got the idea to start.
And that sounded perfectly fine. We can then go ahead and rename our videos in the dashboard to whatever we would like. We will also build a credit system. So right now the user, for example, has 0 credits. So let's go ahead and try and create a video just to see what happens. So we'll select a video, select a target language, and then click translate. The video is then added to the queue and the dashboard, and refreshing after a couple of seconds, we see no credits. Luckily, we have made an integration with Polar.sh. The user can therefore pick between 3 different credit packs. So let's just try and buy the small one, which will give us 10 credits. This should then redirect us to the dashboard and then add the credits to our account. Polar.sh also integrates very well with our Auth framework, BetterAuth. By going to the customer portal through this menu right here, the user will be able to see data such as previous orders and also settings such as payment methods and billing details. We will also have an account page like this where the user can change his name, email, and also his password. Everything related to authentication will be handled with the framework BetterAuth, and all UIs such as the sign-up card you see right here will be created with the BetterAuth UI library, which comes with all authentication pages pre-made for you already. This will save us a lot of time. We will self-host 2 AI models. When we deploy these AI models, we'll be able to see each request they receive and also see the logs of each individual request. We are going to use serverless GPUs on Modal to host these AI models completely for free. For the database, we're going to use Neon. Here we will set up a production and a development database to keep the data separate. We will also use its dashboard to check out the data and modify it during development. All in all, this project is a full tutorial on how to build a modern SaaS app hosting both your own AI models and integrating with third-party APIs. We'll implement a background processing queue like you would in a scalable production-ready app. You'll then work with S3 buckets on AWS, Python, Next.js, React, Tailwind, Postgres, and touch on concepts such as payments and authentication. Now, let's get started with the project. Let's first talk about the features which we'll build and then also how to build these features. So we'll build multiple different features using both self-hosted and external AI models. Both of these options will be free to try out, so don't worry about that. First of all, the first feature which we'll build is going to be the image to video feature. This is also called portrait avatars if you would like to research that on your own. I've picked out a model called Hello3, which is a pretty new model, which we can self-host in the cloud. And the way inference works for this model is that it takes a photo that we would like to be talking. It also takes an audio file. This audio file should read aloud a script for what the photo should say. And then running inference with this model with these inputs, it will produce a full video. So broken down even further, it looks like this. We'll give it a reference image. This is the image we would like to speak. We can also give it the driving audio down here, such as "My name is John." This is what we would like the image to say. Lastly, we can also give the model a description of the image, such as "smiling men under red paper lanterns," and this description will help the model generate better results. We then take these three inputs right here, feed them into the model, and this will then generate a video that speaks the script down here. And because we are working with video right here, so video is being generated, inference takes quite a while with this model, because it will have to generate these frames one by one. So the basic flow of generation down here, as you probably saw in the intro as well, is that a user first selects a photo, then the user can put in a script or an upload file or upload an audio file, and if he puts in a script, he also has the option to pick a voice that the script is read aloud in. Then the user clicks generate. This all happens in the client side on the browser. Then whenever the user clicks generate, a request is made to the backend. And we have two options right here. Either the audio file is provided or no audio file is provided, but only a script is. So if no audio file is provided up here, well then we do not have this input for the model. So we'll just need to generate the driving audio with another AI model that is just text to speech. So in that case, we'll need to make another round trip to the server over here. First of all, if we do have the audio file, well then we can just go ahead and make inference straight away. So our Next.js backend is going to call our Modal backend over here, which serves an API inference endpoint that will generate video. So when we have the video already, we'll just need to generate the video. So we make a request to our backend. The backend will then generate the video, and the API will then return the path to this video in an S3 bucket on AWS. So this is the simplest approach right here. If we then have no audio file, but only a script, well then our Vercel backend is going to need to make two API calls to our Modal backend over here. The first call is going to be using the script to generate the audio. So we'll call this API inference endpoint that does text to speech. You can also provide a voice for this text to speech endpoint if you would like to clone a specific voice. That is why I say you can provide a voice right there. And then this will then do text to speech and then return the path to the audio in the S3 bucket. And now we'll then be ready to do the same as we did up here. So we'll be able to include the path to this newly generated audio from the text to speech, and then also the image itself, call this generate video endpoint, and then video will be generated and the path to this video in an S3 bucket returned to the Next.js backend such that we can display it over here in the browser. So providing a script instead of an audio file just means that we need to do another round trip to our Modal backend because we'll need to do the text to speech part as well. So that was the basic flow of how this model up here works whenever we serve it in our application. Good. The second thing we'll do down here is implementing the same feature just with an external AI model. This external AI model is called Portrait Avatar, and it is hosted on a service called Sieve data, this one right here. So inference works kind of the same way as it did up there. We'll still provide a photo like we did previously. This is just provided through the API instead of our own API, and then Sieve data then offers multiple different models and generation options that we do not do. So it might work a little bit better because the researchers in Sieve data have optimized some of these models to work even better. So the reason I want to use both external models and also models that we self-host is because it's a pretty cool way to see how our system can support multiple AI backends at the same time, so you can kind of switch between these as the user. Also, it makes the system more flexible because if this model right here is bad for some purposes, well, this model up here might be better for those purposes, and vice versa. So the flow kind of goes like this. The user picks a model to use, and this is going to be like with something like checking a checkbox. The user can then click generate, and by the way, both of these things happen right here in the browser. And then when the user clicks generate, then based on the pick of the model over here, then either our backend or the Sieve backend is called, just with the same parameters, because the user will need to upload both a photo and also the driving audio, or at least provide a script in both of these cases. So let's try and take a look at how the flow looks whenever we use Sieve instead of our own model up here. So again, the user selects a photo, puts in a script or an audio file, and clicks generate. Then either we have the two cases again. We have the one with the audio file provided and the one with the audio file not provided. And it is going to be a little bit different whenever we use Sieve compared to whenever we use our own model up here. So first of all, whenever we use Sieve, we queue a job whenever we call our backend. We don't just call the backend and then wait for the backend to generate the video. So whenever our backend, let's take the audio file is provided case for example, whenever our backend wants to generate a video through Sieve, we then request a portrait avatar being generated over here, and then Sieve returns whether the job was queued or not queued. So this means that Sieve doesn't wait with returning the response until generation is finished, as we do with our own Modal backend. So the HTTP response just provides some info on whether the job was queued or not. Then whenever Sieve receives a request over here, it is also going to deduct some credits from your account. You have something like $20 of free credits anyways though, so you don't really have to worry too much about that. Also, then whenever they receive this request right here, the job processing status can also be monitored in the Sieve dashboard. You can see how it might be queued, processed, or is currently processing. And then you can see some logs in the dashboard as well if you would like to debug if something goes wrong. And also you might have wondered if the job was just queued or not queued, and that is the only response we get back from Sieve, well then we'll need to get the actual result of the generation at some later point. And I'll explain this in a further section, in a future section right below here, whenever we reach that part. So this was the scenario where the audio file was provided, and just as up here, if the audio file is not provided but a script is, well then we'll just call our own endpoint right here for text to speech, then we'll clone a voice or have some voice read aloud the script that was provided. This will then return a path to the audio in an S3 bucket, and this can then be the driving audio, which we send to the Sieve API just as we did up here, along with the photo. So again, we just do an extra round trip to the Modal backend before we call the other API, which is the Sieve API down here. So this will then queue this portrait avatar right here being generated, and this will also just queue the portrait avatar being generated. And then down here, whenever Sieve finishes the generation, it will then send us something called a webhook back with the actual result of the generation. So the Sieve server will send a webhook back. This is basically just an API request just sent from Sieve to us instead of the other way around, back to our Next.js backend. We then tell Sieve where they should send the webhook, and we tell Sieve where they should send the webhook on the initial request up here. So the flow looks like this. Our backend that is running on the cell in production is right there, and then we have the Sieve API right here. So whenever Sieve finishes generation, as you can see right here, Sieve will then send the request to our backend, and this request will then contain whether the generation failed or succeeded, and then also the URL to the generated video if it succeeded. And then we send a response back to Sieve that says something like, we acknowledge your webhook, and this means that we have saved the URL pointing to the generated video somewhere in our database, or maybe download the video to our own S3 bucket. And then if the generation failed, we'll just save that status in the database and make sure that we show that to the user. And the way we acknowledge a webhook is simply just by returning a 200 OK status instead of something like a 500 internal error. So this is how it's going to work whenever we use Sieve. And we can also dive a little bit more into the basics of webhooks in case you haven't worked with that a lot before. So the basics is that first of all, we have a backend right here, for example, and then we have Sieve right here. And then the first step is telling a backend over here to start generating. So the way we do this is that we make a request to the backend over here, which we would like to generate something. Then we send it the generation parameters. So this would contain the URL, for example, that it should send the webhook back to, but also parameters such as the image for the image for inference, the driving audio, description of the image, etc. And then what the Sieve API will do is it'll send a response back saying, okay, we've started generating. So it'll just tell us, as it did up here, that the job was queued or not queued, basically. Then whenever it finishes generating over here, it will then send a webhook back. So maybe 15 minutes goes by and then generation finishes, and then the Sieve backend will tell us that it is done. So the Sieve backend will send the request back to us, and then it'll say we are done generating. here is the link to the output that you requested initially up here. Then we send a response back to Sieve saying, well, that is noted, that is just the 200 OK response. So that is the basic flow up here. So instead of only sending a single response like we do up here, we send the response to generate, then we wait for it to finish, then it returns the response back. Oh, sorry, we send a request, not a response. Then down here, it happens over 2 requests. So first we send the request to start generation, but then instead of waiting for it to finish, we'll just do it asynchronously. It'll just do it asynchronously, and then it'll send the request back to us whenever it is done, instead of us having to wait for it. So this has some pros and some cons. So one of the things that could also happen instead of the video being generated perfectly fine over here is that maybe an error happened. So errors can of course both happen on our side, but also on the Sieve API side. So let's say an error happens on our side during receiving the webhook. So for example, Sieve right now is going to tell us that the backend is done and a video has been generated. So it sends a link over to, or sends a webhook back to our application over here. Then it says we're done generating, and then here's the link to the output. And then we made an error in the code in this example that in turn causes an internal server error. Then because we return something like a 500 internal server error, Sieve will then know that an error happened right here. And then because these webhooks are done asynchronously, it'll be able to do something like, okay, we'll retry in 5 minutes, and then we'll just see if it works then. And then if we after 5 minutes send the same webhook, or Sieve after 5 minutes send the same webhook to us, and then we get an internal server error again, then Sieve might wait 10 minutes and then try again. And it can do this a series of times until it actually gets a 200 OK response back. So this means that the Sieve can then retry these webhooks until it knows that we've received the response that we were looking for initially. So what would happen if we just waited like we do up here with the Modal our Modal backend instead of using these webhooks? Well, in that case, we would make a request to the Sieve API, and then we would say start generation, and then we wait for the Sieve API to generate, and then maybe 15 minutes goes by. And then after 15 minutes, it should then return a response back. And this response should then contain the URL to the output. But we have a couple of problems with this approach. First of all, we might have this running on a serverless endpoint, which will then time out after only 1 minute, because that is something like the limit on Next.js whenever we host it on Vercel, because these serverless functions can run forever. So maybe our backend endpoint right here will time out, and then we'll never receive the response. And then all of these 15 minutes of generation are used over here on Sieve, but then because we won't be available to receive the response, we'll just waste all of this generation because we'll never even receive the response. So that is one of the errors that can happen if we just wait instead of using webhooks. We have guarded against this though whenever we use the approach up here with Modal, because we'll use Inngest to do all this in the background. But this is just so you know one of the reasons why some people might use webhooks instead of just waiting for the response. So looking into the pros and cons of webhooks, some of the pros are that our server doesn't have to wait for the generation to finish of this Sieve API, for example. So when deploying our Next.js app to Vercel, all endpoints that are deployed will be deployed as serverless functions. This means that each function will have a timeout of about 1 minute as far as I recall. So we'll lose the response if generation takes longer than that. And for these kind of video generation AI models, it almost always takes longer than 1 minute to generate. We're going to fix this though using Inngest, just so you know that, so it won't become a problem for us. But if we didn't use Inngest, for example, well, this would then become a problem. Also, another pro is that, as I explained before, the server can retry sending the webhook if we don't return a 200 OK response. So without a webhook, we would only get one chance to actually save the response and get it right. And in this example, which I showed you up here, we, for example, timed out and then lost the response completely, which is kind of bad because the user won't be able to see what happened. Also, the cons of webhooks over here is that we have the added complexity of having to implement these webhooks, because you'll have 2 API requests and you'll need some kind of API endpoint, which you can then call to give us the response. And this node right here of using Inngest to fix the problem with waiting, I'll just move out, because that isn't really a problem, that is more of a note. Like this. Good. So let me just walk you through a little bit more what we'll then do whenever we get a response from Sieve up here. So we now have the URL of the generated file from Sieve, and as I explained before, we have the URL from the webhook up here. So it'll send us the URL to the generated video, and then we'll have the URL. Good. So We won't just store this URL from Sieve though in the database, because this URL from Sieve is just a pre-signed URL with an expiration date. This means that that Sieve stores the file that it just generated somewhere in a bucket, and in their case they use Google. And then what they do is they generate a URL that you can use to access this file basically. But this URL won't last forever. It'll expire at some point, and then we won't be able to access the file anymore. So we'll need some way to persistently store this file instead of having to rely on using their URL which expires. So for example, if I today generate 3 videos and then just rely on their URL right here for showing the videos in my dashboard, well then today I'll be able to see the videos. But then let's say this URL right here expires in about 3 days. Well then if I check back in a week later, well then my dashboard would look something like this. I would just have 3 videos which wouldn't be able to play because this source right here would be invalid. And this is the exact problem which we would like to avoid by downloading down this file right here to a bucket of our own using an external service which we'll implement ourselves. So to fix this, we'll therefore create a service that downloads the video from Sieve's pre-signed URL and then uploads it to our own S3 bucket. And this means that now we own the file and it won't just disappear, like I explained that it would over here if we just rely on their URLs. So the flow looks like this. The user clicks generate on a video, then Sieve starts generating. Then once Sieve is done, we'll obtain the URL to the generated video from the webhook as I explained. Then after doing this, we'll call our endpoint, which is the service which we'll create. This service will then download the video and then upload this video to an S3 bucket. And now whenever we want to show the file in the dashboard, we'll generate a pre-signed URL of our own, so which we can use to show this video instead of using Sieve's URL over here. So we won't even save this. It is just going to be some temporary URL which we'll just need to use to download the file to store it on our own. Good. So that is how that works. So this right here was the walkthrough of how the feature will work. Whenever we want to create the image to video. So this was a pretty cool feature. But now let's hop down to the next one, which is translating a video. And this is also called dubbing. For this dubbing feature right here, we won't be using a self-hosted model. We'll only be using the dubbing endpoint on Sieve. And basically what this dubbing means is that dubbing is just taking a video with, for example, English speaking, and then using AI to make the speaker speak in another language in the video. So it both means taking the audio and then changing the audio to the new language, but it also means taking the lip movements and then matching the new language. So for example, if you have the English video right here, then it should just be translated to a Spanish version, and then you wouldn't even be able to tell over here that it was an English version. You would just think that it was Spanish natively. So that is what dubbing means. The generation flow looks something like this. The user picks a local video file because we'll need a video file, and then the user also selects which language to translate to. Then the user should be able to click a generate button. This all happens in the browser, and then we'll then call our Next.js backend over here. Our Next.js backend will then call the Sieve AI backend over here with the parameters that the user specified, such as the things we'll talk about down here. And then whenever Sieve is done generating, it'll then send a webhook back to our Next.js backend, which we can use to save this video as we explained up here, save the video, and then we should be able to show the video that was generated over here in the browser. So we covered pretty briefly how the flow looked up here, but let's go a little bit more into depth with how it actually works in practice. So in this step between the browser and the Next.js backend call, what actually happens when the user clicks generate? Well, Sieve AI, for example, or the Sieve AI dubbing endpoint is going to need a link to a video file stored in the cloud. So this is the video file that the user picks right here. So we are storing this video file in an S3 bucket. So you might have wondered, well, if a user picks a local video file in this browser, well, how can we take this video file, send it all the way over to the Sieve backend over here? And the way this works is that we do not just send it to our backend and then send the video file from the backend to the Sieve backend. That is not really how it works. The way it works is that whenever the user clicks generate, step 1 is going to be making a request from the client to the backend, so from here to here, where we tell the backend, please give us a pre-signed URL, which we can use to upload this file that was selected to an S3 bucket. So this S3 bucket will then be an external thing that is not part of any of these 3, so it might be somewhere like up here. So we'll then have this S3 bucket, which is just somewhere in the AWS cloud, and then we'll get a pre-signed URL back from the backend, which we'll be able to use to upload the video file to this S3 bucket over here. Step 2 is then uploading the file from the S3 bucket, from the client to the S3 bucket. So instead of uploading the file through the backend to the Sieve backend, we'll upload the file to the S3 bucket right here. And we'll upload the file through this pre-signed URL, which the Next.js backend generated for us. So this entire upload process right here happens on the client. And then whenever the Next.js backend is called over here again, we will then tell the Next.js backend the location of the video in the S3 bucket, like this. So the Next.js backend will then know the location of this video, which we uploaded in the S3 bucket. Then it is also going to generate a pre-signed URL for that, and then send this pre-signed URL all the way over to the Sieve backend. So instead of the video passing through all of these different layers, the video is just going to be stored safely over here on AWS, and then we only pass the location to the video file instead of the video file itself, because video files are pretty big and chunky to work with, so we don't really want to send those in network requests. So that is how it works in this step right here. I'll just remove these two right there and right there. Cool. Then over here we'll just talk about what happens between these two steps right here as well. So first of all, whenever we make a request to Sieve, Sieve is of course going to need access to this uploaded video over here. And then step 1 is therefore our backend generating another pre-signed URL for the file that was just uploaded over here to the S3 bucket. And then if you do, for example, take this URL, this pre-signed URL right here, and then paste it into your browser, well, then navigating to that URL will just automatically download that file. This also means that if we just send this URL to Sieve, well, then Sieve will be able to access the file through that URL. And then step 2, the request made to Sieve will include this pre-signed URL. This means that Sieve can access the file, and then also we'll send the target language to translate to Sieve, and then also tell Sieve which route to send the webhook back to whenever generation is done. So then Sieve will have everything it needs to do both the generation and also to let us know about the results. So therefore, whenever Sieve is done, it is going to send the webhook back, and then using our endpoint over here, we'll then be able to take the URL and then store it inside our own bucket over here, so that we can show it in the dashboard of the user. Cool. The third feature we can talk about can be this change video audio down here, which is also the last one. Changing video audio is also often called lip sync, in case you would like to research that yourself. And the way we're going to do lip sync is also by using the lip sync endpoint on Sieve, which also uses open source models, which have been improved as far as I know by the researchers in Sieve. So this means that we won't be self-hosting any models, but we'll just rather be using the lip sync endpoint on Sieve because it works really well. So basically, lip sync synchronizes the lip movements in a video with another audio track. So it basically means replacing the audio of a video and then making it look like the speaker actually said that. So it is pretty similar to up here, where we then provide a video and then also a target language. But instead of providing a target language, we'll then just provide an audio file, and then the output video over here will then just say that audio file instead of trying to match some target language. Good. So the way it works is that the user picks a local video file, then the user picks a local file for the audio or records some audio directly in the dashboard, and then the user is able to click generate. This all happens client side. And then as I explained earlier, these files are then uploaded to an S3 bucket through the client right here. Then our Next.js our Next.js backend right here will then take the S3 keys of these files that we just uploaded to S3 and then create pre-signed URLs for those. So pre-signed URLs. It'll then pass these pre-signed URLs over here to Sieve, and then whenever Sieve is done generating, it'll send a webhook back, as we have also talked about earlier. Then we'll take that URL that Sieve sends back, upload it to an S3 bucket of our own, so we now own the file, and then we can use that file to show the video in the browser for the user. So all of these flows are pretty similar. We have our own browser, we have the browser where the user is able to click things. We then have a Next.js backend. We can call a Sieve AI backend over here as well. When Sieve is done generating, it'll send a webhook back. We'll save the results, and that is basically it. So that is the flow whenever we use Sieve, and then whenever we use Modal up here. What we then do instead is just that we call the Modal endpoint over here, wait for it to finish, and we offload this waiting to Inngest instead of waiting on our own serverless functions, because then we'll time out. Then whenever we get the response back right here, we just save the S3 key to the response, and then we're done with that request. So that is basically how these 3 features that we're going to build works. So now we have covered that, and we can move on to the next part up here. So I'll just hop all the way up and then go over to the next part. And this is just basically more architecture talk. So as we've already taken a look at, our application is super background processing heavy. So therefore we'll take a look at how background processing works. We'll also take a look at how the database works, payments, authentication, etc. works, because these are all parts of the SaaS application which we'll build. First of all though, I would just want to talk about our sponsors of this video. So we'll use Neon for the database, and then also Modal for the serverless GPUs running in the cloud. So if you would use the links in the description for accessing these services, that would really help out my channel, because that allows me to do this for a living. So I really appreciate that. Cool. Now let's talk about how we can use GPUs for inference, because as we have seen before, we are going to self-host this model over here, and that of course requires a GPU to run, because even though we do have a GPU, it can take quite a while to generate this video, so we're definitely going to need a GPU to run this model. So we're going to use this service called Modal for running these AI models on GPUs in the cloud. So what we can do if we use Modal is that we can access GPUs, we can also develop super fast, and then we can do it serverlessly, which means it is pretty cheap for us, and also it auto scales if your startup or your application scales because you get more users. So basically what we are able to do is that we can take this model over here, then we can create an API endpoint, and then this API endpoint will then run inference with this model, and then we'll just specify which GPU it should run on, and that is that. It is that simple to get the model up and running. So this means we can change out the GPUs which we would like to test it on, and we can get it up and running super quick. So how does it work whenever we run the code during development? Well, first of all, we just write the code for running inference with the model. Then we can run the command in the terminal, modal run main.py. This will then upload the file main.py to the cloud in Modal. Modal will then build a container right here, and then it is going to run our code inside of it. And then the output of the code is going to be shown inside our terminal. So what happens basically is that we write our code locally, we then run the command, the code is uploaded to cloud, run in the cloud, and we then see the command locally as if it ran locally. So it's kind of like if we had a GPU available on our MacBook or whatever computer you want to use, just without having to pay for this huge GPU. So this is super powerful because it allows you to develop as if you had the GPU available locally while you actually don't, which is pretty cool. And then whenever you want to deploy your code, we have already actually tested out that the code is going to work, because this modal run main.py up here actually just runs the code in the cloud as if it was in production basically. So when you want to deploy the code, you just say modal deploy main.py instead of modal run, and then the build container that was built up here is then deployed as an endpoint, and then in the terminal we can then see the URL which we'll need to call to hit these endpoints, which then serves the deployed model that we built up here. So that is kind of how we're going to use Modal in the video, and you'll see more about this later when we actually build the program for doing inference with the model. Cool. Let's just talk about the database then. So we're going to use Neon for the databases, and we'll create 2 databases here. We'll create a database for development and a database for production. That is because whenever we do development, we would like to be able to play around with the data, delete things in the database, etc. So this shouldn't interfere with the production database at all. These should be 2 completely separate environments. So therefore, we'll create a database for each. Then whenever we want to run our program locally, so just test out our program or just develop it basically, then we run our Next.js application right here. So we have a Next.js server running on localhost. And this Next.js application right here then stores data in the development database, and then whenever we want to deploy our app to production, then our Next.js app right here that is hosted on Vercel is then connected to the production database, meaning that all the production data is then stored in here instead of in here. So that is kind of how that works. Cool. Then going down, we can just talk about how we can connect to a database in case you haven't looked into that a lot before. So first of all, you want to create a database. So you can do this preferably for a dashboard because it is just simpler. So you go to something like Neon, go to the dashboard, then you create a database. Then you can copy a connection string, and a connection string is kind of like a long string like this, a long piece of text that contains both where you should connect to and also a username and a password and some configuration options. Then you take this connection string down here, paste it into your application environment variables, so right here, or you specify them in the cell whenever you deploy application, and then your application will automatically deploy to it if you use an adapter like Prisma, for example, for handling the database. So what does a connection string look like? Well, first of all, when you copy a connection string, it looks like this. It contains a protocol. So for example, we'll use Postgres because that is what Neon uses, which is a great database management system. There's also things such as MySQL, for example, or SQLite. So the first part of the connection string will be the protocol. Then it is going to contain the username, which is often just dbuser. It is also going to contain a password after this colon right here. So it will contain a password. Then it is going to say @ and then right after @ it's going to contain the URL where the database is actually located at. So that's just the address of the database, kind of like how we type in a regular URL into the browser whenever we want to open up a URL. And then it's pretty cool over here because a database has a username and a password, just like we already know and use daily basically, but this username and password is just built into the connection string. So instead of having to specify both the database, username and password, you just specify a single string right here, and then everything is taken care of for you by your database adapter. And then also after this place where you connect to, you would then have the name of the database. So this is likely set automatically by Neon. So for example, it would just be called my database, regardless of what you call it in the Neon dashboard. And then after this, you have your query strings over here, which is just some configuration options for how the database should work when you connect to it. For example, if you put in this SSL mode required, which is done automatically by Neon, it will then force clients to use SSL, otherwise the connection would be rejected because it is safer using SSL connecting to it. Also, you can put in this channel binding, which is also done automatically by Neon, which protects against man-in-the-middle attacks. So that is just kind of how a database connection strings work and what they look like, in case you haven't really dived into that topic before. Great, let's just go down to the next part. So let's just talk about background processing, because our application over here is super background processing heavy. So we'll need some kind of way to handle all of this background processing and make sure that it is correctly done in the background. So whenever we would like to create a, not song, but video, it consists of a series of steps. First of all, we would like to get the info required to generate the video from the database. Then we would like to do text-to-speech. This is done in our Modal backend. We also want to submit a job to Sieve, and then we want to do deduction of credits, etc. So these are all steps that are done as part of the workflow to generate a single video. So there's quite a lot of steps involved in generating a simple video. So what we would like to do is take all of these steps right here, then bundle it into a single workflow, and then whenever the user clicks generate in our app, the app should then automatically just execute these steps in the background in a durable way, also meaning that if this one fails, for example, then this specific step is retried until it works, and then the next step after that is then run. So for example, if the server crashes up here, if the Modal server crashes because an error happens right there, then it is just going to retry this step right here until it works. Also, durability over here also means that the state of each step, so the output of each step right here, is stored such that we can resume from where we left off from each step. And this means, for example, that each one of these steps can be run inside a single serverless function of its own, meaning we can kind of avoid these serverless timeouts, because a serverless timeout is only a single minute. So basically, these background processes can run for a long time without us having to worry about these serverless timeouts. So let's just hop down and take a look at the flow again. The user sees the browser, clicks generate, and then the browser where the user clicks generate calls our Next.js backend, which will then call the Sieve AI backend right here. But in between our backend and then the Sieve backend, we'll put in a queue to make sure that the Sieve backend isn't just blasted with requests. And also we want to make sure that our own backend, where we host the Hello Free model, isn't just blasted with requests. And also all of these steps up here, they happen right here where this arrow points. So we would like to make sure that all of these steps right here are handled in a durable way where they are retried if they fail, for example. So we're going to use a queue to fix this problem. So a queue is basically just going to decouple the Next.js backend from the Sieve AI backend, such that this one doesn't call this one synchronously, but this one calls this one asynchronously. So what happens is that when a user clicks generate, we'll take an event and then insert it into a queue, and this queue will be handled by Inngest, which is another service. And this queue is basically just a queue that consists of different elements. Each element is a request for generating one of the videos that we support over here, so one of the features. And then each of these events over here contains information about, or the information required to generate the actual video. So for example, it will contain the S3 keys of the source photos, the script that audio should be synthesized from, or maybe the audio S3 keys required to generate the actual video. And then with this queue right here, we can then throttle user demand or make sure that users can only process maybe 1 or 2 videos at a time, so they don't blast this service over here with requests. And when using services such as Inngest or trigger.dev, we can then automatically just set or limit how many events can be processed at a time per user, and this flag right here is often called concurrency. So this entire thing right here happens asynchronously in the background, and that is what I meant by saying that we decouple these two right here. So this one doesn't automatically call the Sieve AI backend in synchronously. So whenever the ingest queue then determines that it is time to process the next queue because of maybe concurrency limits, then ingest is going to trigger something called an ingest function. And an ingest function is basically just a series of steps that we define. So what we define right here, for example, just in code. And these steps will then just be tried in a durable way. So if one of those fails, it is just going to retry until all of these steps have been executed. So one of these steps, for example, would be calling our endpoint on Modal and then waiting for this hello free inference to finish. Another step would then, for example, be to deduct credits or doing text-to-speech, for example. So all of these steps would then finish, and then the database be updated with the finished result afterwards. So that is the queue which we'll build, and you'll see more about how it actually works in practice whenever we build it out, because it is pretty simple to build out actually. Cool. Lastly, we can just talk about authentication and payments. So we'll use BetterAuth for authentication, and it is pretty good. It is pretty cool because it is the simplest way that I currently know to roll out my own auth. I used to roll out my own auth using services such as Auth.js, but I found that BetterAuth is even simpler, and it also has some pretty cool integrations, such as an integration for Polar down here, which makes everything even simpler. It also integrates very well into our stack, so I'll use Next.js and Prisma because that is what I know and like the best. And one other huge benefit is that we can use a library called BetterAuth UI. And BetterAuth UI basically just handles all UI in the application for authentication. So the login pages, the sign up pages, forgot password, account pages, etc. All of these things are automatically implemented for you already, which is a huge time saver for me. So after setting up BetterAuth like this, we'll then also just set up payments. So I'll use payments with Polar.sh in this video. So Polar and then also BetterAuth has an integration that automatically creates customers in Polar whenever you sign up users, for example. It'll also keep track of the user ID and then couple that with the custom ID in Polar automatically. So it'll just keep the setup super simple and make sure that everything just works without you having to do much of setup. Also, Polar.sh is available in more countries than Stripe, which allows even more of my users to follow the video, which is great. One thing though is that Polar is a little bit less matured compared to Stripe because it is a smaller startup, but generally it is way simpler to work with for the kind of payments we'll set up. So I definitely want to recommend Polar if you haven't tried that out yet, because the times I've tried it, I've really enjoyed using Polar. So that was a little bit more talk about the architecture, so how we're going to handle the processing down here, the background processing, and also the services which we're going to use. Now let's just talk about the AWS setup which we'll create. So in our AWS cloud, we're going to use two services. We're going to use the S3 bucket service and also the IAM service for managing users. So for the S3 service right here, we're going to create two different buckets. And a bucket is basically just an external file storage, which is stored in the cloud, where you can put in files you want to store permanently or temporarily. We're going to create a bucket called HeyGen clone. This bucket will have a list of different directories inside of it. It will have a directory called CVA. CVA is an abbreviation of change video audio. So it is just a folder for storing everything related to the feature change video audio. So this, for example, would be video files and new audio files required to generate one of these change video audio videos. I also want a folder called PTV, photo to video. Here we'll store everything related to this one. So this is the driving audio and photo for doing a photo to video or portrait avatar. Then I would like to have a folder TTS for handling text to speech. So for example, if you would like to clone your voice whenever you do voice synthesis, if you provide a script for portrait avatar, for example, you can then upload a voice file or a voice sample, and then this voice is then put inside the TTS folder, so we know where to find it whenever we want to do text-to-speech. Then we can create a folder called video translation. Video translation will also contain MP4 files, so this is just the source video for translating a video to another language. Then another folder we'll have is one called samples. So this samples folder right here should contain some sample, both photos and also videos that the user can use. So this, for example, would be in the dashboard, as you saw in the intro, where the user can pick between some default example photos or default example voices, instead of having to upload his own photos or voices, if you just want to test out the service, for example, without having to find these voices and photos. And then lastly, I would like a folder called Sieve right here, and this Sieve folder should store the outputs of a Sieve generation. So as I explained all the way over here earlier, Sieve is going to give us this URL right here that has a pre-signed expiration, that is pre-signed and has an expiration date. So I would like to take this pre-signed URL, download the video file down, and then place that video file inside our own bucket over here, and that is under the Sieve directory right there. This means that all the Sieve generations will be placed in here, ordered nicely. Lastly, because this bucket up here will be all private, meaning that this is not for public use, to access any of these files you will need to generate a pre-signed URL. We'll have to generate pre-signed URLs basically every time we would like to show the user these example photos and also voices. And because users might use the dashboard a lot of times, push refresh, and a lot of users might do this at the same time, we would have to generate a lot of pre-signed URLs, for both the photos and the videos. Photos and voices, sorry. So going down here, I would like to create a public bucket that also has the same directory structure for samples only. So this public bucket allows you to just access the files directly without generating any pre-signed URLs. So I'd have the exact same files as right here, but the only purpose of this bucket would only be to just show these sample photos and also voices in the dashboard without generating these pre-signed URLs. So basically the same sample photos and voices as the other bucket. Just by putting these in a public bucket, we won't have to generate pre-signed URLs to display them. And then if a user does decide to use any of these public photos or voices, well then they are also inside the private bucket over here. So we can actually use them whenever we want to use them for generation. Great, so that was the walkthrough of the AWS setup and also the entire setup of the application. So the features which we're going to build and also how we're going to build them. If you didn't quite catch every single piece of theory in here, don't worry, because we'll implement everything and talk about all of these different concepts again and again throughout the video, so you'll be completely fine. So without further ado, let's hop into the code and then start building out the actual project. So the order in which we're going to build the project or implement the code is that first we'll set up the AWS infrastructure. So this is the IAM users, but also the S3 buckets. Next, we'll go back and then implement the endpoints with Modal. So this is where we'll host the text-to-speech model, but also the Hello Free portrait avatar model. After this, we'll then go ahead and build out the actual front end, and then we'll integrate with the Sieve data as well. So let me just start out by setting up AWS just so we can get this done, because we only need to do this once and then it'll work throughout the entire project. So I'll hop into Google, and then I'll search for AWS, and then sign in. So if you do not have an account, you might want to create one, and then I'll just go ahead and log in with mine, and then I'll see you in the dashboard. So now we're inside the AWS dashboard, and then we can go ahead and hop into S3 here. This is where we can create our buckets. So the buckets where we can use to store and also retrieve the data which we'll work with. So first we'll create the bucket, and then afterwards we'll create the users to actually interact with these buckets. So the first bucket is going to be the HeyGen clone right here. So I'll hop back into S3, say create buckets. It should just be general purpose, and then I'll say HeyGen buckets. Then I'll scroll down and just leave the rest of this as it is. Then say create bucket, and then wait for this to finish. Then I think we have another bucket on here as well. We also have the public HeyGen clone, and this is for all our public data, so the things we do not want to create pre-signed URLs to see. So we'll just create a bucket for that too. I'll say public HeyGen clone here. And then I would like to say block all public access, and then set that to false, and then just check right here to acknowledge that we are okay with that. And then I'll say create bucket. And this means that we'll be able to actually display the files through their direct URLs instead of having to create pre-signed URLs to see the files inside this bucket. Whereas all of the items in this bucket, HeyGen bucket, we can't just directly access, so the objects aren't public. Now hopping into Excalibur right here, we can just check out the folders which we want to create. We want to create a folder for change video audio, CVA. We also want a PTV, TTS, VT, samples, and Sieve. So we'll just go ahead and create these now. I'll start with the CVA. So I'll just say create folder and then change video audio. And then I'll create one more. This is PTV. Then I'll create another one, text to speech. And I'll create another one, video translation. And the next one is samples. Create folder. And we then also have Sieve right here. And I'll then click create folder as well. And then under samples right here, we just want to create this sub folder structure where we have the photos folder and the voices folder. So I'll hop into the bucket under samples, create folder, and then say voices, create folder. And then I also want to create the photos folder like that, say create folder. And then we can upload the specific files to these folders, which we want to use later on in the video. So I'll hop under photos first of all, and then I can say upload. And then I can say add files. And then under my downloads folder, I have the following files right here. So I have these three, and then also one of me. So I'll just take these four and then upload these. Then we can just say upload. And if you want to know where I get these three files from, if you hop under hello free, which is the model which we're going to host later on, we should be able to see some of these sample photos. So we have this one and this one and this one. So hopping under, I think it's examples, inference, and then images. We then have the number 8, that is this one. Then I think it's number 9 as well, and number, not 18, I think it's 22. Yeah, so these three photos I downloaded by just clicking this button right here. And then as you saw, I just uploaded them to my folder. You can of course find any photo online if you have permission to use it, of course, or a photo of yourself, and then upload that to the photo, or sorry, to the folder right here. And then you will be able to use it as a default or example image later on when we build out the actual front end. So now we have the actual photos uploaded. If I then hop back under samples, and then I hop under voices, we should be able to just upload some voices as well. To get some voices, I'll go to Google and then search for style TTS set S. And then we can go under this demo right here, because this is a voice model. We won't really use this, but they have some voices which we can download just to test with. So there is Mark Zuckerberg here, for example. So if I just click play here.
So our team developed the first speech-to-speech.
I got the idea to start.
Your capacity to do whatever.
So we can use these voices just to test with. So I can go ahead and click download for each one of these. I've already done this because I've tested with these voices before. So I have them in my downloads folder, but you can go ahead and download the voices which you would like to test with. You can also find some voices of your own, or use a clip of maybe 5 seconds of your own voice if you would like to test that out. So now let's head back to the AWS page under voices, and then click upload, add files, and we'll then just upload these voices right here. So I have these 3 voices and my own voice. I'll just play that.
My name is Andreas,
And then we can just use that to test with in my application. So go ahead and click upload. And then the folder structure should be alright for the HeyGen bucket. We just want to do the same for the HeyGen public bucket as we talked about. So in here we also have the public HeyGen clone. This is a bucket that also needs the samples folder. So that means it also needs the photos and voices folders beneath that, in that. So in the public HeyGen clone, I'll say create folder, samples. And then inside this folder, I'll just say voices. And I'll say photos. In photos, I'll just say upload, add files, use the same 4 photos, click upload. And I'll just do that for the voices as well. So I'll say upload, add files, and then I'll just take these files right here and I'll say upload. So now we should have these files, both the voices and also the photos right here, be public. So we just need to make some changes to the bucket policy before we can do that, because if we take the URL right here, say copy URL and paste it in, we see that we have the bucket name and then we also have samples, photos and the file name. But if we click this, we see access denied. But we really want this to be public because that is the reason we have the bucket in the first place. So we need to modify the bucket policy under, I think it's permissions, and then under bucket policy, we'll then say edit, and then we can add a new statement. So I'll say add statement, and this one should be public read get object, and then the principal should just be a star, so anyone, and then we want the action to be s3 get object, like this, and the resource should then be the actual bucket ARN. So I'll just copy this up here, the ARN of the bucket, paste this in, and then I would like to say /star, which means that we can get the object for any object within the bucket. This means, and this is what we mean with the /star, so anything within this bucket basically. So let me just try and apply this bucket policy by saying save changes. And then if we now hop back under objects, samples, photos, and then just copy the URL of one of these, we should be able to paste it in. And then from this URL right here, which is not pre-signed, see the actual photo. So that worked perfectly fine. Now if I hop under voices, take Bezos, and then say copy URL, and paste that in instead, we should be able to play this voice too.
I got the idea to...
Which we are also able to. So it seems to be working just fine with the public HeyGen clone bucket as well. Then next up, we would like to create the actual IAM users. So under Excalibur, we can see that we have these two buckets, but we also want to create these two users right here. So I can go under my search and then search for IAM. And then I'll just open this up in a new tab just so we have these two buckets available over here. So I have IAM opened here. Then I'll hop under my users, say create user. And then the first one should be called HeyGen backend. So I'll paste that in right there. Say next, and then I would like to attach the policies directly, and we would like to attach the policies for list, read and write for this bucket specifically. So if I go under create policy, we can then just say service s3, and then I would like to say lists bucket. That was the first one, and then we would like to have read object. I think it's get object, like that. And then also put object for writing to the bucket. And then for the actual bucket, I would like to choose a specific bucket. So I'll say bucket, add ARNs. And then hopping under our other page over here, we can take this HeyGen bucket, then go under metadata, I think it's properties maybe, and then copy the ARN, which is the identifier for the bucket, so the ID. Then we can paste that in under the resource ARN, say add ARNs. So this is the bucket which we can apply these actions to. And then we just need to specify that these actions also apply to every single object inside the bucket. So we'll say add ARN, and let me just copy the ARN up here again. HeyGen bucket it is. So this should be HeyGen bucket. And then we should just say any object name right here, meaning that it is any object within this bucket alone. So then I'll say add ARNs, and then going under this, we can say next. And then this policy name, let me just see what we call the user. Under Excalibur should be something like HeyGen backend policy, like that. And then I would like to say create policy. And then I would like to just create one more user now. So actually we just need to apply the policy first. So clicking refresh here, and then just searching for HeyGen backend policy. And then next, we can then say create user. And then what I'll do is I'll say create user, call this HeyGen, and then frontend, like we saw in the Excalibur right here. So frontend, and we'll then say next, attach policies directly, create policy, and then I'll just do the exact same actually. So I'll say s3, and then I'll say list bucket, like that. and I'll say get object, and I'll say put object, like that. Then I will say add arns, and then this should be HeyGen clone, like that. So we just need to spell it correctly, of course. HeyGen clone. Then I can just copy the name here, add the arns, say add arns, paste in the bucket name, and then just say any object name, add arns. And now we should be able to click next. Call this HeyGen frontend policy. And then say create policy. And now we can just attach this policy to the user we were creating. So this will be the frontend policy. And we'll then say create user. So now we have two users, we have the backend and the frontend user. So in case you want to change the permissions such that the backend user has more permissions than the frontend, now you can do that by just going in and then updating the backend policy instead of granting both users the same rights by creating only a single user. So this setup right here with a backend and a frontend user should be fine for our use case right now. So what I'll then do is I'll hop under the browser and then search for Modal. If you use the link in the description that really supports my channel, I'll just search for Modal right here, Modal, and then find this one. And then this is the service which we talked about earlier in the theory, which we can use to run code on serverless GPUs. So if you do not have an account, please head under sign up. Otherwise, I'll just hop to login and then log in with my GitHub, and then I'll see you in the dashboard. Good, so now I'm logged in, and the first thing I would like to do is hop under secrets. So right here, by the way, we can see all of the apps which we are going to deploy. So right now we obviously do not have any, but any apps which we do deploy in the future, these secrets will be injected into. So this means we can define the login credentials for AWS right here, and then the login credentials will be available in any apps which we deploy, and specify that app should have access to that secret. So we can go ahead and say create new secret, and then just say AWS. And then for the region, I'm using the US East one. So you should be able to see your region if you hop under AWS and then click around up here. So the most common one, if you just create a AWS account, is just US East 1, and that is also the one I use. So now we need to define the access key ID and also the secret access key, and these are the access keys which the application can use to query the S3 bucket, for example, or put files into it through the AWS API. So hopping under our users, that is exactly what we created the users for. So because this is for the backend right here, we'll take our backend user. So we'll search for, go into users, say backend, then we can say create access key, and then I'll just say other, next, and then I'll say modal backend, create access key, and then for this access key, that should just be this one. And then for the secret access key, we'll just paste that in as well. And lastly, I just want to add one more field, and then this one should be called S3 bucket name, and the S3 bucket name should be HeyGen clone. And this I just do such that we do not need to hard code the bucket name into the application, but such that we can instead just set this environment variable and then reference the actual bucket name through that. So up here, I'll then say HeyGen secret, and then I'll say done. And then I'll just wait for this to finish. And now we should be able to see our secret. So as you see in this example right here as well, this is some code that is going to run on the cloud on Modal. And over the function that is going to run on Modal, you can put in this secrets annotation right here, so where you specify the specific secret that we just defined. And this means that whenever we want to interact with the AWS API, so put something into the bucket, for example, through this Boto3 client, this Boto3 client can then grab these values, so the access key ID, the secret access key, and also the region, which we defined in here. So that is what that does. Good. The next thing I would like to do is actually build out the first step in creating an AI avatar portrait. So hopping under Excalibur and then going under features right here, we see that the first feature is image to video, so portrait avatars, and we are going to self-host this Hello Free model, but this Hello Free model is actually dependent on another model unless we provide an audio file ourselves. So over here we have these two scenarios. We have one where the audio file is provided and one where the audio file is not provided but the script is. And as we explained earlier, in this scenario we'll have to do one more round trip back to our Modal backend to do some text-to-speech inference, and we're using Chatterbox for this inference right here. So Chatterbox, if we just search for that and then go in GitHub, this is just an open source, state-of-the-art text-to-speech model. It only works in English though. So if you want to do text synthesis in another language, you might want to look for another model which you can self-host, or even another API which you can just call. So to work with this model, you first need to do pip install the model pip package, and then you can just instantiate this class right here, give it some text, so that is just the prompt that should be synthesized to text. Then just put it into a single method call, and then you get out the audio generated under the following file right here. So it is really simple to use, and that is why we're going to use it in this project. So first I would like to hop into the code again, and then open up a new folder. So I'll say folder, and then go on documents and repositories right here. Then I would like to say HeyGen clone. And then inside this folder I'll say open. And now we have our workspace ready. So I'll then hop under my root folder, say new folder, call this backend. Inside the backend folder, I will create a text to speech. So I'll say new folder, text to speech. In here, I would like to say new file, requirements.txt, and I would like another file as well under files. I would like a text-to-speech.py where we can contain all of our code. And then behind the scenes, I've just copied a voice file, which is my voice, to the clipboard. So I'll take that voice and paste it into the text-to-speech. You can just download one of the voices that we took a look at earlier and then paste it in right here. So if we just play this,
My name is Andreas and
you can hear that this is my voice. So this is just to test that this chatterbox model can actually replicate my voice in case we want to test that feature as well. And now I'll just open up this backend folder specifically and then create my Python environment inside of here instead of inside the root folder, because this root folder is also going to contain the frontend. So I'll go ahead and say open folder and then go under HeyGen clone, backend, open this up. Then in here, we can just first of all check if you have the same extensions as me. So what I'll do is in just a second is hit command shift P and then say Python create environment, run this command. But I think you might need this Python extension right here to be able to do this. So sorry, this one right here, or maybe it is this one, Python environments. So if my Python code looks a little bit different than yours, then maybe you need some of these extensions right here. So Python environments, and maybe also pylans for the syntax highlighting, I think. All that is actually for checking the types for Python, I can see. So just make sure you have Python and then also the Python environments installed. Then what I would like to do is just hop back into the folder right here and then say command shift P, create a Python environment, and I'll just pick Python 3.12. That is what I usually use for AI development, 3.12 or 11. Then I'll say OK. And just wait for this to finish installing. Good. Then I would like to just set up Modal. So hopping back into my browser, we can just go under Modal and then docs. And then we just need some kind of quick start. This one maybe. Yeah, so pip install Modal. Then I'll open up a integrated terminal right here. Run pip install Modal. And just let this install. Good. And then now we should be able to run Modal setup. Like this. And I'll then just take this URL right here and then open it up in my browser. So I'll open it up right there. And then I'll say authorize. Like that. And then this should be all fine. And then back here we can see that a token was written to our system, which means that we can now interact with the Modal API, so run our program in the cloud, for example. Then just to test out that everything works, I'm going to hop into this TTS file, and then we can just write a very small program just to test that we're able to run code in the cloud. So if I hop under Modal and then click docs here, we should be able to just see, I think it's examples, hello world. Then we can define this program. So in here, I'll say HeyGen clone. And then the next part is then defining a function that is going to run in the cloud. So this app right here is what is going to show up in the dashboard. So we have a dashboard right here with all our apps. So this is where our apps is going to be shown. And then this is the function that actually runs within this app. And then down here we can test it whenever we want to test it locally. So I can go ahead and paste that in as well. So now we have the following. So let me just go ahead and say remove this parameter and then just say print hello. And then down here we can go ahead and say f.remote. So let me just see like that. And then I can also say f.local like that. And let me just try and run this. So I'll say modal run. And because we're inside this backend folder right here, we're just going to have to say text to speech/tts.py to go all the way from this folder and into this file and find this file, sorry. So I'll say enter and then just see what happens. So now it should be running. And in just a second, we should see the output. Good. So now we have a hello in blue and we have hello in white. So whenever we see a blue output down here, that means that the output is from the cloud or the server. And whenever we have a white output, that means that the output is from our local device. So that is because we run it first of all on the server and then on our local device afterwards. So if you want to run something that is GPU heavy, like inference with a GPU, you can just put that inside this function right here, and then it'll have a GPU available if you let it have a GPU available up here. But if you want to run something locally, you can just test it out with .local. So now we at least know that the things that we wanted to work actually works, because it did run in the cloud. So let's now try and build out the actual program which we want to build. So first of all, I would like to change the name of the app. This should be chatterbox text-to-speech generator, like that. Then we can also define an image. So I can say image is equal to, and inside here we can say modal.image.dbnslim. And if I just close down this file and open it back up, we might be able to see the types actually work. So by defining an image like this, our app up here will actually be run inside of a container. So this container will have the operating system, Debian, and then we'll also set the Python version installed in that operating system, and that will then be 3.11. We will also like some requirements or some pip packages to be installed into our environment inside of image. And we can do that by saying .pip install from requirements, and then we can say text to speech requirements.txt like that. And lastly, we can also install some dependencies into the system that our image runs with directly. So this should be ffmpeg, for example. So we can say .apt install, and then we can say ffmpeg. So this just installs ffmpeg into this Debian image, whereas this command right here installs the actual Python dependencies into the Python environment in the image. Then we can define a couple of more things down here. First of all, I would like to define something called a volume. So if I just close down these pages right there and then hop under storage, we should be able to see that we have some storage options right here. So a volume is a place where we can store files that are accessible by the modal image. So just like we have an S3 bucket up here where we can store our files, a volume is just basically an S3 bucket that is being attached to a modal image, such that we can store things in between different runs. For example, the weights of an AI model, such as the checkpoint for a large language model, because otherwise we would have to download that checkpoint down to this image every time we run it. So basically we just attach an external file system to this image that we run our code inside of, which then gives us some advantages. So storage was the other thing I wanted to set up. I also want to set up these secrets. So right now we have already defined this HeyGen secret, but I would like to actually define it up here as well. So I can just copy this line right there. And then down here I can say s3 secret is equal to modal.secret.fromName. And then by referencing it like this, we'll be able to use it later on to then access the values like we talked about earlier on. Cool. Then as I explained before, right here we have an app.function. So this is the annotation for just running a function, a given function in the cloud. But I would like to actually define a class which will give us some more advantages. So I'll go ahead and replace this with class text to speech server. And then in here I can put in a def load model where I pass in self and just say pass. And I can put in some more functions down here later on. I'll just comment this out for now just so we don't see these squiggly lines. And then just say pass in here as well, like that. Now what I would like to do is to say that everything that runs inside this class, so both this function right here that says load model, not modal but model, but also all the other functions which we define inside the class should have some resources available. So I can use the annotation app.cls for class, then I can pass in the image is equal to image, and this lets Modal know that everything that runs inside of this class is going to run on this image. So we will have ffmpeg available, for example, because we installed that, but also all the requirements in the Python environment available, and the Python version installed is also going to be this one for everything that runs inside of this class. So that was the image. I also want to pick the GPU which we run everything on inside the class. So the GPU is going to be the L40S. And if you hop into Modal right here and then search for Modal pricing in the browser, we should be able to see the different GPUs right here. We're going to use this NVIDIA L40S, which is a really powerful GPU, and it's about $2 an hour, but that is completely fine because we have $30 per month of free credits, so we definitely won't run out of time with this GPU. So these are the ones we have available to choose between. So for example, if you run out of memory on the GPU, you can just pick one that is bigger or have more memory available. But we'll just start up with this L40S just to test things out. Good. So going back here, we have defined this L40S. And then I would like to also define some more resources. So I would like to mount a volume, so attach an external file system like we talked about earlier. And I can see that I actually forgot to implement that. So going up here, I'll just say something like volume is equal to modal.volume.fromName. And then I would like to call the volume Hugging Face cache chatterbox. And then I'll say create if missing, and then just set this to true. This means that if it doesn't exist already, which it does not now, it'll just auto create one for us. Then I can take this volume and then just attach it to everything running inside of this class down here. So I can say volumes is equal to, and then I would like to specify first of all the path which we attach it to. This is going to be /root /.cache /hugging face /hugging face like that. And then I can say is equal to, I can put this in and then say volume right after. This means that the following volume right here, or the external file system, is going to be attached to this path locally in our image. So whenever we put a file inside of this path right here, it is also automatically going to be synchronized to the volume, and we'll then be able to see the files that were put inside of the volume under the storage menu right here in the Modal dashboard. Another thing I actually found out that is super cool is that we can store files directly inside the S3 bucket by mounting the S3 bucket to this image as well. So if we hop under this, we can say /S3 mount, and then we can say :modal and then cloud bucket mount. Then we just specify the S3 bucket which we would like to attach to our image. This is going to be the HeyGen clone. And we can then also say secret is equal to S3 secret like that. So this means that any file that we put inside of this S3 mount folder inside of our image down here in our function is automatically going to be copied into our cloud bucket, so HeyGen clone in our S3 bucket automatically. So whenever we have done synthesized some speech to text, we can just take that file and just copy it into the following folder right here. And then this means that it'll automatically just be copied into the S3 bucket without us having to upload it manually through the Bodo free client. I'll then also just make the secrets available. So I'll say secrets is equal to modal, and we also actually have them defined up here. We can say S3 secret right there. So we can also define a scale down window. So because this is a serverless function being run, we can define how long the container should stay warm for between requests, after requests, and we'll set this to 2 minutes. This is a trade-off because you'll need to pay for these 2 minutes of the container staying warm. So this is a trade-off that you'll have. We'll just set this to 2 minutes because we have the free credits anyways. Cool. Next thing I would like to do is that whenever we get a request, this load model is going to be ran first. So I would like to actually load the actual AI model into memory. So we can hop into the Chatterbox GitHub again. So this one. And then we can go ahead and first of all say pip install chatterbox-tts. So if I just say open integrated terminal, pip install chatterbox-tts, And then I'll also just take this chatterbox-tts requirement and put it into the requirements.txt, which is what is being installed by the image. So let me just do that and save. I'll also just put in Modal and also FastAPI for now. And I know we're also going to use a library called Pedantic, like that. So we'll just keep these in here. Good. Then I'll hop into the text-to-speech server, and now this is installed. So let me just go ahead and close this down. Then what I'll do is I'll say print loading chatterbox model ... And then I can say model loaded successfully, like this. And then between these, I can actually go ahead and load the model into the GPU memory. So we do this by calling the following command right here. So this will set the chatterbox-tts model, and let me just import that. So hopping up here, we should be able to say from chatterbox.tts import chatterbox-tts, like this. And this will then instantiate the class which we can use to load it into memory. So this will also load it into memory for us because we set the device to CUDA, and CUDA means we try to run the model on the GPU and not the CPU. So because we're inside the class and I would like to use this model in another method, I would like to say self.model to make it an instance variable instead of just a locally defined variable inside this load model class. Also, whenever this runs for the first time, so chatterbox-tts.from pre-trained, it is going to download the model automatically down from Hugging Face and then into this Hugging Face cache on our local system, or sorry, not on our local system, but inside the local system in the cloud, so in the image. And because we have attached the following volume to this path, this means that whenever this has been downloaded for the first time, it is going to be automatically cached for both this function run, but also any future function runs that requires using this chatterbox-tts model. Next, we can define an actual endpoint. So if I say define and then generate speech like this, then I can say self because we're inside a class, and I can then define a request. And then also we can define a response which we're going to respond with. So to define the schema of both the request and also the response, we're going to use a library called Pedantic. So we'll say pip install Pedantic, like that. And then just when that is installed, we can go up here. And then I would like to say class and then text to speech request. And we'll inherit from a base model from Pedantic. So we'll just need to import that. Then we can say text, that is a string. We can also say voice s3 key, that is an optional string as well. And we'll set that to none per default, and we'll just need to import this optional from Pedantic or from typing. So what this does is that it allows us to define the schema of the request. So we say we only accept requests that has the following schema. So we say text to speech request. This also means that whenever we work with the request inside of this endpoint, we can then also have the request be type safe. And the request contains a text, so that is what we want to synthesize. So for example, this text could be hello world, and then the audio clip generated says hello world. And this voice s3 key is optional because it is only supplied if we want to clone a specific voice. But if we want to clone a voice, this s3 key should point to a place in an s3 bucket, so an audio file that contains a voice sample. And this is also one of the reasons why we mount this s3 bucket to our endpoint as well, or to our image as well, because this means that we can get this voice s3 key, or sorry, this voice from its s3 key directly from this s3 mount, which is pretty cool. So next we just want to define the response as well. So I can say class and then text to speech response will inherit from the base model, and I'll say s3 key and I'll say string, like that. So what do we return from the endpoint? Well, the user provides some text to synthesize, and then we'll return the path to somewhere in the s3 bucket where the synthesized audio clip is in. So that is why we return an s3 key. And then of course down here, this shouldn't be written this way. It should be voice s3 key, like that. And then we can define that down here. So we'll say text to speech response. And then inside this function, and we'll just need to annotate that as well actually, to make it an endpoint, we'll say modal.fastAPI endpoint. And then we'll say this is invoked via the post HTTP method. So we'll say post. Then down here, we can go ahead and say Let me just close this down. Print, and then received request to generate speech for, and then I'll put in it is request dot, so we'll need to make this a formatted string like that, request dot text. And this is just for debugging purposes whenever we test out the actual endpoint, because we'll be able to see this printout in the Modal dashboard logs. Now we can get ready for inference, so we can say with and then torch, and I'll just import torch up here. So I'll scroll all the way up and just say import torch like that. Then we can say torch.noGrad, and below this. And the reason we are putting in this torch.noGrad is because we aren't training, we are running actual inference, so we don't need gradient tracking. And that is basically what we said when we say no grad. Cool. So in here we can first of all check whether we received this optional voice s3 key, so whether we should clone a voice or not. So I'll say if request dot and then voice s3 key. So if we did receive a voice, we can then say print using voice cloning with s3 speech prompt dot dot like that. Then I can go ahead and say audio prompt path is equal to, and I'll make this a formatted string. So s3 path slash requests dot voice s3 key. And I messed up right here, and it's actually s3 mount. So s3 mount is where we attached the actual s3 bucket to our image. So this means that if the user did send along a voice s3 key, so an s3 key pointing to somewhere in our bucket, we can then determine the full path in our local image to that item, and that is going to be the s3 bucket, because that is where we attach the bucket to, and then also the actual s3 key of that item. Next, we can check whether the file actually exists or not, because even though it is optional, we need to check whether this s3 key actually exists. So the way we're going to do that is by beneath this saying if not os dot, and we'll need to import os.path dot exists, and then we can say audio prompt path. So if it does not exist, then we'll raise a file not found error, and then just say prompt audio not found at, and then just put in the audio prompt path like that. So if no error is thrown, then we can safely assume that the audio prompt path actually contains the file that was referenced. So that means that we can actually do the inference right beneath this. So cool, the way we do inference is by saying modal.generate, and we save the model under self.model. So we should be able to say VAV, so that is going to be the audio file, is equal to self.model, and then we can say dot generates, and I would like to then put in the target text, that should be the request dot text like that, and then also the audio prompt path, which would be the audio prompt path. So if a voice has been provided for cloning, then we are passing that in. So we are then only calling this right here if a voice has actually been provided as well. So we then need to call this again just outside of this if statement if a voice has not been provided. So right below this, I'll go ahead and put in an else statement, and then I'll say print using basic text to speech without voice cloning dot dot dot, and then I can say VAV is equal to, and then we'll just take this entire statement and paste it in, but just remove this audio prompt path since it is not there. So the audio is actually also saved on the or created on the GPU, so we'll need to move it to the CPU before we can save it to a file and then put it into the S3 bucket. So down below both these if statements, because any of these if statements are going to create the VAV variable, so we know that it is going to be available. So right after these, I'll say VAV CPU, so this is going to contain the audio just on the CPU instead of on the GPU. It's going to be equal to VAV.CPU like this. So we move the tensors to the CPU instead. Next, I want to take this and save it to a buffer such that we can save it to the disk ultimately, which is inside the S3 mounts. So we'll go ahead and say buffer is equal to IO, and we'll need to just import IO. We can then say dot bytes IO, Under this we can say torch audio, which we'll just need to import as well. So we'll see, go into the terminal, say pip install torch audio, like that. And I just need to import it because I already have that. And then I'll say .save, and we can put in the buffer, we can put in the tensor on the CPU, we can put in the sample rate, self.model.sample rate, and we can put in the format, which is going to be VAV, like this. Next we can put in buffer.seek 0, we can put in audio bytes is equal to buffer.read, like this. So this will rewind the stream to the start after this torch audio.save has written data and then left the cursor at the end. And now we can take this buffer, which contains the raw VAV bytes, and actually save these to the S3 mount in a file. So we'll go ahead and say audio UUID, and then just give this file a name that is completely unique. So we'll put it into a string, convert it to a string. And then I would like to say UUID, which we can just import like this, .UUID 4, like that. It'll just generate a UUID, so that it's just a series of random numbers like this that is always going to be unique. Beneath this we'll put in the S3 key, which will be the TTS folder, so text to speech folder, and we'll then put in audio UUID.vav as the name. We can then say S3 path is equal to, and then I can put in S3 mounts, like this. So we'll write it to the S3 mounts, and we'll then just put in the S3 key as the specific place we write it to. I'll then say os.make directories. I can then say os.path.directory name, and then I'll put in the S3 path, and we can say exist okay is equal to true, so it won't throw an error if it does exist. So we have actually already created this /TTS folder, but it is still pretty good practice to put this in just in case. And next we'll actually take the raw audio bytes and then write them to the S3 mount up here. So we'll say with open, and then we can say S3 path /WB, which is an abbreviation of write binary. So we can write our files to this our bytes to this file. We'll then say SF, and we can then say f.writes. And then we just pass in the audio bytes from the buffer up here. And lastly, we can go ahead and do a log like print saved audio to S3, and then just put in this S3 key. And we'll just need to make this a formatted string before that works. And then now that should work good. Lastly, now that we have the S3 key and we have saved the file, we can go ahead and actually return a response. So we'll say return text to speech response. And we'll then pass in the S3 key as the S3 key, like that. And that should then be the entire endpoint actually. So now I would like to hop down to this local entry point, and then instead of just saying f.remotes, we can actually take this endpoint and then try to test it out. So the way we test this endpoint out is as if it is actually already deployed. So we'll need to make a request to an endpoint that corresponds to this name right here. So first I'll just go ahead and say import requests like this. Beneath this I'll say server is equal to text to speech server. And then right now we don't really know what the URL for this endpoint actually is, but we can get the URL such that we can make a request to it. And the way we do that is by saying endpoint URL is equal to server dot and then generate speech dot get web URL like this. And that should then give us the URL which we can call. I also just want to make some request data, so I'll say request is equal to text to speech request, because remember we created the class earlier. And then for the text right there, I would like to say hello from Modal. This is a test of Chatterbox, like this. Cool. And then we can also put in a voice S3 key in case you want to test that out. I'll just go ahead and hop into the S3 buckets right here, objects, and then we can go under samples, voices, and then just pick this one right here, my voice, and then I'll just copy the S3 URI. So we'll need the following right there, that is the S3 key. So we can then say voice S3 key, and it is going to be samples voices myvoice.vav. Then we just gotta prepare the following data for the request. So we can say payload is equal to request data request dot and then model dump. Under this we can make the actual request, so we can go ahead and say response is equal to requests dot post, because remember we made a post accepting endpoint up here. So we'll say dot post, then we can put in the endpoint URL. We can also put in JSON is equal to the payload, and below this we'll put in response dot raise for status in case any errors happens. So if any error happens up here and we get a wrong status code back that isn't 200, we will get an error raised right here in our local entry point as well. So we can then say results is equal to text to speech response, where we destructure the response into by doing this. Cool. Then we can say if results, or actually I'll just say print and then something like results dot s3 key, yeah, because that's the only thing we'll return anyways. Good. So I'll just take this and then I'll say open integrated terminal, and then we can just hop up 2 times and then say modal run text to speech .tts. So when I run this for the first time, it might take a while because right now we haven't built the image yet. So whenever you define an image up here, it'll need to build an image which it can run as a container later on. So this means that it'll need to build an image with both the Debian operating system, but also it is going to need to install all the requirements and also FFmpeg, for example. So it'll need to build the entire image, which can take some time. But whenever that is done, we only need to wait for this to finish the first time, basically. So whenever you make a request after this, it is going to be already built, so we won't have to wait for all of this to happen next time. So I'll just wait for this to finish and then we'll see what happens. And I actually just remembered while it is installing that we forgot to install this torch audio. So all of the requirements that is being installed inside the image have to be defined inside this torch or inside this requirements.txt. And we forgot to put in the torch audio. But now we have it. So now we should be able to rerun this command. And then because we changed this requirements.txt, that should invalidate the cache right here. And then rerun this command and all the commands coming after that. So whenever it is done here, I'll just go ahead and run it again. So it just finished up right here and we just got an error. So let me just check what the error actually is. It says internal server error. So I'll just try and scroll up and then just see what happens. So failed to mount the cloud bucket, failed to create S3 client, and then HeyGen clone. The bucket does not exist. And that likely makes sense because if I hop in here, we can see that it is called HeyGen buckets. So let me just take this, let me just see if I use this anywhere else. HeyGen clone. So we'll just need to replace this with HeyGen buckets. And then we already fixed this in here by adding torch audio as well. So I'll just try and rerun this command now. So I'll hop down here, modal run text to speech /tts.py, and then just let this finish again. So it just finished up and I see we have another error right here. So scrolling up, text to speech server has no attribute model. So I'll just say self dot model and then try and figure out why that happens. So we use model, and I think I know why up here. We forgot the decorator. So we'll need to say modal.enter like this, because otherwise this won't be run before any of the FastAPI endpoints are hit. Because remember, we'll need to load the model into the class instance variable right here before we can use it down there. Alright, so let me just try and run the command again, and then let's see if it works now. I just forgot to save, as I can see, so I'll just save and then run the command again right here. So I'll just wait for this to finish and then we'll catch up. So it is still running, but at least we didn't get the error anymore. We can see that it says sampling and there is some progress going on. We can also now see that the audio was saved, which is pretty good. So the endpoint didn't fail and it seemed to be working just like it should. Now, if I just copy this key right there, and then I hop into my HeyGen buckets, go under text to speech, we can then see the audio file. So I'll just go ahead and download this audio file by clicking download, and then I'll open it up in Visual Studio Code. So here the audio file is. Let me just try and play this.
Hello from Modal. This is a test of Chatterbox.
So this was apparently my voice with the text-to-speech model saying hello from Modal. This is a test of the Chatterbox. So it seems to be working just fine, which is perfect for us. Right now though, when deploying this endpoint, anybody is able to call it because we haven't really secured it with any tokens or anything. So I'd like to create some authentication to make sure that just anybody can just call this endpoint. So what I'll use is something called Modal proxy tokens. So proxy tokens, proxy auth tokens it is called. So here we can hop into the dashboard and then create some proxy tokens. And then whenever you call the endpoint, if we have specified that it should require proxy auth tokens, we'll need to send these proxy auth tokens along in the headers, otherwise the request is going to fail. So hopping into the dashboard right there, and then under my profile, and then if I go under proxy auth tokens, you can then click this new token. Then we'll take this token ID. For now, I'll just hop down here, and then right over the request maybe, we can go ahead and just say headers, and then is equal to, and then going back here, we can see that it's called modal key and modal secret. So I'll just copy these two actually and then paste them in. Make both of these strings, both for the keys and the values like that. And then we should be able to pass in the headers. So I'll say headers is equal to headers. Then up here in the actual requests, we can go ahead and say, I think it is right here, requires proxy auth is equal to true. Then let me just check out what happens if I do not provide this. So if I just say modal run again, then we'll just test out the code. Then it should give us a 401 client error, unauthorized for URL. Then if we do provide the actual tokens with the headers, we can see that we're able to step into the actual endpoint and see the logs of the endpoint. So the proxy auth tokens work fine now, and we just need to remember that whenever we do call the endpoint from the client, we just need to pass down the proxy auth tokens as well. So now I'll go ahead and deploy this endpoint. So whenever this is finished, we can go ahead and do that. So now it's done, and I can go up and say modal deploy instead of modal run. And this should then deploy the actual endpoint like this. And this URL right here is then the URL which we can use to call the actual endpoint, which we defined right there, generate speech. Next, we can begin implementing the portrait avatar. So I would like to say new folder, photo to video. Inside here, I would like to put in a file, ptv for photo to video.py like this. I'll just take the same requirements file as in here as well and paste that in. We won't really need this chatterbox-tts or the torch audio, but we'll just leave the rest of this as it is. Then I also want to take the contents of tts.py and paste it in under ptv. And then that will at least give us a starting point, because we'll need a lot of the same logic, such as building the endpoint, loading the model, etc. So first I'll go up to the start where we define the actual app, and I would like to call this hello free portrait avatar. And then going into here again, we should be able to find the hello free repository right there. So hello free is where we can get a photo to speak. So let me just try and play one of these. So as you see right here, the photo is speaking, even though it was just a photo given a script, which is pretty cool. We'll need to first of all clone this down, and then we'll need to install some requirements. These requirements come from this txt file right there, and these requirements are required for the actual hello free model to work. We also are going to need FFmpeg, and then also a couple of other things. I can also see that we need to download some pre-trained models, and these are inside a Hugging Face repository where the model checkpoints are right there. So we'll need to install all of those as well, and we'll need to organize them in the following folder structure. So those are the things we need to do to get the model to run. So let's try and go ahead and do that. First, I'll take all the requirements and copy them. And then I'll just hop back into my own requirements from not text to speech, but photo to video right here. And then I'll just paste them in right below our existing requirements, which are the ones that we have defined. Good. Then we should not install the requirements from text to speech. We should install the requirements from the photo to video folder instead. And we are also going to need to install some more system dependencies. FFmpeg is not enough. So first of all, we're going to need git, because we need to clone down a repository with git clone, as we saw right there. We're also going to need some other dependencies. We're going to need something called clang, and also libAIO def, like that. So I've previously tried to run this model right here without these libraries where it failed. So therefore we need these as some runtime or maybe some build time dependencies for this hello free model, which is a little bit more heavy and more complex than the text-to-speech model, which is also why we need all these different requirements as you saw, but also these libraries for C++ compilations. We are also not going to use the Debian Slim operating system in the image. We're going to use .from registry like this, and then we'll take an NVIDIA base image like this / CUDA like that. CUDA 12.1.1 development version, Ubuntu 2004, and then we'll say add Python 3.12, let me just hit the right button, 3.10 like this. And then whenever this base image is installed inside the image that is being built, it is going to ask in the terminal for setting up a couple of things, such as what country are you in, what time are you in, etc. So to make sure that the terminal doesn't get stuck whenever the image is building, we can add in an environment variable, which we can do like this, called Debian Frontend. And we'll set this to non-interactive. And this will make sure that this terminal won't be prompted during the build of the actual image and get stuck because of that. So this right here should set up what we need to just run hello free, but we also need to actually download it. So I'll take this command right here, and then I would like to run that command in the build step whenever we build the image. So I'll say run commands, then I can put in git clone and then clone this right here, and I would like to clone it to a folder called hello free. Then right after this, we can go ahead and download the model checkpoints. So what I would like to do is first of all download the model checkpoints to a volume, so we don't have to do it every single time we hit the endpoint. So this volume I'll download it to should be called hello free cache like this. So I would like to just say volumes right here is equal to, and then I would like to say we would like to bind to models. This is our location in the image or in the container that the checkpoint is available at, and then we would like to bind the following one, volume, like that. Then we can just create a function which we can run after this run commands that clones down the project, which will then download the actual model checkpoint down. So right here, as we can see, it doesn't automatically just download it down because we have this git command which only downloads the project, and then we'll need to use these commands down here to then download the actual checkpoints down. So we'll need to just do that manually. So down here under volumes, I'll say def download hello free models. Then I can say from Hugging Face Hub. So you might want to say pip install Hugging Face Hub to be able to do this. Import snapshot download. Then we can say snapshot download. We can pass in the repo first of all. That should be something like fudan, I think this is the one. Yeah, fudan-generative hello free. So that is the repo. This one, which we want to download the model files from, and we would like to download it to the local directory called, and this should be the model volume path. So we'll have models / pre-trained models like this. So this is where we download it to locally, and then we just want to say ignore patterns, nothing, so we download all the files down. So to run this function as part of the build step of the image, we can go ahead and say .run function, and then I would like to run download hello free models, and I would like to make the volume up here available such that we can download into that volume right there. And as you see, the volumes is already set up right here such that it attaches to the correct path inside the container of the image. Right now though, the models when downloaded right here, downloads into the models, pre-trained models folder. So this models folder is part of the volume, but it is not actually inside this hello free folder containing the actual models. Not the model files or checkpoints, but the code for running the model. So to use the actual model, we'll need to make these model files available inside hello free / pre-trained models. And they also say something about that right here. So it needs to be available inside the pre-trained models right there, which is then inside the hello free folder. So we'll need to create a link between the pre-trained models inside the volume and then the pre-trained models, which doesn't exist right now, inside this hello free project. So to do this, we can create a symlink. So I'll say run commands. I can then put in ln-s, and they can say we'll create a link between models and then pre-trained models like this, and between hello free and pre-trained models like this. This means that when the program running hello free, which is defined inside this GitHub repo right here, tries to get the model files from hello free / pre-trained models, it actually reaches into models / pre-trained models, which is where we actually store the model checkpoints. So now we have defined the image that we need to actually run the model, and we can go ahead and try and define the inputs and outputs of the endpoints, which are going to be used to actually run the model. So the inputs for this should not be text-to-speech request. It should be, what do we call it up here? We called it the portrait avatar. So I'll say portrait avatar request. And then going into the repo over here, we can see what it actually takes under examples inference, and then input.txt. These are multiple different inputs for the model. So we can just look at one line, which is the input for running a single of these inferences. So we have a description. So here we have a little girl talking around a campfire. So hopping into the images, that is the one right there, a little girl talking around a campfire. Then there is also the image that should be referenced, and there is some audio that should drive the mouth movements of the image. So that is what we're going to receive over here. So because we don't have a description of the image available like we did right here, so for example a little girl talking around the campfire, we basically only have the image and then the transcript that we want the image to say available. We're just going to put in the transcript instead of some detailed description, just because we do not have it. And I have tested this without this actual description and it works completely fine. So I would like to put in the transcript right there as the first parameter for the request. Then I also want to put in the photo s3 key. This is the photo which we would like to talk. And I also want to put in the audio s3 key, which is the s3 key for the driving audio, so what the image should say basically. And as you might be able to guess, the response right here, the portrait avatar response, should contain or should return the video s3 key like this. So just an s3 key pointing to some video, which is the finished result of what it has generated. And then down here we can go ahead and set up the actual resources that the class should have available. So I'll call this portrait avatar server, and then I'll just go ahead and remove this function right here, because as you can probably see over here, we won't be able to load in the model as elegantly as we was with the chatterbox model. So scrolling down to where the model is used, let me just see that, run inference. So that is down here. This will then run inference with the inputs from input.txt. So while it is possible to change the code and then load the model into memory in an inter function like this to then keep the container warm with the model loaded into memory, it is not as elegant as it was with the chatterbox. So to keep things as simple as possible right now, we're going to load the model into memory on each request and just use their provided script for loading the model into memory and doing inference at the same time. Therefore, I'll just go ahead and remove this .enter function, and then we can go ahead and get started with the resources up here and then the endpoint afterwards. So first of all, this model uses quite a lot of VRAM in the GPU. So I'll pick a GPU called A100, 80 gigabytes, just so we have 80 gigabytes of VRAM available. Then I'll just remove this Hugging Face volume right here because we aren't really using Hugging Face. We're downloading the model down manually. So I'll just scroll down again to down here with the resources. And then under volumes, I'll just make sure we use the volume which we defined earlier on. So that is the volume right here. So we need to have this volume available because we have the symlink between our volume and then the hello free pre-trained models folder so we can access the checkpoint. I'll just go ahead and remove the scale down window right here because we aren't loading the model into memory on some unload function anyways. But I do want to set a timeout though, so I'll say timeout and I'll say 2700, so that is going to be 45 minutes. And I know this is a lot, but this is also a photo to video model, so this model generates video. So these kinds of models take a long time to generate. They take maybe 10-15 minutes, but if you have very long videos, they might take all the way up to half an hour or 45 minutes. So this is just to avoid us getting any timeouts after having waited for maybe 30 minutes and then losing all progress, for example, because that really sucks. Cool. Then we define some other request types. So this one is portrait avatar request. And here we have portrait avatar response like that. So first of all, I would like to print out the parameters which we receive from the request. So I would like to say received request to generate video, and then I'll just generate video like this, or maybe a portrait avatar. And then I'll just print out the different parameters. So we have the request.transcript. We also have the request dots and then photo as free key, and we also have the photo, or not photo, the audio as free key like this. And because we have these this S3 bucket mounted right here, we can then check whether the S3 key for the photo and audio actually exists in that bucket. So I'll go ahead and just remove at least this, because I know we aren't going to use this. And then right below this print, I would like to say temporary directory is equal to temporary file like this. Just import that dot make dear temporary. So this temporary directory right here is both to store this input.txt file which we're going to generate to actually run inference, but also to store the output of the model. And then because this is temporary, we're just going to delete it afterwards when we have uploaded the file to the S3 bucket through this S3 mount. But first, let's find out whether the files exists or not. So I would like to say photo path is equal to a formatted string s3 mounts slash, and then I can say request dot photo s3 key. I'll just copy this down and call this audio s3 key, and this will be audio path. Then I can say if not os dot path dot exists, and we'll then pass in the photo path. Then we can say raise file not found error, and I would like to say photo not found at photo path, and we'll just do the exact same kind of guard statement right below, where we just pass in the audio path instead, and then we also put in the audio path right there. Next, I would like to create the inputs for the model, and remember, to run inference with the model, we need to run this scripts slash inference long batch.sh script, and then we need to feed it this input.txt file. So we already took a look at how that looked. So going into this is for giving it 6 inputs at a time, but we just want to give it a single input. So we want to create a format of input where we give it a single line of text, and then the path to the image and the path to the audio. So what I can do to do that is just to create that file basically. So I'll say input txt path is equal to os.path.join, and then I'll put in the temporary directory because that is where we'll store it at, slash input.txt. So we'll create a file input.txt under this temporary directory. Then we can say with open input txt path, and we'll set it to write mode as file. Then we'll say file.writes, and then I can put in a formatted string where we say request.transcript, so that is the text. And then we had to put in these two right there, two @ signs. Then we'll put in the photo path @@, and then we'll put in the audio path, and then say @@ right after that as well. Or actually, we do not need to do that. I'll just make a new line though instead. So now we have the inputs for the actual model. Then we can go ahead and say print generating video with hello free like this. Then we can say output directory is going to be equal to os.path.join temporary directory and output like that. Then we can say os.make directories, and we'll pass in the output directory, and exist OK is true, so we don't get an error if it doesn't exist. So this just makes sure that we have this output folder right here whenever the output of the model is being created. Next, we had to actually run this script. So going back, let me just find the script down here. This script is the following right there, bash script. So let me just copy this, and then under this I'll say command is equal to a new string of a new array of commands. I'll put in bash as one for itself, and then comma, and then we have the hello free, which is where we downloaded the GitHub repository to, /scripts /inference long batch, and then we'll just take these two right here and make them commands of their own. So this will be the input txt path, and we also need to pass in the output directory. So it's going to look something like this: bash, the script, input, and the output. Bash scripts, inputs, and outputs. So that seems to work out just fine. And then to run actual inference, we can say subprocess.run, and we can pass in the command, say check is equal to true, and we can say change working directory to hello free to run it from the hello free folder. Next, we can go ahead and say print processing finished, because this right here should then run inference, and this should take maybe 10-15 minutes, so it's going to take a long time, but then after that is finished, we'll see processing finished just to make sure. It also doesn't tell us where it generated the file at, so we know that we generate the file inside this output folder right here, but we don't really know the name of the file. So we'll need to search the output folder, and because there is only a single output folder inside the temporary directory, it should be pretty simple. There's only going to be one file, but we still need to search the output folder to find out the actual name of the file. So I'm going to say generated video file is equal to none. Then we can say for file path in global. So we'll just need to import global.global, and then os.path.join the output directory, and then I'll put in 2 stars, and I'll put in star.mp4. So these 2 stars right here means match every directory depth, and this right here just means that we're looking for mp4 files specifically. And then we can also say recursive is equal to true. So recursive like that. It still needs to be outside, so it's a parameter for the global and not for the os.path.join. Good. Then if any of these files are found, we're going to see the path for that file in fpath variable right here. So we can then say generated video file is equal to file path. We'll then break the loop because we're only looking for one, and also there's only going to be one. And in case this is none because it was not set, aka it was not really found, we'll then say if not generated video file, then we'll erase the runtime error and say hello free did not produce a video file like this. So the video file produced right here is likely not going to contain any speaking, but only the actual mouth movements. So we'll need to merge the audio, which we already have from the audio path right here, with the video that was produced. So that is what I'm going to do down below. I'll say print merging the video and audio with ffmpeg ... or maybe not. And below this I'll say final video path is equal to os.path.join the temporary directory with final video.mp4. The final video will be an mp4 file, which is this video right here, and then also the audio over there. So to do this, we can use ffmpeg. So we'll say ffmpeg command is equal to, and then we're going to first of all say ffmpeg, and then we'll specify the flag input, which will be the generated video file. We'll specify another input, which will be the audio path. So that is the audio we should merge. We'll then say dash C and B. And that should be copy. So this will copy the video stream without re-encoding it. Then we can say dash C, CA, like that. And then say AAC. So the audio is being re-encoded to AAC, which is standard for MP4. Then we can say shortest. So it will finish encoding when the shortest input stream ends. So if the audio, for example, is shorter than the generated video file, then it'll end encoding the new video whenever the audio finishes, if that makes sense. Good. Then I can lastly pass in the final video path, which is going to be the output of this entire operation. And then we can actually run the command. So we'll say subprocess.run ffmpeg command, and we'll say check is equal to true. Then we can say print, make this a formatted string, final video created at final video path. And all we then need to do is take this final video path and then make sure to copy that video into the S3 buckets. So this is called photo to video, which is the folder we created earlier in the S3 bucket as well. And it is an MP4 file, not a WAV file. And I'll just call this video UUID instead, like that. Then I'll just remove this part right here because we aren't writing any files right now. We just want to copy a file. So first I'll say saved video to S3, and then I can also say shutil. So we'll just say import that shutil.copy to copy a file, final video path to the video S3 path. That's going to be the S3 path right there. So we'll copy it from the temporary folder to the S3 path, and then we can return the the portrait avatar response like this with the S3 key. Now you might think that we have this leftover file that just takes up space on the system, which is right in the output directory right here. So I just want to make sure that that is always deleted. So the way we do this is by taking this entire thing right up till here, and then we wrap it inside a try catch. So we don't really need the catch, but I'll put in a finally, because regardless of whether it fails or not, I would like the temporary directory to be cleaned up. So I can say finally, I think something is wrong. This try will need to have an indent removed. And then up here, we will need to indent it once more. So I'll just say indent right there. And then going down, the finally just needs to be indented as well. And then in here we can say if os.path.exists temporary directory, then I would like to say shutil.remove tree temporary directory. So if this succeeds up here, it is still going to remove it, but if it fails, it is also going to remove the temporary directory, just so it doesn't take up space, because over time we might have some of these temporary directories that are left over because they failed or something, and that is just going to take up space and then maybe cause an error in the future. And then we can go ahead and test it out down here. So I'll say server is equal to the portrait avatar server, and this should then be the not generate speech but generate video. So I'll call this generate video. Where is it at? Text to speech right there. So now we have the endpoint for that as well. Then we'll need to make a portrait avatar request, and then we are going to need a transcript. The transcript I'll just set to nothing right now, like that. And then we're going to need a photo S3 key, and then also an audio S3 key. So let me just try and find two of these. Hopping into our buckets, we should be able to hop under samples, and then photos, and now I'll just take my portrait right there, copy the URL, this should be that one. So I'll pass this in as the photo, and then for the audio, I'll pass in my voice as well. Samples voices, my voice, so that is already set up completely fine. Good. We'll leave this as it is with the headers because we still have the proxy tokens enabled up here, securing the endpoint, so that is perfectly fine. The response needs to be a portrait avatar response though, and the S3 key down here is still the same. S3 video, S3 key, like that. Good. So let me just see if that is what we also returned up here. That is video S3 key. So we'll need to pass that in instead of the S3 key, like that. So this right there is what it should look like. Now remember, inference will likely take a long time with this model right here, even though we only have a couple of seconds worth of audio. So we might need to wait for some time, but that is completely fine. Good. I'll just hop back right here, and then we should be able to see the live app in just a second. By the way, we can see our chatterbox-tts generator, which is our deployed web endpoint. So this is deployed right here. We can then say any calls that we would make to it right there. And we can also delete the deployment right there if we wanted to. Good. So now I want to hop under Open Integrated Terminal. Then I'll press up a couple of times till we find a command to run it. So I'll say not text to speech, but photo to video. And then this should be PTV for photo to video. Then I would like to say enter. And then we will likely get an error because I have forgotten something. But let's just see what happens whenever this is done building. So we get this error right here with no matching distribution found for PyAV. And I looked into this. So if we go into requirements.txt for photo to video, we should be able to remove this right here because it isn't being used anyways. So if we run this again, let me just see what other error comes up. So we're getting this error right here. So scrolling up, we can see that something is not available. clang++ is not available, no such file directory, but we do install it right here. So what goes wrong? Well, this yellow text right here is actually pip install from requirement running, and that is running something that uses clang to build a wheel, I think. But because we are installing clang after the requirements, it is not available. So if we install clang before installing the pip requirements, then it should hopefully work out. So let me just try and switch these around, run it again, and then just wait for this to finish. Alright, so I just got an error again after building for a couple of minutes here. So this is the chatterbox-tts import, which I forgot to remove. So I'll just go ahead and remove these imports, which I'm not using, just to avoid these kind of problems again. Because this download hello free models will then import all the imports up here during the build step, because that is used during build right here. So that is why it failed. And since we do not have Chatterbox installed in here, like we did otherwise, because we aren't really using it, we would get a missing module. So down here, I'll just run it again now that Chatterbox is gone, and then hopefully it should work this time. Good. So now it has been running for a couple of seconds, and now we see this download hello free model is actually working. So it says fetching 35 files, and then we see a percentage progress bar over here. So this actually means that it is running this successfully now. So this is as far as we have come so far in the build step, which is pretty good. So this means that we're actually downloading the model checkpoints. Whenever this is done, I'll come back and then we'll take a look at what happened. It has been going for maybe 5 minutes now, and it is still only at 49% right here with fetching the files. So just so you know it, if it takes a long time for you, that is probably why. So now I think something is happening. So let me just see what's going on. So this is just part of the regular inference logs. So you don't really have to look at these unless they give you an error. So let's just wait for these to finish and then we'll catch up. So it finished up over here, and we can see that the total execution time was 1200 seconds, which is about 20 minutes. Then over here under apps, and then our app. So if I just say stop apps right here, and then the one we just ran, we can then see that it also took about 20 minutes. If I then just click on this one right here, we can then see that the final video was created under this path, and that we have the following UID as the file name. So let's hop under the HeyGen buckets. So right here is the bucket, and then we can go under our photo to videos, and then we can see the one right here that matches the one from the logs. If I then click download, I'll then just try and open it up in Visual Studio. Alright, I have it open here, but there's something wrong. So as you can see when I play it, it is all distorted in the background and my face kind of changes. So let's try it out.
My name is Andreas and this is my voice.
So I think what might go wrong is that it is not able to see me very clearly in the picture because of all these red lamps. So that is pretty interesting to know. It is pretty lucky though that we have the other examples available from the S3 bucket. So we can just go ahead and try one of those out. So maybe you already tried one of those out and it worked completely fine. In that case, that is great. We just happen to use a bad photo of me on my local machine. So you likely had another photo anyways, instead of this portrait that I use of me. So let me just try and take this other one that is photo number 8, and let me just try and use that instead, because maybe that gives me better results. So I'll just try and do that. So I'll paste this in instead. I'll still use the same myvoice.vav because that should be completely fine. And I should then be able to run the actual program again. So I'll go ahead and say modal run photo to video and just try it out again. So this will take a while, as you saw before. So I'll catch up with you whenever this is done. The program just finished up here as well. And then if I hop under the newest one and then say download, I'll just go ahead and show you the results. Here is the video, so let's try and play it.
My name is Andreas and this is my voice.
So as you can see, this looked way better, and also the mouth movements were way more aligned with the actual audio. So what I think happened is that the red colors kind of distorted how the AI model found the person in the photo or something like that, because it was kind of a weird photo with some colors that I'm not sure that the AI model has been trained on a bunch of. So since I won't really be able to use that as an example photo or a default photo for actual users, because we do offer this model out, I would like to just go ahead and remove that from the sample because it isn't really a very good example. Or I'll actually just leave the photo as it is right now because I want to test it out with the Sieve data API as well to see if their model performs better than ours do. So we have just deployed this single open source model, but this other open source model that Sieve offers might handle the edge case even better. So I just want to test it out before we remove the example. So without further ado, let's hop back into the code. So now that we got this to work, I want to just deploy the model actually. So I'll say modal deploy, and then just deploy this thing right here. And then this should be ready for integration with the frontend, so for use by the client, through the following URL right here. Next up, I would like to go ahead and create the following feature right here, and that is the last one which we'll create within our modal backend. So the last endpoint which we'll define. So as we talked about, whenever Sieve generates something for us, it is going to give us a pre-signed URL so we can access the file, but it does contain an expiration parameter up here, which means that we can't just use this URL forever. So I would like to take a URL like this containing a file, then downloading it into a container, and then uploading it into an S3 bucket such that we can own the file forever. And that is what we'll do with a modal endpoint. So hopping over here, I would like to close these two down, and then I would like to copy the text-to-speech one because that is the simplest one. And then I would like to call this Sieve to S3. In here, I would like to first of all remove my voice. And then under requirements, it is going to be very simple. We only need pedantic for the request and response schema. And then we also need FastAPI. The rest of these we'll just go ahead and remove. Then under text-to-speech, I'll just call this Sieve to S3 like that. And then we can go ahead and define the actual application. So for this app, I'll call this Sieve file to S3 like this. And then I would like to just say apt install and then curl, because we want to use curl to download the file down to the container. And then we'll just call this Sieve to S3 just to install the requirements as well. Good. We don't really need a volume because we don't really need to store anything outside of the S3 mount. So I'll go ahead and remove the volume. The secret I'll leave as it is, but I'll just redefine the request and response quick. So this should be Sieve import or something like that. Sieve import request, and then Sieve import response. And then the request should just be a simple URL to a file, so video URL, and the response should be S3 key like this. So that is going to be the S3 key to where we are now storing this temporary URL in a more permanent storage solution. We of course also can just remove this volume down here, remove the GPU, because we don't really need a GPU just to download a file with curl and then upload it to an S3 bucket. That is way too much. I'll then just go ahead and remove the scale down window, and then I would like to say timeout, and then something like 600 seconds, so 10 minutes, just in case it is a large file or something like that that would take a long time to download. This probably should never happen in theory, but just for making sure we don't hit these timeouts if they should happen. Then I'll call this Sieve importer, And I'll remove this modal.enter because we aren't really loading any large language models or AI models in general into memory. We're just downloading a sample file and that is it. This will then be the Sieve import request, and this will be the Sieve import response. And then over here, I'll just go ahead and remove that. And also, let me just remove these as well. So the first thing I would like to do in here is to say, and I'll just go ahead and say video ID like this actually, because we can just reuse the same logic. And then right here, we'll say video ID, and the folder which we'd like to place the file into is Sieve. And then this should be MP4 because we generate videos. And lastly, the S3 path matches fine. We put it into the mount, which will transfer it into the S3 bucket. And then instead of this down here, so I'll just go ahead and remove this line right there, and then also say Sieve response. Then I would like to try and download the following URL, video URL, and then put it into the S3 key, into the bucket at the S3 key location. So I can go ahead and say try. In here I'll say command is equal to, and then we'll put in, and I'll just make these square brackets. Then I first want to use the curl command followed by the -l. So the -l is just to follow HTTP 300 redirects. Then we can go ahead and say --fail. We can say --proto defaults. So this will just exit on 400 or 500 error pages instead of trying to download whatever is on those pages because there are nothing on them. And then if no scheme, so HTTP or HTTPS is then provided, it'll just set it to HTTPS by default by doing this. We can also say --retry to retry up to, let's say, 3 times. We can also say retry delay and then just say --, and I would like to retry with 2 seconds in between each. Then we can say -o, like this, -o, which is the file path will write the response by the 2. So this should be the destination path. So that is going to be S3 path. And lastly, the URL which we would like to download from, and that is just the request.url like this. And now we just need to actually run the command. So we can say sub process import that.run. We'll then say command, and we can say check is equal to true. And then if something actually goes wrong and we get a partial file or something, I'll just say except exception. Then I would like to just remove that corrupt file, because if it goes wrong halfway through, we might get a corrupt file or something. So I'll say if os.path.exists, then we can say the S3 path at that location. Then we'll just say os.remove, and we'll just remove the S3 path like this. And we'll then just also raise just so we get an error in the program. Good. So that should be enough for this simple service right here. Now I just want to actually test it. So we'll go ahead and say test URL is equal to, and then something. And then what I would like to do is just to test one of the sample files. So it should work with any URL really, but I would like to just take one of the sample files. So maybe we go into the public bucket and then see if we can copy a voice maybe. So if I take this one and then say copy URL, let me just see if that is fine. If that is completely fine, then we should be able to copy that from the public bucket into our HeyGen bucket with this service. So we'll just paste that in right here. Then we can change this to Sieve importer instead. So Sieve importer, which is what we call our class, this should be not generate speech, but instead something like import video. Then going down again like that. And then for the request, this should be the Sieve importer request. Here we put in the URL. So I'll say video URL is equal to test URL. Then these things should be the same. And here we have the Sieve importer response. And for the response, we have an S3 key like that. Good. So let me just try and run this service. So I'll say modal run Sieve to S3 / Sieve to with underscores to s3.py, and then I'll just test this out just to see how it goes. So about 5 seconds in, it is building the image like here. And then we get this file not found error, no file or directory. So the first thing I'd like to do is just scroll all the way up. Then I'll take these imports, which we do not have installed, and just remove these just to make sure that these do not cause any problems. So that one, and then the ones we just had right there. And the requirements, we only have these ones you see. I also see that we do use underscores right here instead of the dashes like we do right there. So I'll just put in 2 of these instead, and that is likely why the file was not found, because it did happen in the build step because it is with yellow. So now let me try and rerun this command, and then hopefully it works this time. Good, so just finished up right here. We can see that something was downloaded and then put into the following location in the S3 buckets. So let me just hop into the bucket, go under Sieve, and now we're able to see our file. So remember also that we did take a voice, so a .vav file, and then we did save it as an MP4 file, so we might want to rename the actual file extension whenever we do download it and test it out. So if I just go ahead and say download right now, then in my Finder right here, I'm able to see the actual file which we just downloaded, and I can't really click play because it isn't supported when we have an audio file that has the wrong extension. So we'll just go ahead and rename this to WAV, like it should be, and then say use WAV, and now if I play it,
I got the idea to start Amazon 16.
This matches the audio file which we copied from the public buckets. And because we only pass this service actual video files, so that MP4 files from Sieve, we don't have to do this manual rewrite anytime. That is only because we tested it with a .vav audio file, because we didn't really have a video file available in the public bucket. So that is just why we did that little trick. So now that this service is ready as well, let me just go ahead and say Modal deploy, and then just deploy this code too. And that should then give us the free endpoints which we were talking about from the theory section. And we can then also see this endpoint right here for the import video endpoint. And now everything is actually built that we need to implement this first feature right here, which is image to video portrait avatars. We have both the scenario where we provide an audio file, the scenario where we can provide a script, and then we also have the service which can copy from Sieve and then over to our own file storage whenever we want to implement Sieve as well. So that is pretty good. So now let's hop back into the code and then start building out the front end. So to set up a simple Next.js application, I'll just go ahead and initialize it with the T3 stack like I usually do. So hopping onto the T3 stack and then just copying this installation command, we can say, and I just need to hop outside of this backend folder because we aren't in the root of our project right now. So I'll say open folder, and then right here I'll open it up, and then I'll open up a new terminal right next to backend, and then I'll say npm create t3 app at latest. Then I'll just call this the front end, Typescript, Tailwind CSS, no to tRPC, none for the authentication. Then I would like to say Prisma, yes to app router, and I would like to say Postgres SQL because we're using Neon, remember. Then ESLens, and no to the GitHub repo, and yes to npm install. Here I'll just click enter. And that should then set up the entire front-end structure for us right here, and also install the npm packages. And now we can just try and get it to run. So first of all, if I hop under package.json, we can see that it opened up this npm scripts menu as I did that. So if you right click right here and then check on npm scripts, you should be able to see this menu whenever you have package.json clicked. Then I can say npm run dev, that should be right here. Just click the play button, and then we should be able to see the application start up. So I'll just use this or show this in split screen from now on. So now we see the split screen, and if I then click Control or Command and then click right here, we should see the application opening up. And I'll just remove these tabs, this one, and this one. And now we're able to see the application which we just initialized. So it's running on localhost, which is our local server down here. And this is going to be the starting point for our entire front-end application. So first I would like to set up the environment variables. So I'll hop under environment variables right here. And then right now we just have a default database URL. So I'll just leave this until we have Neon set up. And then we can go ahead and say modal key is equal to, and then we'll just take the modal keys from one of the services where we just had it for testing. So this is a modal key. And then beneath this we'll say modal secret. And this will then be the following right here, secret. Good. Then we just need an AWS access key ID, and we need an AWS secret access key ID, and we'll get these. We actually just can set the region to. The region, like I explained earlier, is going to be US East 1, and the S3 bucket name is going to be HeyGen buckets, like that. Cool. So now we just want to create an access key or a set of access keys for our front-end user, because we already have one for the back-end user. So I'll open this up over here, go to users, HeyGen frontend, say create access key, other, then I'll say Next.js frontend, just so we know what it is for. Copy the value into the access key and also the secret access key environment variables. Then I'll just hop back in here, and then I would like to define the endpoints. So here we can say text to speech endpoint is equal to, we also want the photo to video endpoint, and we also want the Sieve file to S3 endpoint, like this. So the way we can get these is by hopping under the Modal dashboard right here. And then the text to speech is going to be the chatterbox-tts generator. So we'll click this, and then we can grab the endpoint from right here. So I'll just copy this URL and then paste it in under the text to speech. And then for the photo to video, that is going to be our hello portrait avatar endpoint. So now I'll copy that endpoint too. That is this one. We can also take the Sieve file to S3 endpoints and copy that URL as well, like this. And that should be it for connecting with the backends. So these are all the values that we have so far. So let me just click save and then hop under frontend, source, environment.js, and open this up in a side-by-side view. Good. Then I would like to fill this env.js file out such that we can access all our environment variables in a type-safe way, and then also make sure that they're actually included whenever we compile and deploy the application on the SIL. So first I'll take this modal key, and then everything that you define in here is only available on the server. So modal key should be a string. So this will validate compile time that it is a string, and then only make it available on the server afterwards. So we have the modal key, the modal secret. We also have the AWS access key ID. We have the secret access key, the region, the bucket's name, and then we have 3 endpoints right here, there, and these are also URLs. So we can just go ahead and use the Fluent API to make sure that they are URLs as well. So we'll just go ahead and do that. Then down here we need to specify which of these environment variables point to which of the one that we defined up here. So what we can do is we can say, we'll just copy this one, and then I'll start by pasting in the modal key. The modal key should correspond to process.environment.modal key. Then for the secret, we'll just do the same, and I'll just copy this down a bunch of times. We'll say secret key, access key, secret key, region, bucket name, text to speech endpoint, photo to video endpoint, right there, and also right there. And then lastly, the Sieve file to S3 endpoints. Good. And then we can just delete this last line. Good. And now whenever we want to access our environment variables, we're able to do that through this environment.js structure right here, which ensure both the types and the presence of each of these values. Then hopping back into our application. So let's go to the dashboard and then just hop over here. The app still works just fine. Now I would like to set up the database, which is Neon. So I really appreciate it if you use the link in the description for Neon, because it really supports my channel and let me do what I can do. So I'll just hop to Neon right here and then search for Neon serverless Postgres. then I would like to log in. If you do not have an account, you can go ahead and sign up, but I'll just log in, and I usually do that with my GitHub. So I'll see you in the dashboard. And now that I'm logged in right here, we can go ahead and create a project. So I would like to call this HeyGen clone. And then I'll just say Frankfurt, that is possible. Europe Central 1 Frankfurt, because that is the one closest to me. Then I would like to say create. And then we can see that we have a production database, but I would like to create a branch for development as well. So hopping under branches, we can see that we also have the development branch actually, with the parent being production. So maybe it just had to just create. And then because this is our development database, or sorry, our development project, I would like to say connect under development. So we'll say connect. Then we'll grab this connection string. So all of this except for these two ticks right there. And then we should be able to hop back under our environment variables and then paste it in instead of this database URL right here. So this is going to be our connection string like we talked about in the theory. If I then just click save and then go over here, we should then be able to go under tables. And then right now we have 0 tables because it is a completely empty database. So right now, if you go under the Prisma schema.prisma, we can see that we have this table called post, for example. So if I go ahead and say db push, this should then push this database schema to the database which we're connected to through the connection string. So over here, if I then refresh, we now see this post table with the columns also defined in schema.prisma. And this is basically how we can make changes to our database. We make changes in the schema.prisma, and then we can either make a migration or push directly to one of the branches over here. So in just 2 minutes, we were set up with the entire database, which is really cool in my opinion. Good. Now we can move on with our application, and I would like to start out with authentication. So we'll use BetterAuth for authentication. So I'll say installation, and then npm install BetterAuth. So if you right click Frontend and then say open integrated terminal, make sure that your path right down here is Frontend, because you can only install this, or you only should install this inside this Frontend folder. Then I'll say install, and then BetterAuth should be added to our npm packages under node modules, like that. And then we just need to create this BetterAuth secret. So hopping under environment variables, then we can just hop up. Let me just do it over right there. BetterAuth secret, and then we'll just generate a secret. That is this one. Paste it in, and that should be good for BetterAuth to use. And then I'll just put this inside 2 quotation marks like this, and then also add this BetterAuth URL. So I'll just copy this in straight away, and this matches perfectly fine. HTTP and then localhost. And then next up, we can go ahead and create this auth.ts. So going under source and then new folder, library. Under library, we'll say auth.ts. Then I would like to put in a Postgres connection that looks like this. So we just need to copy this in and then just import pool from the correct place. And actually, we do not need to do this. We are using the Prisma adapter. So this one down here is the one that we should copy in. So make sure you select Prisma, and then you can just remove this import and then just import it correctly up here. So instead of Prisma, it is going to be database, which we can import like this, because the T3 stack already created an instance of the Prisma database, which we can connect to the database through and query the database through. Then we'll just need to say Postgres SQL here instead of SQLite, and then we're good. Now, going down to create database tables, we can say BetterAuth CLI generate. So if we check out the schema.prisma right now, we only have this post table, but putting this in, that should then change all of the contents of the schema.prisma file to include the correct, let me just wait for this to finish. So let me just see if it changed the schema.prisma file already. It did not yet. So I'll just go ahead and stop this command and then just try and rerun that. I don't really know what went wrong. So let me just rerun the command, say Y for yes. And now we can see that the file was successfully overwritten. So under schema.prisma, we now both have the post, and I'm just going to delete this post table because we don't need that. That is just an example. But we now have a user table We also have a session table, we have an account table, and a verification table. We don't really need to touch these at all because they are used by BetterAuth, so just leave them as they are. But we still need to go ahead and push these tables to our database. So we can say db push, and then over here in Neon, if we then refresh, we are able to see our 4 tables like this. So hopping back into the guide now, we can scroll down authentication methods. So I would like to enable email and password. So going and copying this line right here. Then right below the database, we can paste in this email and password. And then scrolling down again, let me just see what else we have. So we use Next.js. So we need to create an API route, which BetterAuth can use to work. So we'll go under source app, and then we'll create a new folder called API. So this is how we create API routes with Next.js. Then we'll say auth to create a a part of the route called auth. Then we'll say new folder .all. Then under all, we'll put in route.ts. Inside here, we'll just copy the contents of this file and just fix the import by just clicking command dot and adding the import. And that was it for this route. Now going down, we need to create a client instance, which we can use to call sign in, sign up, get the user from the session, etc. So we'll just copy the following file contents, hop under library, create a new file called auth client.ts, and then paste in the contents of the file. I'll just go ahead and remove this base URL because it is optional whenever we're using the same domain. So I'll just go ahead and remove this and also this dictionary right here with options. And that should then be it for the setup. Now to set up the actual pages which we can use to log in through, we'll use something called BetterAuth UI. So I'll search for BetterAuth UI like this. And then we should be able to see that we can see the sign in, sign up, forgot password forms, etc. So under demo, this is basically what we'll get for free. So sign in, sign up, etc. Cool. So we'll just go ahead and install this too. We must have ShadCN installed, so we can start out by installing that. I'll hop under the get started Next.js, and then I would like to just install ShadCN. Remember to put in npm right there, and then we can paste in the installation command like that. I'll say Y to proceed, and this should then install ShadCN, neutral, and that then installed ShadCN. Good. Then going back, we need to configure Sonar as well. So this is also a ShadCN component. So we just need to install this Sonar component, and then we can take this toaster and then add it into our layout.tsx file. So hopping into layout.tsx right here, we just need to add in the Sonar component. And what Sonar does is that basically if you click right here, it shows a toast like this. And that is probably used by BetterAuth UI since we need to install it. So I'll hop under children right here and just paste in the toaster. And then I'll say command, comma, and then import it from components, UI, Sonar like that. And then I'll hop back into the BetterAuth UI documentation. And then I'll go down to the installation now. So first of all, we need to install it in the following way. So I'll paste it in right there. And then in the meantime, we can go ahead and copy this command. So we'll need to find the global.css file. So we'll search for CSS. We have the global.css file right there. And then I would like to just import it up here. And then we can hop over to the Next.js integration. And then we need to configure these things. So we'll need to set up a provider and also put some things into the layouts. We need to wrap the children with the providers. And then after that, we can go ahead and set up the authentication pages, which will then take care of both the sign up, sign in, magic link, forgot password, sign out, etc. and all of these different things. I'll start out by creating this providers.tsx component. So I'll hop under my components in the source folder. That is, let me just close this down, source components, and then I'll say new file, providers.tsx, then paste in the component. Just remove this import right here and import it from the correct place, which is the following one. And then down here it says once configured, wrap your layout component with the providers component. So hopping into the layout again, I think this is the one right here. We can then wrap both of these with the providers component we just created, like that. And then going down, we can then set up the authentication pages. So I'll create this route segment. So I'll hop on the app, and then I would like to create a route segment so we can have multiple route layouts, because I would like a route layout for both the normal pages when you are logged in, but also for the pages when you are not logged in. So I'll say new folder and then say auth. And I would also like to create a route segment for main, like this. Then under auth, we can go ahead and just define the following path. So we'll need a folder called auth view, like that. And we also want to put in the page.tsx like this. Then we'll copy in the contents right here, like that. And then that should cover these following routes. So let me now try and go ahead and go to the login page. That should be the sign-in page right here. So I'll just copy this URL, hop over here, and then paste this in. And right now it says this page could not be found. So going over here again, we can see that we forgot likely to put in this auth right here. So we have the group. Inside of this, I'll create a new folder called auth, which we can then drag this auth view folder into. So we have auth and then auth view. And then let me just try and refresh over here now. So now we see the form like we were supposed to. But right now we can see that it is aligned in the top left, which doesn't look very good. So I'll just hop into the documentation again. And then I'll try and find the GitHub so we can just see which classes he put on to make it look better. So if I hop on the layout, he likely put on some classes right here. So we need to put on the flex, the minimum height of the small viewport height, also flex column, and likely also item center and justify center to center the things. So hopping under the body, we can say class name, and then minimum heights, screen, view, small viewport heights, flex, and then he put on flex column, like this. We also want to put on the justify center and the items center as well, like this. And then everything is centered up as it should be. Now I just want to take this layout file and copy it into this auth route segment right there, just so we have a layout for the auth specifically. And then I'll also just take this layout and then move this into the main, and then just empty out this entire page.tsx just to clean that up. And then I'll just return home or something like that. Good. So now we have a layout for the main routes and also for the authentication routes. So we likely want to apply a specific layout with breadcrumbs or something, or maybe just a sidebar in general for the route when you're logged in. But whenever you're logged out, we just want to keep it super simple and just have a layout that looks like this. I also just want to hop up here and then just say HeyGen, or whatever you want to call your application, for the title and description. And I'll just do this in both of the layout files, right there and also right there. This means that up here it should now say HeyGen, and you can also just switch out the favicon if that is something you would like to by changing this favicon.ico instead of using the default one that is inside the public folder. So this one. Good. So let me now try and create a protected route, and then we can test the login feature. So hopping under main, I'll just go ahead and drag this page, copy this page into the main right there. And then this will just be a server component, and I'll just call this page. In here I would like to say const session is equal to awaits, and then auth, we just need to make this async as well. Await and then auth, we can just import that .api.get session. Then we can get session by passing in the headers, like that. And we'll just need to import this. Then we can say if not session. Then we redirect to the auth page, which is auth/sign-in, like that. And then redirect, we'll just import. Otherwise, we'll say return, and then something like logged in. So this route right here is just going to be the first route. So if I remove everything, the default root route is just going to be the route that we see right here. I just need to remove this page.tsx though, because otherwise we'll have two conflicting routes. So now if I do go ahead and log in, I should be able to access this route, but if I'm not logged in, I shouldn't be able to access it. So if I just remove this, it'll redirect me straight away to auth/sign-in. So it looks like the authentication is working completely fine. So let me just try and sign up. So I just created an account now, and now we are logged in, and we can access this route right here. If I also hop into the Neon console and go under user, we can see my user right here. So it looks like it works completely fine, which is great. Then we can go ahead and add a sidebar to the layout right here whenever you're logged in. So we'll just search for ShadCN sidebar and then go in here. And then we can start by installing the sidebar into the project. So we'll install the sidebar, and this will install the component into right under components right here. And this should allow us to use a sidebar. We'll just need to add these to the globals.css too, as far as I can tell. So under, let me just find this layer base, I'll just paste them in down here, and that should be good enough. Good. Then going down, we are going to need a component called app-sidebar.tsx, and then we can use that inside the layout.tsx file. So I'll take this app sidebar, go under components, say new file, app sidebar.tsx, paste in the component, and we just need to import this from the correct place, which is UI/sidebar, and add the rest of the missing imports, and then hopping under the layout.tsx file. So let me just close down all of these so we have some more space. Then I'll hop under the layout for main specifically, and then I would like to add the sidebar. So previously I'd gotten an error where the toaster threw an error or something in the console because it was rendered out after the children like this, which is kind of weird, but I looked into the GitHub issues on ShadCN and found out that I could put a toaster first like we did right now, and then I would avoid that error. Maybe they fixed it, maybe they didn't, but at least I'll just keep the toaster as the first thing right under providers so I know it'll work. Then I can put in the sidebar provider like that, and then I'll just say defaults open and set this to false. False like that. Then I'll just go ahead and say children, pass it in like that. And then under this, we can put in the app sidebar. So right above the children, I'll say app sidebar like that. Then I'll just hop into the layout now and see what it looks like. So right now we still don't see the sidebar. So I'll under this app sidebar put in a sidebar inset. Here we can say, I'll just go ahead and import this. Then I would like to say class name, flex hide screen, and flex column. Save that. And then just to test out that it works, we'll just go ahead and set the default open to true and refresh over here, just so we can see that the sidebar does pop out. So it does work like it should. And now I just want to revert it back to false and then create a trigger for the sidebar up here in the breadcrumb menu. So I would like to, inside this sidebar inset, put in a header. This header should have the class names bg, background. I also want sticky, top, set 10, border, bottom, px4, and py2. If I then save, we should be able to see something up here. If I put anything into it, such a paragraph that says hello, like this, we're now able to see some kind of little top header, which looks pretty nice. Then right under the header, I'll just take these children and then I'll move them inside the sidebar inset, and then I'll put it into a main instead. Then I'll just say class name flex1 overflow y auto, save that. And now the children are inside the sidebar inset, meaning they are wrapped inside of this layout, so both with the sidebar. So if I set this to true and then put something inside of this header as well, like hello, then it looks like this. So the contents of the main page is going to be pushed aside by the sidebar and also pushed down so it doesn't overlap the top bar up here as well. So that is exactly how I wanted it. Then I'll set this to false again, and then I'll keep on implementing the header. So the first thing I would like inside this header is a div. So I'll put in a div, and then in here I'll say class name flex shrink 0 grow items center and a gap of 2. And then right inside this, I'll put in a sidebar trigger, like this, save that, and now we have a trigger to open and close the sidebar. Then I'll just go ahead and say class name, and then margin left -1. So see how it moves a little bit to the left now, so it's a little bit closer to the sidebar. I think it's too far away how it was initially, so that is why I moved it a little bit to the left. Then right next to this sidebar trigger, I'll put in a separator, which we can import from the components here as well. Then I'll say orientation, vertical, and I'll also say class name mr2, and I'll say h4, and then it still doesn't show up here, so I think we might have to override how it was done by the author. So we might want to say orientation is equal to vertical, and then say h4 then, like this. So let me just see, we need to put in this square bracket, and now we overrode how it was in this specific configuration, and then we're able to see the height of 4 now with the vertical separator. Then I just want to implement the breadcrumbs as well. So if I just search for ShadCN breadcrumbs, then I can go ahead and install this component too. And then what I'll do is I'll hop under the separator, then I'll put in the breadcrumb, and then also a breadcrumb list, like this. Then I'll put in a breadcrumb item, and then lastly I can put in a component which will make that will show the actual correct breadcrumbs. And the reason I'll make a component for this is because I want to keep them inside a client component. Right here we have a server component, so we can't use a hook such as use path name to determine which page we're currently on, so therefore I'll just do it inside a client component. So in here I'll say new file, breadcrumb page, I'll say breadcrumb client.csx, then I can say export defaults function breadcrumb page client. In here I'll just make this a client component, and the reason I make it a client component is because we can use this hook called use path name like that, and this will allow us to get the current path name, so the URL up here which we're currently at. Then I can say return breadcrumb page, like that, and in here I want to say if the path is equal to just the regular / just the root, then I would like to render out the text home. Otherwise I would like to render out the text creates, and I'll just put in create right there. So if we're on the create page, then it should just render out creates. So this is the way you can render out breadcrumbs in case you want to do that. I'll just take this breadcrumb page client and move this into the breadcrumb item over here. So we'll just need to import that like that, import it, and now we see home. And in case we were under a create page, for example, right now we haven't implemented that, but if we went to a create page like this, then it would render out a create instead of home. Right now though, the sidebar doesn't really show anything, it just shows an empty sidebar. So I'll just go ahead and modify this sidebar up here in the app sidebar so it shows what I wanted to show. So inside the sidebar, just go ahead and remove everything, and then I'll start by putting in some sidebar content like this. Inside the sidebar content, I'll put in a sidebar group. Inside the group, I'll put in a sidebar group label. In here, I'll put in a paragraph. So let me just see if we didn't import this. I'll put in a paragraph that says HeyGen, or whatever you would like to call your application. It looks very small and pretty bad now, so I'll just go ahead and revise that. So I'll say class name. Then I'll start by putting in text primary, margin top 4, margin bottom 12, flex, justify, center. Let me just save this. Then we can say px2, text free Excel. We can say font black to make it really bold. And we can go ahead and say tracking widest. We can also say uppercase like this. And now we have something that kind of resembles a logo. If you want to use a real logo, you can just go ahead and design one in Photoshop or something like that, and then just use an image, but we'll just use some text just to get started quickly. Then we can get started putting in the buttons for the actual sidebar. So right now this sidebar is a server component, and we also just want to make it async since it's a server component anyways. And then under this label right here, I'll put in a sidebar group content like that. In there, I'll put in a sidebar menu, which we'll just import. Then we'll create a client component for the sidebar. So now I'll say sidebar, create a folder for this specifically, which I'll drag the app sidebar and also the breadcrumb actually into, so we can order our components a little bit better. Then inside the sidebar, I would like to say new file. And then we can say sidebar menu items.tsx, like this. In here, we'll make it a client component. And I would like to say export default function sidebar menu items, like that. And then we'll just say return, and then just return a paragraph saying hello or something like that. Then going into the sidebar, we'll just need to update our imports. So if we just go ahead and remove this, and then just update the imports like so, that should be fine. And then under layout as well, I'll just go ahead and remove this and update the import to the correct one, like that. And then we have one more error, so that is in this one, where we'll just need to import this from the correct path as well. Cool. And the reason we had to revise all those or change all of those imports is just because we changed where we referenced them from by putting that place into a folder. So right now, so then all of those relative imports didn't really point to the correct places anymore. Here we'll just need to put in type variant props instead of just variant props. And we might have to do the same for the Sonic component right here, like this. And then I see that we have no further problems. If I do refresh over here though, let me just see if it resolves. So we have this error right here in the layout where it can't import what it was supposed to import. So let me just see why that is. Alright, so I just found out what it actually is. So going up here, we can see that we have this import, and it doesn't really show that this is the error. We can only see it in runtime. So I'll just go ahead and remove the import. Let me just show you why. We have components and breadcrumb client, but actually it should be components sidebar breadcrumb client. And then if I save, I'm able to see that it works completely fine like it should. Good. Then hopping back into the app sidebar here. Oh, sorry, I think it was the sidebar menu items. We can go ahead and just implement that. First, I would like to get the path name again. So we can say const path is equal to, and then put in use path name like this. Then I'll say let items be equal to, and then these should be, each one of these items right here should be an item in the menu. So each item of course has a title. The title should be home for this one. It should also have a URL so we know when it should be active or not. So when it should be having a different background. So for example, if you're on the home page, we should activate one of these so we know that we are on that specific menu item. Then we'll say icon home, and we'll say active false like this as well. And then below this items, we can go ahead and actually set this active flag depending on which route we are on. So I'll go ahead and say items is equal to items.map item ... the item. So we'll take the rest of the properties of the item and then leave them as they are, but we only want to modify the active item, and we'll set it to whether we are on that URL or not. So for example, right now we are on the root URL, so this root URL is going to match this URL right here, and therefore the active flag is going to be true. But if we are on the create URL, for example, like this, create, then it would not be true right here, it would be false, so therefore the item would be not active. Cool. So down here in the actual HTML, we can go ahead and return a React fragment. Then I'll say items.map to loop over each one of the different items. So let's say you want to have a create menu as well. we'll then just copy this so we have one more, and then just call this create, for example. So that is how you add multiple different menus. So after items.map, we can go ahead and say item, and then for each one of these, we'll render out a sidebar menu item. This one should have a key, and the key I'll just set to the item.title. And the reason we want to set a key is because we are inside a .map, so we need to set some specific key so React knows how to differentiate between the different items that are being rendered out. Then inside this sidebar menu item, we want to put in a sidebar menu button as well. And then I would like to say as child, and I'll say is active. That should be dependent on the dot is active flag. So I think it is just active actually, like this. And then for the content of the button itself, it should just be a link, just a next link with the href item.url. So whenever you click it, it just takes you to that URL. And then we'll put in an item.icon as well, which you can do this way. And right below this, we'll put in a span with the actual title. So it should then, if I refresh over here, and actually we just forgot to use this sidebar menu items. So hopping back, I think we want to put it in right here and just import that. So now we're able to see the actual menu item. And then just hopping back in here, let me just show you what would happen if we added one more. So if you put in crate and then something else like a book, I don't know, something like that, then right now we can see that it is not active, but when we hover it, the background changes. So we know that we have to make this active, aka highlight the background, because this URL right here matches the URL that we're currently on. So that is how you add more of these items. Good. Closing this down, we can go down under this sidebar content, and then I'll put in a sidebar footer. Inside this sidebar footer, I would like to put in a div first of all. This div should contain a view that shows how many credits the users have left, but also an upgrade button. So I'll just go ahead and make a comment where I say credits, and then another one where I say upgrade, because right now we haven't implemented the payment or anything. We also haven't implemented the credits in the database. So I'll just leave this as it is actually. And then right below this, I'll put in a user button from this BetterAuth UI library again. Let me just close it up correctly, like this. So it is going to look like this down here. If you just hide this, we have this user button. And then we can just change this a little bit. I'll say variant outline. And then I can save this, and now it becomes the same color as the existing background. And then at one point, whenever we have the payment solution ready as well, we also want to put in an additional link that takes you to a customer portal, because right now we have settings and we also have a sign out button, but we do not have a customer portal where the user can manage his existing payments, etc. So I'll just go ahead and make a comment right here that says to do, and then add customer portal or something like that, just so I remember that for the future. So right now, if I hover this button right here that says settings, we can see that it takes us to account/settings. But if I do click it, we see that the page is not set up. So I just want to set up that page quickly. And this is where the user can change his name, password, etc. So under the BetterAuth UI library, we just want to set this up as well. So going down to below auth pages to account pages, we can just add this component too. So I'll hop under auth right here, and then I would like to just copy this. So I'll say this is auth. So right in auth, I'll create a new folder called accounts. Under account, I'll put in account view, and then I'll put in a page.tsx inside of this, where I just paste in the contents. And now if I hop under this menu again and say settings, then it will take us to an account page like this, where we can change our password, see our sessions, and then also change our name and email. Good. I just noticed though that we weren't able to navigate back actually. So when we click settings, we can only see these menus, but we can't navigate back, without using the browser back button up here. So I'll just go ahead and create a button for that. So hopping into this account page specifically, because that is the only one I want to do it for, what we can do is we can add a back button. So for example, we could add in a button right here, but then because we are inside a client component, we wouldn't be able to, inside a server component, we wouldn't be able to use the onClick for anything, because the onClick property right here only works in client components. So we would need to just go ahead and make a client component where we import this component into. So I'll just go ahead and do that. So under components, I'll make a new folder called account. And then I'll say new file, and then I'll say back button.tsx. In here I'll say use client. And then I would like to create a new component called a back button, where I return the actual button, like that. And then on click, we'll just need to get the router actually. So we'll have to say const router is equal to use router. And then whenever we do click this button, we'll just say router.push, and then push the user to the first page or just the default root page. And then I also want to put in a arrow left icon, like that, from Lucid React. And let me just see what else. So right now we do not see the button, we just need to import it over here. So if I put it in like this, and then we should be able to see it in just a second. Right now it says it wasn't mounted, and that is because we need to import it with navigation instead of with router. Then I'll just refresh, and now we can see that button. Then I'll just say variant outline, like that. And then I would like to put on some classes. I want to space it a little bit from the actual card. So I'll say MB4 maybe MB6. And now it looks a little bit more decent, I would say. Then if I actually click the button, it takes me to the home page as I would expect. Also, I just want to say cursor pointer for the button as well. So whenever we do click it or hover it, we can see that our pointer becomes a hand. So we know that we can click it. Good. So now that is done as well. I now want to get started with the actual homepage right here, where you can create new videos and also see your recent creations. So first, I'll just start by creating a client component for showing these things. And this is required because we have some buttons inside of it that we can use to open up some modals, and we can't really do that on a server component. So I'll go ahead and hop into components, and then I'll say new file, client home.tsx. In here, I would like to say export function client home, like this. And when we are ready for it later on, we're going to pass down the recent creations from the server component, because we can query the recent creations, so the already created videos from the database, and then pass them down from the server component to this client home. But for now, we're just going to leave it empty. And then I'll say return paragraph hello. And then I'll just go ahead and say use client. And then I can take this client home and just use it inside of not the auth view, but the main view. So I'll just go ahead and replace this logged in with our new client component. That looks like this. Good. And then over here, it should update like that. First, I want to conditionally render out 3 different buttons. I would like one that says something like photo to video, one for translate video, and another one for change video audio. So we're going to conditionally render them out from an array, which I'll define up here. This will be called features. And each feature should have a label, so that is just the title of the button. This one will be photo to video with portrait avatar. And we'll also define an icon which we can show to. So I'll say icon, and I'll just use this image icon from Lucid React. We're also going to define some colors that makes this button stand out from the other buttons. So I'll say color, BG blue 50, and text blue 500. And lastly, we'll make a description as well, which we can show under the label or the title. So I'll say description, and the description should be turn photo and script into talking video, like that. So that is the first feature which we'll create. I'll copy this down twice, right there and right there, and then this other one I'll call translate video, and this one will be languages. For the icon, here I'll use orange instead of the blue color, and I'll then say translate. I'll just put a dot in here actually. I'll then say translate with original, voice, and lip sync. Then for the last one, I would like to say change video, audio, and then this should be a video icon. This one will be, let's make it purple and purple. And then for the description, I'll say replace the audio track of your video, like that. And now we should be ready to render them out down here. So first I would like to return a div. This div should have the class name, padding of 8. I also want to put in an h2, create something new, like that. And then I'll just style this because it should be kind of a header looking text. So this will be MB6, text large, and font semi-bold, like that. And then right below this, I would like to create a div to contain these buttons up here. And then this one should have margin bottom 12, flex wrap. So whenever we make the screen smaller, the buttons are going to wrap to the next row. And then I'll also make a gap 4 between the buttons, like this. Now inside here we can say features.map to render out the features we just created up here. I'll then say feature, and I would like to say div. And then each one of these divs should have a key, of course, because we're inside a map. And this will just be the feature.label, because these are unique since we've just hard-coded the features up here. Then we can put in some more things. I'll put in a div first of all. This div should contain the feature.icon, like that. And I'll just say class name, height 5 and width 5, like this. So now we're at least able to see the icons. And then I'll also just style this. So I'll say class name. Then I would like to say flex, items center, justify center, rounded large, padding 3. And then we can pass in this feature.color. So the ones we defined up here, the color. Then we can put in another div below this one. This one should have the label and also the description. So I'll just put in a closing div tag. Then I'll say class name, relative, flex with full, flex column, and justify center. Inside this div, I would like to put in the feature.label. Let me just go ahead and do this. We just need to put this inside another div where I put in the feature.label. And in here, I'll say class name, text, small. I also want to set the font medium. I want to say text gray 900, transition, all duration 300, group hover, like this. And then I'll say minus translate 2.5. So whenever we do hover it up here, for example, and we just need to set the actual group. So going up here, we just want to say class name. So right there, I'll say class name, group. And then when I do hover it, the text is going to hover a little bit like this. We just want to style the rest of this first though, otherwise it won't look very good. So I'll say relative, flex, and I'll say minimum with 80. So it looks like this now. Then I would like to say cursor, pointer, So you see the cursor now turned into a hand like that. Then I also want to say items, center, gap 4, rounded large. I want to say background white, padding of 2, so it looks like this now. Then we can go ahead and say transition, all. And we can say duration 300. Then I'll just go down to right below this label, and then I'll just copy this div and then say feature.description. And then we obviously need to change the text, because right now we have the same two things. So this right here I'll change. I would like to say pointer events none, like that. I also want to say absolute, like that, absolute. Then we can say top 3. So right now, if I hover it, you can see that only the text right here moves, and right down here it is static. So we can say top 3, and then left 0. And we also want to change the text size, so text extra small because it is the description, text gray 500 as well, to make the user know that it is the description. And then let me then see opacity 0 as well. So when I hover it, right now it's gone. But what I would like is that whenever we hover this, the description appears actually. So after this opacity 0, we can say transition, opacity. Then we can say duration 300. And we can say group hover. Then we'll set the opacity to 100. So whenever we hover the group, so this entire div right here, it'll appear like that. And then I can see that it moves both up and to the left, this title, but I actually want to only translate on the on the y-axis, so it looks like this. So now the description appears whenever we hover it, like this, and I think it looks really nice. Good. And then we can add a border to it as well that appears whenever we do hover the button. So under this div, we'll put in another one. We'll just call this a span. We'll then just say class name, pointer, events none. Then we'll say absolute. We'll say inset 0, rounded large, like this. Then we'll say border. We can say border transparent and set the opacity to 0. We can also put on a shadow. Then we'll say transition all. I'll also put on duration 300. I'll say group hover. And then a group hover will say border gray 200. We'll also say on group hover. We will say opacity 100, like this. And we'll say on group hover. We'll show a shadow medium, like that. So now when we go ahead and hover this, we can see that a border appears along with a shadow, and we see that it has a nice transition because of this transition all that we put onto it, and the transition lasts for about 300 milliseconds. So this is the final outcome, which is pretty good in my opinion. So whenever each of these is clicked, or are clicked, sorry, I would like to set a flag in a use state that keeps track of which one of these were clicked. So for example, we can have 3 modals down here, and then we can open each one of these modals based on which ones of these were clicked. So I'll start with creating the use states for keeping track of which ones should be open. And then I'll say const photo modal open. So this should be the photos video with portrait avatar. And then I'll say set photo modal open is equal to a use state. And I'll just set this to false per default. Then I'll also just create one for the translate modal open. And this one should be translate as well. And for this one, it should be change video. And here set change video audio, like this. I just forgot audio. So change video audio open, set change video audio open. Good. And now for the on clicks, we can go ahead and determine these based on what the label actually is. So remember, we conditionally render each one of these out. So based on which one we are currently at, we can decide on what should happen in the on click. So I'll say on click, and then I would like to say if feature dot label is equal to, and then I'll just take the label up here. I think I misspelled this actually. I'll take the label right here and then put it down right there. So if that is the one we click, then I'll say set photo modal open to true. So that is for the first one. So whenever we click this, this one will be set to true. We can then also say else, or we can just say if actually, and then I'll just copy this entire statement, and then right here this will be translate video. In that case, we'll say set translate video modal open. Then for the next one, this is going to be change video audio, and then we'll say set translate video set change video audio to true. Good. So now we are arriving at one of the more complex part of the project, and that is where we have to create the actual modals. And these contain a bunch of different components and also a bunch of different logic. So this will be quite a big component probably. So that is going to be pretty interesting to build out. So let's go ahead and get started with that. Under components, I'll create a new folder called modals. In here, I'll say new file, photo to video modal. And in case you do not know what a modal actually means, it just means a pop-up that is shown on the screen. So for example, if I click right here, and a thing pops up that takes up the entire screen, and then it has a gray background all around it, blurring out the background, well, that is a modal. Good. In here, I'll say export function, photo to video modal. And then I would like to do this. So what do we want to pass down to this modal? Well, first of all, whenever we do open it, a flag to tell the modal component whether to stay open or not. So if this is true right here, well then it should display something, otherwise it should just be closed. Then I also want to pass down a function which we can call onOpenChange, like this. So whenever a close button, for example, is clicked inside the modal, well then we should close down the modal. So we'll call this method right here, and this will then set this flag to false again, and then hide the modal. So that is what we'll pass down. Now I just gotta define the types for these as well. So open should be a boolean, and onOpenChange should be open, boolean, and then it just returns void, so nothing. So we just pass in a flag about whether it should be open or not. Then I'll just put in a paragraph that just says hello, and then I'll import this photo to video modal down here. So all the way down at the last div, I'll just take this component, import it, and then just say import right there. And we of course need to pass in the open, and this should just be, photo to video modal, photo modal open, sorry. And then on OpenChange, we'll then just call the set photo modal open. And let me just see what it is complaining about. Void is not assignable to this. So if we just hop into the component again, we just need to return this, and then we should be all good. Nice. So now if I click this right here, we can see, oh, it's actually already hello. So let me just refresh, and then make sure that this is set to false. And then in here, we'll say something like if not open, then we return null. Otherwise, we return that. So whenever we click this, it displays something, otherwise it doesn't. Good, so that is exactly what we wanted. Now we can conditionally show this modal based on the button you click. So we're going to use a ShadCN dialog for displaying this. So this is a dialog, aka a modal. So we're just gonna install this first of all. So let me hop in here, install the dialog, and then we can actually just let me just see the code here. We can actually just, I think, put in, so I can remove this, is what I'm trying to say. And then I can say dialog, like this. and then I can say open, and then I can pass in the open flag directly, like that. And then hopping into the, so many pages, wow. This one. Then hopping in here, I should be able to click this, and then it should open up. So maybe if I say paragraph, hello, it should actually open up the dialog. So we likely need to pass in a dialog content, like that. And now we're able to see it, perfect. So if I click here, it's fine. This doesn't really do anything because we do not call this on open change method. And let me just see what it's worrying about here. It just requires a dialog title, which we'll do in just a second. So this works completely fine, which is perfect. Now let me just go ahead and style the dialog. First, actually, we can just say on open change and call this on open change right there. And then I think this is built in. So if we just click that, we can open up and close down the dialog. Good. Then for the dialog content, we'll put in a class name, hfit, max height, and then I'll say 95%, like that. Then we can say width full, minimum width 95% as well, 95%. And we'll say overflow, y auto. We'll say on large devices, let me just hit the correct button, width full. We'll say on large devices, max with 5XL, and we'll say on large devices, minimum with fits. So now if I try and resize like this, we can see how it works. So it has a max width on larger devices. This is the max width of 5XL, but on smaller devices, we can see that it is going to be with full like this. So it is constrained to the full width of the screen. Also, we can just go through the classes. So first of all, hfit makes it fit the height of this dialog to the content within it. So if we have more paragraphs, well then it is just going to be taller like this. And then we are going to constrain the height to the max height of the screen, or like 95% of that. And then if we have more content than this, we're going to apply overflow y auto, which will then make it scrollable. We also have this minimum width 95% constraint. So as you see, it is not the full width of the screen. It is only 95% of the screen. But we also have this W full flag, which will make it try to fill as much width as possible up until this constraint right here, of course. Then on the larger devices, so what you see right here, we still have this W full, so full width, but we do constrain it to another maximum width. So instead of constraining it to almost the full width, we constrain it to this one right here, which is 1000 pixels. So that is 1000 pixels right there. And then we also say that the minimum width of the dialog must be the contents width or more. Good. So that is basically what we do with this dialog content. Inside of this, I'll put in another div. I'll say class name flex, and also flex column and gap 0 like this. Then inside this div, we can put in a dialog header like that. And we'll put in a dialog title into this too. The dialog title should be realistic talking video with, and then we'll just put in a span that says AI portrait avatars. Sounds pretty cool, right? And then dialog header right here, we'll just import. And then for this span, we'll make this purple because then it will look way cooler. So text purple 600 like that. And then if I open up the dialog, it's going to look like this. So just styling the title as well, we'll just say class name. And then I'll say px5, text 2XL, and font semi-bold like that. So now we have a proper header, which looks pretty cool. Cool. Then going beneath this, we'll go ahead and say dialog description. And I just want to import it from UI dialog, which is where we install our ShadCN components. Turn a single photo and script into a high quality avatar video using an AI portrait model like that. And then we just gotta style this too. So we need to say something like MT2 and text base. And I have a spelling error up here, I can see. So turn, and I'll just remove this actually right there, so they are both aligned now. Then under this dialog header, I'll put in a div, well, say flex column, gap 8. I'll also say px8, py8, so that is just p8. And I'll say flex row on larger devices like this. Here I first want the place to upload the photo. So I'll just say upload photo. And this is the left part of the screen. So I'll just make this a comment so we know that for the future reference. And I'll say div. Then we can say class name flex with full, flex column, gap 4. And I'll say on large devices, we'll constrain the width, or sorry, set the width to 340 pixels, like that. Now, if I then hop into this one, we can create a way to upload photos. So I'll just say div in here. Then I'll say flex, height full, flex column, items center rounded, XL. Then we can say border 2. We can put in a border dashed border gray 200, BG gray 50, PX of 4, and a PT 8. And we'll put in a padding bottom 4. So we'll just need to fix that one. And I think the rest of the classes are fine. So now we have something that looks kind of like an upload field, which is kind of what I wanted to go for. Then we can put in a div inside of this, flex, and flex grow. We can put in a flex column and items center, justify center, like that. In here we'll put in an upload cloud icon. And let me just close it correctly, like that. And then we'll just style the 2 by saying margin bottom 2, height 10, width 10, and text gray 400. So it looks like this. Cool. Under the upload cloud, we'll put in a label. The label will allow us to click and then upload a file. So select a file basically. So inside this label, we're going to put in first the text upload photo. We'll then put in an input from ShadCN. And this should have the type file. We also want to say accept. And I just want to accept an image because that is what we're going for of any type. I want to say class name hidden because we don't want to show this choose file input. It looks pretty ugly. We want to be able to click the entire thing and then upload a file instead. And then I'll say on change. I'll just wait with that because we don't have that ready yet. So going into the label, we're just going to style the text through this label. Text MD, like that. And then we'll say cursor pointer. So it's already text MD, I can see. But cursor pointer, we can then say font medium and underline. Then if I click over here now, right there, we should be able to select a file. So that works fine. Then we'll just add some description down here below. We'll say for best results, choose a photo that is at least 720p, like that. And then this looks pretty bad because we need to make sure the user knows that it is a description. So text extra small, for example, yeah, text gray 500, like that. So that looks pretty decent in my opinion, and you can select a photo like that. I'll then just create a function up here called handle photo file change, and this is we'll receive an event which is react.change event from an HTML input element like this. And inside here, we can grab the file that was just selected. That is just going to be the first one because we can only select one file at a time. So we'll say file e.target.files and then we'll say 0 to get the first one. Then we can say if the file exists, then we'll do something. So I would like to do two things. I want a use state for both a URL for this photo which we just uploaded and also one for storing the actual file. So the one for the URL is used to just preview the file over here in the modal, but I also want the actual file such that we can upload the file to an S3 bucket whenever we do click generate sometime in the future. So I'll say const and then selected photo URL and then set selected photo URL is equal to use states. And it can both be string if a photo is selected, or it can be null if no photo is selected, like that. And then for use state, I'll just import this. And then down here, I'll say selected photo file and selected photo file. And that is the same, except that the type is a file instead of a string, like this. Good. So in here, I'll say set selected photo URL. So this is what we'll do to preview the photo whenever the user has selected one. We'll have to create a URL from the file, which we can then put into an image source like this URL, something like that. So the way we create a URL to show the file is by saying URL dot create object URL, and then we just pass in the file. It's as simple as that. We can also say set selected file and then just pass in the file directly like this. And now we have the file such that we can upload it directly to an S3 bucket because we have it stored inside this use state right here. So that is pretty simple. Now we'll just go down to the inputs and then we'll say on change like this, on change. Then we'll say handle photo file change. And we can actually also just show the sample photos under this. So remember how we uploaded the sample photos to the HeyGen bucket. So let me just sign in again. So I just signed in and then I'll hop into my buckets, public HeyGen clone, samples, and then photos. And then we have these photos right here. So I'll hop up to above the component, then say const sample photos, like that. And this should be an array. We will say S3 key. And the S3 key will just be, let me just copy this URI for example. That will be this one, this part right there. So the S3 key is going to look like this. And the URL will just be the entire URL. So just that one, yeah. So I'll say URL, like that. So that is the first element. We also have the other two. We have 9 and 22. So 9 and 9 and 22. And we have 22 right here as well. So the reason we have both the URL and also the S3 key is because we need a key and a value basically. So in here, whenever I want to show these sample photos, the URL is just for showing the sample photos because they are in a public bucket. So we can just use this as the source in an image tag. But whenever an image is actually clicked, then we'll say, okay, this is the actual location of the image because now you have selected that image. So this is where you should grab the photo from. And because this is the same in both the public bucket and also in the private bucket, we can just use this S3 key from the private bucket, from the public bucket, because it is the same anyways. So going down to, let me just hop over here, going down to right below this upload photo box, I'll just go ahead and show these sample photos now. So I'll hop to this div right there, and then I'll put in another one, say class name empty6 with full. Then I'll put in a div, try a sample photo. In here I'll say class name text extra small, text gray 500, like that. And then right below this I'll put in another div where I say class name empty1 flex gap 2. And then we can say sample photos.map. And then we'll render out an image for each one of the sample photos, like this. Then we can say source, that should be item.url, like that. So this is obviously way too big, so let me just go ahead and style this. Yeah, we also need a key actually. That is just going to be the S3 key because that is unique. The class name should be age14 width 14. So now we have the correct size, cursor pointer. So I want the user to know that they can click these by setting the cursor pointer. Then we can say rounded and border and object cover in case they are not in this correct aspect ratio. Then because we are fetching these from an S3 bucket directly, we'll set the cross origin to anonymous. Otherwise we might get some errors in the console sometimes when we try to load these photos. So one thing we haven't done yet is that we haven't set the CORS policy, so CORS policy for these photos, because otherwise we might get some errors, such as right here. If I open up the terminal, we can see that access to the image has been blocked by the CORS policy, no access control origin. So we'll just hop in and then go ahead and set this CORS policy. So going into the bucket like this, make sure that it is the public bucket, and then going to permissions, you can scroll down to the cross-origin resource sharing, click edit, and then I'll just hop into Google and then search for AWS bucket and then CORS policy, public, like this. And then this is a very common problem, so we're just going to grab one of these CORS policies like this, and then I'll paste it in right here. And I just want to remove all the ones except for get, because that is the only method we want to allow, like that. And then I'll click Save Changes. Then I'll just hop back into HeyGen right here, the HeyGen clone, and then open up the Modal. And then we just gotta try and figure out what is going on. Good, so first I'll try and hop into the bucket again, go down to the CORS policy, click Edit, and then we'll add the head as well. Save the changes. And then going back in here, let me just try and refresh. Still didn't make a difference, so maybe they're cached somehow. So I'll hop on the network and say disable cache. Then I'll try and refresh. And then I'll remove this option again. Go back and then try and refresh. And see if that fixed it. Yeah, so it seems like the images were cached before we made the CORS policy change, but now it should work fine. Good. Then I'll just close down this F12 console, and then we can also just make sure that whenever we click this, they are selected as well. So going down here to image, I'll say on click, and when you do click it, I'll say handle photo select. So what do we call it? We call it handle photo file change, but we don't really select a file like this. So I would like to just take these two and then paste them in, where we take the item.url for both, like this and like this. And this actually has to be set to null because we aren't selecting a file, we're just setting the URL. And here we don't need to create a URL already because we already have the URL. So now that should work as well without giving any errors. Good. Next, we can actually show the photo if it is selected. So right now, if we upload anything, I'll click one of these, nothing happens. And that is because we don't really show the photo. So let me just take this entire div and then copy this. So I'll take from where it begins down here and all the way up to right there. And then I would like to say selected photo URL. If that is set, well then we're going to show that. I'll just put in a right fragment. Otherwise we'll put in the upload button right there. And right now, because we clicked one of the buttons earlier, a photo should actually be selected. So I'll put in a div, close it up again. Then I would like to say class name flex column, items center, justify center, and gap 4. Then below this I'll put in a div with the class name relative. In here I'll put in an image, and this image should have the source set to the URL. Selected photo URL, so that is this one, and we'll just set the cross origin to anonymous again, like that. And then we just gotta make this look a little bit nicer. So we'll say class name max height 340 pixels. We'll say max width full, rounded, extra large, border, and we'll say object contain in case the aspect ratio was wrong, and on larger devices or medium devices or above, max width 340 pixels, like this. So this is what it looks like when we have a preview. And then I also want to add the option for being able to remove the photo. So that is why we put in this relative right here, because then we can put in a button that is absolutely positioned, and then we'll put it somewhere in the top maybe. So we can say button, then we can say trash to that icon. So now we have the button. We just gotta say class name absolutes top to right to. So we're able to position it absolutely because it is inside this relative, and then we position it absolutely at the top on the right. Good. Then for the button, I'll just say class name text gray 600 height 5 width 5, and then for the button I'll also just say bg whites p2 shadow, and I'll just say variant ghosts, like this. And let me just make sure that it is rounded as much as possible, rounded full, and I'll then just also say on click, and then whenever we click it we just want to clear all the files. So set selected photo file null, and set selected photo URL null as well, like this. So if I click this, then it resets and we can pick another photo. I just noticed that if we do click this though, or hover it, sorry, we don't really see the pointer. So I'll say cursor pointer. So now we know that we can click this, like that. Good. And then to the right of this div, so over here, I would like to show a box that the user can input this script in. So I'll say right script and options, like that. And then in here I'll put in a div, like that. And I'll just say class name flex1, flex column, and I'll say gap4, like that. In here I'll put in a div, and I would like to put in another div with the class relative. Then put in a text area. I think we might have to install that. I don't think we have it yet. So ShadCN text area, like that. And then I'll just say text area and input this right here. Sorry, we just need to install it. That is what I came to do. Terminal. And now that is done. So we just import the text area now. And then I would like to say placeholder, type your script here, like that. Then we can say, if I just hop back, so now we have a place to put in the script. Then we can say rows, 10 rows, and we can say max length 210, and we'll say value, and that should be a script. So going up here, I'll just go ahead and say const script set script is equal to use states, and I'll just set this to nothing per default. Then down here, that can be the value. So we can say value is script, and on change, or maybe it's on value change. No, it's just on change. We'll then say we'll receive an event, and then we say set script to e.target.value. And now we should be able to type something in, and then the value should be stored inside this use state. And then we can say class name, and then something like minimum height 32. We can also put in break all to break words to prevent horizontal overflow regardless of where in the word you are. And then also under the text area we can put in a button that says upload or record audio. Then up here I'll just say or, and this button can then be variant link like this, and we'll say size small, and we'll say class name, make this conditional, and then first of all I just want to say absolute top 7 and then left 1.5, so it is aligned right under that. Then we can say text base underline like that, and we'll say medium text small. We'll also say top 3 pixels, and we'll say large left 156 pixels. So it looks like this. Now if I make the screen smaller, you can see how it changes. So now it matches the font size of the actual text field, and on smaller device, on this device type, it also matches the font size, and then it is to the right, and here it is to the left. Good. This just needs to be text like that. So now it matches the font size. Nice. And then also whenever you type something into the text field, this should just disappear because otherwise it looks kind of weird. So that is why we made this conditional. So we can go ahead and say if the script is there, then we'll apply the hidden class, otherwise we'll apply nothing. So whenever I type something, it disappears, but you can also click this and then upload something, and then you shouldn't be able to type the script in at the same time. So I'll just add the cursor pointer to it as well. Cursor pointer like this, so I can click it, or not, I could click it anyways, but just so we know that we can click it whenever we hover it. Then I'll say on, click, and when you do click it, we'll set a use state just so we know that we wanted to upload or record an audio. And this use state up here we'll call audio modal open. So I'll say const, and we'll say set audio modal open is equal to a use state that is false per default. And then we'll just scroll down and just set this to true. So whenever I click this, nothing happens right now, but this value is being set to true, so we can show another modal on top of this modal, where we can then upload some audio or record some audio instead of typing in the script right here. So that is the purpose behind that. We can then also implement the modal that should open up whenever we click this upload or record audio. So I'll hop under components and then say new file, audio, upload, modal.tsx. In here I would like to say export defaults function audio upload modal like this, and then I would like to pass in open, on open, change, and on audio recorded like this. So this is whether the modal should be open or not. This is what happens whenever you click the close button on the modal, and this right here is whenever you finish recording, and in that case we would like to save the actual file in the parent component up here. Good. So now I just want to set the types for these as well. So I'll say open, which should be a boolean. We also have this on open change, which will pass in a boolean as well, return void. And we can do the same just for the following one right here, just where we pass in an audio blob instead. So blob like this. Good. Then for the component itself, we'll just go ahead and start up by returning a dialog. The dialog should have open be equal to open like this. We'll have on open change be equal to on open change. Inside the dialog we can put in the dialog content. We'll say class name max width medium to keep it a smaller dialog than the bigger one up here. And then inside the dialog content we'll put in a dialog header. We'll say dialog title, and I'll say upload or record audio. Now let me just take this audio upload modal and then pass it into, import it in here. So I'll just import it right there. And then just pass down open. And open should be equal to audio modal open on open change. We'll then set the state of this variable right here. So we'll pass in the set audio modal open. And then for the on audio recorded, I'll just create an empty function for now, like this. We have the blob right here, that is the audio blob, which is just a blob, and then we'll just do nothing for now. So at least when we do click this right here, we are able to see that we can open up the dialog as something that is on top of the existing dialog. Good. I then also want to create another component in here, right there, called audio uploader and recorder.tsx. And the reason I make this another component instead of just embedding it into this component right here is because I want to have this upload and also record field as part of another modal. I think it is for the change video audio later on. But in this other modal here, it shouldn't open as part of a modal. It should just be directly embedded into this modal right here. So therefore I will make the component right here reusable so we can do that. So I'll say export function audio uploader and recorder, and then I would like to say on audio ready, and then I'll also just say on audio ready here, and we'll pass down the audio blob, which is of type blob, and returns void. Then we can just open up the function. And we can then start out by creating these use states. So we know we're going to need the audio URL and also the set audio URL equal to a use states. This can be either a string or null, and we'll set it to null. And then we also have the audio blob. So this is the actual file contents. This up here is just for the preview of the audio that was recorded or uploaded. So this will be audio blob. And this will also just be string, or actually it will be a blob, like this. Then down here we can create a return statement. So we'll say return diff, class name flex column, and gap 4. In here I would like to create a conditional. So we'll say if not audio URL. So if there's no audio, well, I would like to be able to either upload some or record it. So I'll just go ahead and do this right here, like that. And we'll just need to return something in here as well. Good. So inside this audio URL, I would like to return an audio drop zone. So I'll just create a component for this, since this will be maybe a kind of a large component as well. So we don't want to have too much inside this component because this might be pretty big in itself. So I'll go ahead and just say components, new file, and then audio drop zone.tsx, like that. Here I can say export default function audio drop zone. I'll then say on file select, and then the type of this on file select should be a function file of type file, which is passed up, and it will return void like this. Then in here we can return a diff with the upload cloud icon. So we'll have the class name age10 with 10, and I just want to use this component right here. So I'll just show it right here inside the reg fragment audio drop zone, and then we just need to pass in the on file select. I'll just make it an empty function for now, just so we can see it while we're developing it. So if I click right here, I just want to make sure that this one is used as well. So going into that, right under the header, we can just use this component too, this one, and then say on audio ready. We'll just pass in an empty function for that as well. And now we're able to see the contents of this audio drop zone. Good. So for this diff, we'll say class name flex age 48. We'll say cursor pointer flex column items center justify center as well, gap 2, rounded large, border 2, and border dashed like this. Then for the upload cloud, I just want to say text gray 400 as well, like that. And then I just want to take this and make it center like this, so it is centered. Right below, I'll put in a span where we'll put in the text upload a file. I'll put in a span below this where I'll say drop a file here or click to browse, like that. Then for the first span, I would like to say class, font, all wrong, class name, font semi-bold. And for this other span, I would like to say class name text small, text gray 500. And then below the span, I'll put in an input. And this will be of type file. We would like to accept audio /WAV. So right now we see this, but we obviously do not want to show this. So we'll just say class name hidden, like that. Then we'll just define a file input ref up here, file input ref. So we'll use the use ref hook, like this. And we would like to have a ref to the input element, and it'll just be null per default. Then down here, we will be able to say ref is equal to file input ref. So whenever we click this entire thing, this should then open up the file picker dialog. So we'll say on click, we'll say file input ref dot current dot click, like this. And we'll just change this name to ref instead of red, like that and like that. So now when I click this, it opens up the file picker dialog, which is what we wanted. Then whenever a file is selected, we'll just create something for that as well. So we'll say const handle file change is equal to an event change events of HTML input element. We'll say const file is equal to e.target.files, and we'll grab the first one. So we'll just do this right there. We can then say if the file is there, then we'll call the on file select and then pass the file up to the parent component. And then we can take this handle file change and paste it down to the input here. So we'll say on change, like this, and then it is going to be passed up. I also just want to allow people to actually drag a file, so we can drop a file here instead of just clicking here to browse. So to do this, we'll go ahead and just copy this handle file change and then call it handle drop. Then I would like to get the file like we did here as well, but this will be a drag event instead. And this will be an HTML div element. So we'll just need to maybe import this. So this drag event, let me just see where it comes from. We just import it from rec like this. Good. So for the event, we first of all want to say e.prevent default and e.stop propagation. And then we can handle it in our own way. And our own way is going to be taking the file like we did here. So and then there's going to be data transfer.files instead. And then we can say if file.type and we'll just say starts with audio. So we will make sure that it is an audio file. Then we'll call the on file select like that. Then we'll take this on drop and then we'll pass it into the on drop right here. On drop like that. Then we can test it out by going ahead and scrolling up to backend, text to speech, and then taking this my voice file and just dragging it into right here, or just any audio file. And you can see that it opens up a new page, and that is not quite what we want. So to fix this, we'll say const and then handle drag over. And this will also be one that takes this drag event. So we'll go ahead and do this, and then we'll just paste only these two in. Then we'll take this handle drag over, and then we'll say on drag over, paste it in right there. And then if we try again now, so we take the same audio file and drop it, now it doesn't open up a new pane, and now it should be passed up like it should be on file select. Then we can hop into this audio uploader and recorder, and then we can take our drop zone and create a handler for this, because right now we're doing nothing. So I'll say const handle file select is equal to async file. Then we can say something like try and catch. And remember, if anything happens, we can show a toast with this Sona component. So we'll say toast, just import that, dot, and then error, and then could not read the audio file or something like that. And then in here, I would like to first of all, before setting this audio URL and also the audio blob, just check the length of the audio file, because I would like the user to only be able to upload up to 15 seconds worth of audio. So we'll just need to create a helper to do that. So here's how we're going to do that. We'll hop into, I'll just save this first of all, then we'll hop into the source folder. Then I'll say new folder, call it utils. In here, I'll say media.typescript. Then I'll say export const get audio duration is equal to file like this, and then we'll open up the function. Good. First of all, I'll say return new promise to make it awaitable, and we'll need to have a resolve and reject. Then we can create a new element in the document. So we'll say const audio is equal to document dot create element, and it should be an audio element like that. Then we can say const URL is equal to URL dot create object URL, where we pass in the file. Then we can say audio dot src is equal to URL. Then we'll say audio dot add event listener, and I would like to add the event listener loaded metadata. And whenever this event is triggered, I would like to say URL.revoke object URL, and we'll then just resolve the promise with audio.duration like this. And as simple as that, we then create a fake audio a fake audio element in the DOM. We load in the file by first of all creating a URL from the blob, and then loading that in as the source URL for that audio that we just created, the audio tag. Then whenever the metadata loads for this audio URL, we can then resolve the duration, and which is going to be returned by this get audio duration up here. We can also just copy this right here, and then right below we'll just say error. In that case, we're going to reject the promise with the new error of failed to load audio metadata like this. So now we can take this get audio duration, hop back into right here, and then we can try to figure out the audio duration for the file that was just selected. So let me just say const duration is equal to await get audio duration like that. Then we can say if duration is more than 15, then we'll say toast.error audio must be 15 seconds or less like that, and then we'll return and not do anything else. If the audio duration, and let me just check out what this error is right here, it is unknown. So hopping in here, if I hover it, it says promise unknown, so we can just tell it or tell Typescript that we are returning a promise actually of type number like that. So when I save this, hop back in here, we now see that the type resolved to the correct thing. So if the duration is less than 15 seconds like it should be, then we'll set the audio blob to the file, and we'll set the audio URL as well to URL.create object URL, and then pass in the file like this. Then we first of all need to just use the function down here. So I'll go ahead and do that. And also when I click here, we can see that we only have like a 3-second long clip available. So I'll just set this duration to 1, just so we can test it out. So now we get the error, audio must be 15 seconds or less. If I change this back to 15, we shouldn't get the error anymore. Like this, because now it is under 15 seconds. Then I'll actually just hop into this audio drop zone component again, scroll down, and then I would like to change this to something like supported, formats, and then WAV, max 15 seconds. Like this. So now the user actually knows that there is a 15-second limit and that they should upload audio files. Good. Then closing this audio drop zone down and then having right under this, we can put in another div. Inside this div, I'll put in another div. I'll then for this outer one say class relative flex items center. For this inner div, I'll put in class name. Then I'll say flex grow border top and border gray 200 like this. And then I'll just copy this down again. And then I would like to say a span right here where I say or. And then we can say class name mx4 flex shrink text small and text gray 500 like this. So the user can either upload a file or the user is able to record a file, which is the next thing we'll build right below this. So first I would like to create a use state up here, const recording and set recording. And I'll just make this is recording actually. So set is recording. And this will be equal to a use states, which is just false per default. Then down here, based on whether we're recording or not, I want to render out something conditionally. So under this div, I'll say is recording. If that is the case, we'll render something out. But right now we don't even have the functionality to record. So if we are not recording, I'll just render out a button from UI/button that says record audio like that. Then I'll style this. So I'll say variant secondary like this. And then the class name is already full, or it's already full width is what I'm saying. So we don't need to put that on. And it looks pretty decent in my opinion. Then I'll just create two functions up here. I'll create const start recording is equal to an async function. And I'll create another one called stop recording like this. So start recording should be called whenever this button is clicked. So on click, then we'll call start recording. And then if we're already recording, so we'll just negate this just to check out this state, the other state. Otherwise we'll put in a div like this. We'll say class name flex with full flex column items center and center like this and gap 2. Then I want to put in a span, say recording, ... 00, and we can only record up to 15 seconds anyways. So we'll put in some recording time right here out of 0, 0, 15 like this. Then for the styling of the span, we'll say text extra small and text gray 700 like that. And we'll also just take this button and then copy it down right below the span, and then we'll call the stop recording, and the variant should be destructive like that. And I'll just say class name with full, so it looks like this. Now this number right here, the record time, should be stored inside a use state so we can track it whenever we're recording. So I'll say const record time set record time is equal to use states, and I'll pass in a number 0. Then we'll take this record time, hop down right here. Then we can say string record time dot pad start, and we want to put in up to 2 of these with zeros like this. So for example, if record time is 1, it's going to look like this. If it is 10, it's going to look like this right here. And then if it is 1 again, you can see how it is padded with a 0 right here, even though the number is 1. So it is always going to be 2 characters. Good. So I'll just set this to 0 again. So now that works as well. Then I'll just go down here and remove this negation, because this is how it should look in real life. And then whenever this right here, record audio, is clicked, and I'll actually just make this cursor pointer. both right there and also down here. Class name cursor pointer, just so we know that we can click it. Then up here in the start recording, we'll just start by saying set audio URL to null, just to give us a clean slate. And then we'll need to say audio chunks dot current is equal to an empty array. And then the audio chunks we'll need to define as a ref up here. So I'll say const audio chunks is equal to a use ref like this, where the type is a blob. And we'll just put in an empty array of audio chunks as a start. And up here we also need to put in the type as being an array like that. Cool. So right under this we'll go ahead and say try. Inside this try we'll just put in a catch as well. Inside this try, what I would like to do is say const stream is equal to await navigator dot media devices dot get user media. Then we can say audio true like that. We'll then say const recorder is equal to new media recorder, where we pass in the stream. Then I'll define another use ref up here, which is going to be the media recorder. Media recorder is equal to, let me just spell it correctly, is equal to use ref media recorder or null like this. Then we can say media recorder dot current is equal to the recorder which we just created. Then we'll register some events. So we'll say recorder dot on data available is equal to events. Then we'll say if events dot data dot size is more than 0. Then we'll say audio chunks dot current dot push events dot data like that. So remember, when data is being recorded, so whenever you record with your microphone, audio is basically just being streamed. So whenever data is available or being streamed, we'll just push this to this audio chunks array up here, so we can store it inside this use ref. Cool. Then below this, I'll say recorder dot on stop. Then we'll make this equal to the following function. Const blob is equal to a new blob. Audio chunks dot current type audio web m. We'll then also say const URL is equal to URL dot create object URL, where we pass in a blob like this. So now when the recording stopped, we can then take the chunks that were streamed or recorded and create a blob from this. So this is basically just a file that is not written to the disk but is in memory. Then we'll create a URL for that as well, and then we'll set both to this, or then we'll save both of these in the use states which we have up here. So we have the set audio URL, which is a URL. We also have the set audio blob, which is a blob. And then right below this, we can then say recorder.start, because this after all is the start recording function. Then we'll say set is recording, set that to true like this. Then inside this catch, we'll just say toast.error, and I'll then say could not start recording. Please check microphone permissions, something like that, in case we weren't able to start the recording. Then if I click on the record audio right here, we can see that the audio starts recording, but right now it still says 0, 0 right here. So first of all, I'll just refresh to stop the recording, because right now it doesn't stop the recording because we didn't implement this method. So first of all, I'll just take this record time and we'll just need to update that. Then to do this, we'll hop up and create a use effect. And this use effect should listen to this is recording. So whenever the value changes for is recording, if it is then recording, we'll then count up 1 for every single second. So thereby count up 1 second at a time until we've reached 15 seconds. And after 15 seconds, we're going to automatically stop the recording, because we do not allow any more than that anyways. So I'll say use effect like this, use effect, just import that. And then in here, I'll go ahead and do this. And then we'll just put in the is recording as a dependency. So all the code inside of this function right here is going to be run whenever the value of is recording changes from true to false or false to true. Good. We'll first create a timer of type Node.js.timeout like this. Then we'll say if is recording. In that case, we'll say timer is equal to set interval like this. Then we can say we'll set an interval, and then the code in here will be executed every single second because this is 1000 milliseconds. So we'll then say set record time. So we'll set the value of the record time up here, and we can set it in this way. We can get the current time by doing this actually. Then we can say if the time plus 1 is more than or equal to 15, then we'll call the stop recording function and we'll return 15 as the value of the how many seconds we have recorded for. And down here, if we are not about to stop it, we'll just return t plus 1, because that is how far we've reached so far. Cool. Then down here, we'll say if we are not recording, so else. We'll then set the record timer to, or record timer, sorry, to 0. And now we can go down and just say return clear interval timer like this. So now if I hop over here again, I'll just refresh and then open up this modal, click record. Now we can see that it counts up 1 every single second. So that is perfectly fine. Let me just see what happens whenever we reach 15 seconds. So I'll just skip 5 seconds. And now we're at 14 and 15 and the recording just stopped. So as you can see, it doesn't really record any further, which is what we wanted. And then down here in the stop recording, which we can just implement, we'll say if media recorder dot current dot state is equal to recording. Then I'll say media recorder dot current dot stop like this. And we'll then say set is recording, set it to false. So now let's just try and start the recording and let's then stop it again. So now it is 1, 2, and now just stop the recording and then it's gone. So going down here, as you saw, the entire thing disappeared. And the reason it disappeared is because we do not have anything down here. So we recorded the audio, then we clicked stop. And whenever we click stop, we have set both the audio URL and the audio blob, because this event right here on stop is fired. And then down here, we check whether we have the audio URL or not. So if we do not have the audio, if we do have the audio URL, aka when we have recorded something, then we should show what is down here. But right now, nothing is shown. So I'll put in a div like that. Then I'll say class name flex with full flex column items center and gap2. Then I'll put in audio like this. I'll say key audio URL controls source audio URL like that. So if I just record something and then stop it again, we now can see this. And then I would like to just go ahead and say class name mt2 and with full, so it fills the entire modal. Now if I click play something, we can see that it just played whatever I recorded a couple of seconds ago. Then below this audio, I would like to say button and then use this audio like this. Then for the button, I'll just go ahead and say variant defaults, and I'll say class name flex with full items center and justify center as well. So it looks like this. And we'll also put in an on click. And then up here, we'll just say const handle use audio. If you do click use this audio, which is just a function we'll leave unimplemented for now. Then down here, we'll say use on handle use audio like that. Down here, we are also just going to put in another button and say use a difference audio in case you just want to redo your recording. So we'll just say variant, ghosts, and we'll say on click. In that case, we'll set the audio URL to null like that. So if I click this one right here, then it just resets the entire thing. Let me just put on a class right here with full, just so the two buttons are alike. So down here, if I click record audio and stop it, now the two buttons look like this. Actually, I also just want to put on a cursor pointer like that, both for this button and for this button up here. So this one and this one. If I click this use this audio, nothing happens because we just need to implement the handle use audio function. So if you actually get this far as having clicked this button and then calling this handle use button, we're actually ready to send this audio up to the parent component. So we'll say if audio blob. So if it is not null, then we'll call the on audio ready and pass in the audio blob. So this on audio ready, remember, was passed down from the parent component. So we'll then use this to pass up the audio blob to the parent component's state. And that should then be it for this audio uploader and recorder component. Then going back into this audio upload modal, we can then implement this on audio ready. So we'll receive a blob, which we just passed up a second ago. And then inside the function, we can say on audio recorded, and then just pass up the blob like this. And we can say on open change false to also close down the modal, because if you have already selected the audio or said yes to using it, we'll just close down the modal. So if I click use this audio now, it should close down the modal, and then the audio has been passed up to the parent component, which is right here. So I'll just generate a URL for the blob in the parent as well, so we can preview the audio when you have recorded it in this modal too. So in here, I would like to say const URL is equal to url.createObjectURL, passing in the audio blob. And then to store this audio blob and also the name of the file, we're going to create a use state for that. So I'll say const and then something like selected audio URL set selected audio URL is equal to use states string null, and we'll just set this to null per default. We'll then also say const selected audio name and set selected audio name is equal to use states string, and we'll just set the default name to new recording.wav like that. Then going down, we can actually use these two new use states. So we can here say set selected audio URL, set that to the URL, and we can then create a name. So let name be equal to new recording plus new dates dot local string like that. Then I'll use a regex, so I'll say dot replace, and then I would like to replace the following. So I have this regex from my clipboard, which will find all backslashes, or sorry, not backslashes, it is going to find all colons, spaces, or forward slashes, and then we would like to replace these with just an underscore like this. And then just take this regex right here and copy it. I just had it in my clipboard behind the scenes. And then we can say plus dot wav for the file name. Then we can say if, and then we'll say audio blob as file, because whenever you do upload a file, the file probably is going to have a name, but whenever you do record a file, record some audio, this audio will not have a name. So in case you did upload a file, we'll just use the name that the file already had. So we'll say name is equal to audio blob as file dot name like that, and then we'll just reuse the existing name. So now we can say set selected audio name, set the name, and we can set the audio modal open to false like this. So now let's try and upload something. So I'll say upload a file, pick this one, use this audio, and everything worked like it was supposed to. Right now, if any audio is recorded or selected, we can't really see in this text box or anything that we have uploaded or recorded audio instead of typing in the script. So we might just want to show that up here. So if I take this text area and also button and just say replace that, so I'll just copy this and then just say selected audio URL like this. Then we can first of all put in a reg fragment right here. Otherwise we'll render out the text area. So we'll need to put this inside a reg fragment as well, like that. But inside this first one, this is whenever we have selected some audio, which we have already over here. So we'll put in a div and a closing tag as well. Then we'll say class name, flex, items, center, gap free, rounded, border, BG gray, 50, and a padding of 3, like this. Then inside this div, I'll go ahead and put in a button. This button should have a play icon inside of it from the seed React. So play like this. Then we'll say class name, height 5, width 5, text gray 600, like this. So now we have a play button, and we just want to say class name mr2 to space it from whatever is going to be to the right of it. And we'll say on click. And whenever we do click it, let me just define this correctly, we'll say async and run this asynchronous function. So we'll say const audio is equal to, and then we'll create an audio ref up here to be able to play it from the button. So I'll go ahead and say const audio ref is equal to use ref HTML audio element, and we'll say null here as well. And then we'll just add an audio element which we can attach this ref to, and then we can play through this ref. So I'll go down here to under the play button, and then I'll just put in, let me just see, yeah, right here, I'll put in audio. Then we'll say ID, audio, preview. The ref should be the audio ref. The source should be the selected audio URL. And the style should just be display. None like that. Cool. So now we shouldn't be able to see it, but we should be able to play the audio through this right here. So going back into this audio, we can say is equal to audio ref dot current. Then we'll say if not audio return, and we'll say if audio dot paused will await audio to play, and then we'll say else audio dot pause, like this. Good. So now if I go ahead and upload a file, I'll just pick this one, use this audio, and then I click play right here.
I got the idea to start.
So we can see how it just played right there, and that is because the audio is not playing. So by running this on click, we would hit this statement right here, and then it would start playing. Let me just try and stop it right after starting it.
Amazon.
So whenever I did this, we can see that it paused because it was already playing. So we can therefore both start and also pause the audio again. Then right under this button here, I would like to put in a div. Then I'll say class name, flex, flex1, and flex column. I'll say span, class name, and then something like text, small, font, medium. In here we can put selected audio name, and then we're also able to see the actual name of the audio file that was uploaded, and that is the name that we created early on if it was just a recording. But in this case, because we uploaded a file, it is the actual file name of the uploaded file. Lastly, we just need a button to delete the audio, because right now if I want to redo the audio or upload another file, we can't really do that. So I'll just go ahead and make the action reversible. So I'll put in a button right here and then say trash2 as the icon, like this. Then we can say class name, height 5, width 5, text gray 600, like this. So now we have the button. So then we just gotta say class name And then in case the name of the song is very long, we're going to go ahead and set a margin left, and then we'll also set an on click like this, and then we'll say set selected audio URL and set that to null. Good. So let me just try and do that. So we can go ahead and remove the audio, select another one like this, and if I just say record audio instead, record the audio, use the audio. Let me just try and play this. Audio instead, we can see that works completely fine as well, and I can remove that if I want to. Now for the button right here, I just want to put on a cursor pointer like that. So if I save this and then just select an audio file, we should be able to see the cursor pointer. And I just want to do that for the button up here as well, for the play. So that is this one. So I can hover both this and this now. Next, I would like to go ahead and create a modal where the user can actually pick the voice that they want the portrait to speak in. So I'll go ahead and copy one of the existing modals. So I would like to copy this one. And then we'll just call this one choose voice modal.tsx like this. Then in here, I'll say choose voice modal. And then we'll just keep these right here. We'll just change these a little bit. So this one will be on voice selected. So you can both select the voice, but you can also upload one. So I'll also have on audio uploaded like that. Then we'll just take these two and then just add them down here. So this one and this one. Good. Then the on open chain should just stay as it is. This on voice selected will say voice, and that will then be one of the voices which we'll define up here. So we'll just say voice, and then we'll define this in a second. The on audio uploaded is going to be a file of type file in case you actually upload one of these files. Good. Then up here we can define the voice interface. So I'll say export interface voice like this. Then a voice should have an ID like this, string. It should also have a name which we can show. A voice should also have some tags that we can show, such as assertive, American, etc. Then we can have an accent. We can have something like a flag like this, so an American flag, a Danish flag, which should also be a string. We can also have an audio source, so we can actually show the user the voice so the user can play it. We can have an S3 key, a string like this. And then down here we can go ahead and say const HeyGen library voices. So this is our own little library of voices. This will be of type voice array. And we can go ahead and just define these in this format. Then what I'll do is I'll say ID and then voice1, name, Jeff. And then for this next one, we'll say tags to match this one. So tags should be, and actually we just need to put this inside an object. So I'll copy these, put them inside an object, and then the tags should be deep, American, and we'll have assertive as well, like this. Then we can also use the property accent. The accent should be American, and we can put in an American flag. So I'll go ahead and say flag and then just put this in. Then we can find the audio source as well. So I'll hop into my public bucket, go under samples, voices, and then I'll take Bezos, because you might have guessed this is that person's voice. Then I'll copy the URL, so this one, and then say audio source, like that. And we'll then say S3 key, and the S3 key will just be samples, voices, and then Bezos like this, like that. So this part right here is the first voice. I'm just going to go ahead and skip to the part where I have defined these three voices, and then you can just pause the video in just a second when I've done that. So now I've defined the three voices, and you can just pause the video right here to copy these, or you can copy them from the Discord, or sorry, from the GitHub, in case you just do not want to type them in yourself. Good. So I'll scroll down to our component now, and then I'll actually just take the name choose voice modal, And then I would like to hop into not this modal, but the client home, and then just paste it in, or it actually is inside the photo to video modal, just down at the bottom. So right under this audio upload modal, we'll paste in the choose voice modal as well. And then we of course need the open. We'll just set this to true. We also are going to need, let me just add these automatically. We're going to need these ones right here as well. So this one, I'll just remove these statements that throw errors, and we'll just leave them empty. I just want to be able to see the actual modal while we're building it, like this. Then hopping into the choose voice modal, going down here, I'll just change the size of the modal. So first of all, let me just remove this audio upload and recorder. And then if I refresh over here, hopefully we should be able to see it in just a second, because open true is set to true. So now we can see the upload or record audio file. Then we'll go ahead and say, take this, choose voice. Up here, I would like to say on larger devices, so anything above a mobile. We'll set the max width to 3XL, like that. Then I'll say class name, text extra large, and font bold, like that. And then under the header, we'll put in some tabs, and we might need to import these tabs from ShadCN. So I'll say ShadCN tabs, take the tabs right here, and then just install them. So I'll hop into my terminal, install the tabs, and then we should be able to import these in just a second. So we have the tabs right here now, like that. And then I'll import the tabs from UI tabs, and then these tabs I'll call default value. And then, I'll put this property on the tabs called default value, and I'll set this to HeyGen library. So I would like two tabs. I would like a tab where you can record your own voice, aka use your own voice, and I would like another tab where you can use the predefined voices from the library, and that is the tab which we're defining right here. So the default value is just going to be HeyGen library, which is the ID of that specific tab whenever it is open. In here we can put in a tabs list, like this. Inside the tabs list, we can put in a tabs trigger. Inside this, we can put in my voices, and we can put in HeyGen library, or whatever you would like to call your application. The tabs trigger will just need to go ahead and say value for, and this will be my voices. The value for the other one is going to be HeyGen library, like we defined up here. So that is going to be the default one. And right now it looks kind of weird over here. It seems like it isn't rendering correctly. So first I would like to just try and check the imports up here. So we should have the import. So this tabs trigger is from the wrong import. That is why we need to import them from the correct place, which is UI/tabs. Otherwise they might look kind of weird. Good. So now we should be able to continue. So we have the tabs right here, which we can switch between. And then we just need to render out the contents of the modal depending on which tab we have selected. So for the first tab right here, if we go under the tabs list, we'll put in a tabs content. We'll then say value and then my voices. So this is what is being shown if my voices is the one currently selected. We'll then say class name, padding 4. Inside this, I would like to import the audio uploader and recorder, which we created earlier for the other use case right here, which was upload or record audio. So inside here, we can go ahead and say const file is equal to new file, and then we'll give it the blob, call it custom voice.wav, and we'll say type blob.type, like this. And then I'll just call this blob instead of audio blob. Then down here, we can go ahead and say on audio uploaded, pass in the file, and we can say on open change and set this to false to close down the modal. So now we should be able to see what we created earlier as well. So if I just say record audio, for example, and then click right here and use this audio, then right now nothing happens actually, because we are not using this value right here to keep the modal open. We have just hard coded this as true. So that is why, but in theory, whenever we do
use a not hard-coded value but a state value. This should close down whenever we click use this audio. Good. Then if I just hop back here, we can just implement the other tab as well. So if I just take this tab's content and paste it down below, then I would like to call this HeyGen library. So we show that whenever that is selected. For the class name, we'll say padding 4, we'll say flex, max height 60 viewport height, like this. We'll put in flex wrap, because we will have a bunch of cards showing the different voices that you can select. So if these overflow on the width, I would like them to wrap down to the next row so they don't just overflow the card. So I'll say flex wrap, gap 4 between each one of these cards, and overflow Y auto, like that. So we can scroll up and down if they overflow the height of this container as well, which is 60% of the viewport height. Then inside this tab's content, we can go ahead and we'll just need to define the voices up here. So HeyGen, not HeyGen. Then going down, I'll just say HeyGen library voices dot map. Then we'll loop through each voice. And then for each voice, we're going to render out a card. So if we just comment this out now, and then hop up here, we'll just define a new component for the cards. So we'll go ahead and say function voice card. We'll pass down a voice, what happens when you select the voice, on play toggle, because we also want the user to be able to play the actual voice. And then we can say is playing to keep track of whether it is playing or not. Then we'll just define the types for this as well. Then this voice right here, we'll say that is type voice. The on select will say voice of type voice, void. The on toggle is going to be the same. So we pass up the voice whenever we click play, and is playing is just going to be a boolean, like that. Now inside this voice card, we'll go ahead and say const handle play click. So whenever we click play for the preview, we're going to receive something like an event, just a mouse event. This function will just say e.stop propagation, and we'll say on play toggle just to start playing this actual voice. So this was all we needed for the component, and we just need to return the HTML now. So I'll just return a paragraph right now. So I'll say paragraph like this, hello. And then if I save and then hop down to where we rendered them out, we can just do that so we can see how it looks while we're building it, sorry. So we'll say voice card, and then we don't need to import it because it's in the same component, but we can take the voice right here and say voice.id, and that is going to be the key. We can then also say voice is just the voice like this. Whenever you select the voice, so I'll just go ahead and remove function, void as well, just because it takes too much space in my opinion. So we'll just define a inline function like this. On select, we'll say on voice selected. So let me just see if we made a spelling error up here. We have the on voice selected, like that. Then scrolling down, we can say on voice selected, pass in the voice. Whenever we click play, we'll say toggle play, which is a function we'll create later on to actually play the voice. And is playing, we can say just false for now, because we'll implement a hook later on to both play and also keep track of which song is playing, which voice is playing. So now we should be able to see the voices up here being rendered out, 3 different hellos, because we have 3 elements in the list up here. Good. Then first of all, I would like to create a div, like we usually start out with. Then we'll say class name flex with 52, cursor, pointer, so the user know he can click the actual voice. Flex column, gap 2, rounded large, border, BG wide, padding 4, transition all, and whenever we hover it, we'll say shadow medium. So now if I hover this over here, we can see that the shadow appears with a transition, which is what we defined as these last 2 ones. Then inside this div, and first of all, I'll just put an on click on this div actually. So I'll say on click and then say on select, where we pass in the voice, because when you click this card, we just assume that you want to select the actual voice. Then we'll put in another div with the class names flex, items center, and justify between. We'll also put in a span that says public because it is a public voice. We'll say rounded, BG, green 100, PX2, PY, so padding on the y-axis of 0.5. We'll put in text extra small and text green 700 like this. So it's a cool little badge that just shows the user that the voice is public, so he knows that it is one of his custom voices that he recorded maybe. Cool. Then we can put in a button. Inside this button, we'll keep track of whether the voice is, we're going to render it out based on whether the voice is playing or not. So we'll put in this if statement. I'll say is playing, like this. If we are playing, then I would like to render out a pause button from Lucid React with the height of 5, class name, height of 5 and width of 5, and text purple 600 like this. And let me just see, we just need to copy this pause button, put it into the else statement as well, and just call this play instead, like that. So now we have this button right here. And to remove this background color, which is black, we're going to hop into the button and just say variant ghost, like that. And now it looks way better. Then we'll just say size is equal to an icon because we are containing we're just putting a simple icon into the button. And we can say on click, and then we'll call the handle play click whenever you do call it. Then going up here, let me just see what it is complaining about. So maybe we have the wrong mouse event. I'll just make sure that we have the React mouse event, so now it works perfectly fine. Then below this button here, we'll put in another div. This one should have a span, and it should say voice.flag to show the actual flag, which is pretty cool, and we can put in the voice.name, like this. Then we'll just need to style this a little bit, so let me just put the tags in as well. I'll just put in another span, then just say voice.tags.join, and we'll join the tags together because it is an array of strings with commas in between. And then we'll just need to make this look a little better. So hopping into this div, we'll say class name flex column, like that. Then inside the first span, we'll put in font semi-bold. For the second span, we are going to put in text extra small, text gray 500, like that. And now it looks very decent in my opinion. Then I would like to create a hook which we can use to play the actual audio. So if I scroll down right here, we can see that we didn't implement this. We can neither play the audio or figure out if an audio is playing or not. So what I'll do is I'll hop under source and then say new folder, hooks. Oh, we already have a hooks folder down here. Then we'll say new file and then use audio player.ts. And since we make it a hook, we can also use it in other components later on if we want to do that. So I'll say export function, use audio player. Then I would like to say const audio ref, because we at least know we're going to reference an audio tag from the DOM. This will be of type HTML audio element or null. And we'll put in null here as well. And then we also want to keep track of what source we're playing. So we'll say playing source, set playing source is equal to use state. We'll pass in a string or null, and we'll set the default value to null. Cool. Then the first thing this hook should do is that whenever it is called, it should run this use effect right here. And we'll put in an empty dependency array to run it regardless of what happens. Then in here, we'll put in const audio is equal to new audio, like that. This will then create a new audio element, which we can use to play audio through. This also means we can set the audio ref to the audio which we just created. So we can control this audio right here through the ref up there. And inside this use effect, we're not going to start playing the audio, because remember, the audio should only start playing whenever we click play, but we are going to determine what happens whenever the audio stops playing if the user has played the audio. So we can say const handle ended is equal to a new function called set playing source, and we'll set this playing source to null, and then add an event listener audio.add event listener to ended, and then we'll call this handle ended function whenever the audio stops playing. So whenever it ends, we'll just set the playing audio source to null, and then we'll say return just to deregister the event handler, and then say audio.remove event listener, and we'll say audio.pause as well. And then to play the actual audio, we're going to create a function down here, which we can also expose by returning it in the hook. So we'll say const toggle play is equal to a new function taking in a source, and we can then say const audio is equal to audio ref.current. We'll say if no audio. Let me just see why it is bugging out. So we just forgot the rocket notation like that. So if no audio, because remember audio can be null, then we'll just return and not play anything. Then I'll say if playing source is equal to this source, then we'll say audio.pause, and we'll set the playing source to null. Otherwise, we'll start playing. Else, we'll say audio.source is equal to source, and we can say audio.play, and then whenever if something should happen, we can just catch the error and say console.error playing audio, something like that. And we just want to set the playing source as well, just so we can keep track of what audio is playing. And then this function down here we can expose through the hook by saying we can first of all return the playing source, and then also this function. So this hook right here is able to play in multiple different audio sources, not at the same time, but it can play one, and then whenever we click play on the next one, it then stops this one and then starts the next one instead. So for example, whenever I click play right here on Jeff, then it's going to, and we just need actually to set this to an else, because if it is an if else statement. But just as I was explaining, if I click play right here and nothing is currently playing, then we're going to hit this else statement, and in this we'll set the source of the audio, which we created up here, to the source which we just passed into the toggle play function, and then we're going to start playing the audio. We're also going to keep track of what audio source is playing by setting this this hook up here, setting this use state up here. Then if Jeff is currently playing and then we click again, then we're going to hit this statement right here, which will then just pause this audio and set the playing to null. If Jeff, for example, is currently playing, but then we click Kamala instead, then we're going to hit this statement right here, and then we'll just set the audio source to the new source, aka Kamala, and then just start playing that instead of keep playing the Jeff audio. And then through our use state right here, playing source, we can keep track of whether we're currently playing or not, because if source is set to null, that means we're not playing anything, but if it has a value, it means we're playing something. Also, we can use the toggle play through the hook to start and stop playing. Good. So now I'll just take this use audio player, hop back into the modal where we wanted to use it. So I'll hop into this choose voice modal. So that is this one right there, and I'll then just use the hook. So I'll say const something is equal to use audio player, and then we'll just import the hook, and then we'll destructure what it returns to playing source and toggle play, which we can then use down here. So playing source, we'll say playing source is equal to voice.audio source, and the on play toggle, we'll just say toggle play, where we pass in the voice.audio source like this. Now if we then click play over here,
I got the idea to...
we can see that it plays. If I click play right here, if I then click play and then switch to another one,
I got the idea.
So our
I got the idea.
we can see that it works pretty seamlessly. So now I'll consider this choose voice modal to be finished. Good. Then over here on, it is actually on voice selected. We can then go ahead and implement the button that actually opens up this modal right here, because right now we aren't able to select the voice, but I would like a button somewhere like right here that will then open up the modal instead of us just hard coding the value. So first I'll scroll up to our use states, and then we'll say const right here, and then I'll create one called voice modal open and set voice modal open. This is just a simple use state that just has the default value false. We can also create one called selected voice and set selected voice like this. This is a use state which can either be a voice or null if no voice is selected, like this. And we'll just set the default value to null because by default no voice is selected. Then I would like to also say custom voice file, set custom voice file. This is of course also a use state. This can be either a file or null if no file is selected, like this. And now we have a couple of use states which we can use down here. So first of all, this open should then be the voice modal open, and on open change we'll just use to set the actual value. So I'll say set voice modal open like this, and then we should be able to, whenever we create a button, click right here to open it up, and then it should open up based on the value instead of being hard coded. Then whenever a voice is selected like this, I would like to, and we'll receive the voice in the function parameter, I would like to say set selected voice like this, and then give it the voice. I would like to say set custom voice file to null, and I would like to say set voice modal open to false, because then it is no longer used. And then I'll just copy that right there into here, and then whenever we upload some custom audio instead, this one should of course be set to null, because then we don't pick a voice, we upload something, and then this set custom voice file should then be set to the file instead, and will then still close, it should be file right there, not voice. And then we'll say false right here to close down the modal, because it is still not used, it is again not used whenever we record some audio and then click use. Then I would like to create the actual button for selecting a voice. So I'll hop up to about here, and then I will say container at the bottom of the text area, just so we can keep track of what is what in these diffs. Then I'll put in a div right here with the class name absolute bottom 2 flex with full flex column gap 2 and px free, like that. Then I'll just go ahead and open up another div inside of this div, class name mt2 flex items center and gap 2, like this. Then inside here I would like to put in an if statement, so we'll say if not selected audio URL, and then if this is not right here, we're going to render out the following JSX. So we'll start inside this JSX by saying custom, so we'll put in a new if statement, basically custom voice file. So if a custom voice file has been selected, then we can just put in a fragment. Otherwise we'll put in another fragment. And then for this first fragment right here, I'll put in a div, just close that div as well. Then this div will have the class name flex items center and gap 2. Inside here we'll put in a button with an audio waveform icon with the class name height 4 and width 4. Now if I just go ahead and open up this modal, so if I just say open true, and then I just record some audio like this, record, use the audio, then I should be able to close this down, or at least click false right here. And then we should be able to see this audio waveform icon, because now some audio has been selected. So this if statement right here is going to be triggered. And then right under this audio waveform, we can also put in the actual name of the audio. So this is going to be custom voice file.name like this. And we should then be able to see that as well. Then on click here for the button, we'll say set voice modal open, set it to true. And then down here, let me just see if I hard-coded that. So it should be voice modal open, of course, and not a hard-coded variable. Then inside this span, we'll just say, and actually I'll not decorate the span with any classes, I'll decorate the button. So I'll say class name, flex, cursor, pointer, items, center, gap 1, text extra small, font medium. We can also put in text gray 600. We can put in, whenever we hover it, we'll say text purple 600 like that. So now if I hover it over here, we can see that it looks like this, which looks pretty decent. Now I would like to implement the case where we actually see the button down here called select voice. So if I refresh over here and then just open it up again, we can see that the select voice or custom voice.vav is gone, because we don't really have a voice selected, and we also can't select one. And that is because we just show an empty reg fragment right here. So what I would like to do is I would like to say button, and then this button should say select voice like that. We'll then go ahead and say variant link. We can also say class name h0, px0, text small or extra small actually, and text gray 500 like this. So now the select voice button looks like this, and we just need to implement the on click. And whenever we do click it, we'll say set voice modal open and set it to true. So now if I click this, I can open it up, and if I select a voice, we see that nothing really changes because we still have select voice as the only thing being returned. Good. So the way we can fix this is we can put in another if statement. So I just copied this into the clipboard, and then I'll just go ahead and delete these parentheses, then put in selected voice like this, and then put in 2 if statements. So the button should be the second one, because that is if a voice is not selected. But if a voice is selected, we'll put in a div right here. This div should say class name, flex, items, center, and gap 2. And then inside this div, we'll put in a button with an audio waveform icon inside of it, like that. And we'll just resize this to h4 and width 4, just to make it look way smaller. We can put in a span right below this saying selected voice dot name like this. Selected voice dot name. And then the button should also have flex, cursor, pointer. So it's side by side, and when I hover it, we should be able to see it actually turn into a pointer. It doesn't really do that right now, it's kind of weird. But I would like to say items, center, to align them vertically, gap 1 to space them out just a little bit, text extra small, font medium, like that. We can also say text gray 600, and when you do hover it, we'll say text purple 600 like that. So now when I hover this right here, it looks like that. Then for this button, we can say on click, or let me just see if we forgot that already. We'll just say on click, and then just open up the voice modal again. Just set this to true, because even though we have selected the voice, if we do click this button again, I want to be able to reselect the voice if that is what I would like to do. And one more thing that would be pretty cool is that right now we can only play the voice right here, but I also want to be able to play the voice with the button out here. And because we created this hook earlier on, which we can use to play audio with, we can just go ahead and reuse that hook. So we can say const, and then hello is equal to, and then use, I think it was audio player like that. And then it returns the playing source and toggle play. So playing source and toggle play. So we'll just destructure these. then go back down here to right under this button, and then I would like to put in another button. This button should have an if statement inside of it, and will then say if playing source is equal to selected voice dot audio source. In that case, we'll show a pause button. So let me just say pause, and it's a pause icon. So we'll just import that. Otherwise, we'll show a play icon, also from the seed React. So just play like that. And then we'll just need to actually start playing, because right now we can't even play. So if I click right here, nothing happens. But on this button, we can say on click. And then we can say if we have a selected voice, because it can be null, as you can see right there. What we'll then do is we'll say toggle play and set it to selected voice dot audio source. Then let me just wrap this in curly braces so it looks nicer. And then if I click play now,
I got the idea.
We can now play and pause. It looks pretty bad though, because this button is way too big and also not styled. So for this button, I'll first of all go ahead and say class name text purple 500, like that. So the button now has a color. We can also go down to the pause button, say class age 5 with 5, rounded full, BG purple 100, and a padding of 1. And let me just copy these classes down to the play button, like that. And now the button looks like this. So let me just try and play it now.
I got the idea to.
So that looks decent. And then we can go ahead and say cursor, pointer here as well. So when I hover it, right now, of course, it doesn't work, which is kind of weird. And all of a sudden, after a couple of minutes of debugging, it just works, which is kind of weird. I think maybe Tailwind didn't cache this cursor pointer or something, some weird strange error, but now it at least works like it should, so that is great. And then just let me see what else we need. So going down here, we could, for example, put in if not selected, oh, I can't see anything. If not selected audio URL, then I would like to render out the text, which is a span. The text should be the script.length. So you can see the length right here. And if I type something in, we can see that that is the length. Space / 210 characters or 15 seconds max, like that. Then I'll just style this a little bit. So I'll say class name and then ML auto, text extra small, text gray 400, like this. And now we have this little neat bar over here on the side. So this setup right here is fine for our own self-hosted model, because we can type in a script, or we can provide some audio, and we can also provide some reference audio if we would like to clone a voice. And last, we can also choose a photo or upload one. But I would also like to include the options here in the UI that we might be able to tweak to whenever we use the Sieve data models. So I'll just hop into Sieve data, and then this is the one right here. And then I'll just go to sign in and then just log in. You can just sign up if you do not have an account, but I'll see you in the dashboard. So I'm in the dashboard right now, and I can then see all of the things I've done recently. Then if I hop under Explore, we can then find the portrait avatar model down here. And then the one I would like to use is the one right here. You can pick backend, called Lemon Slice v2.5. And for this one, for example, we can set enhancement to be either none or code former. We can also specify a specific resolution. And we can also specify some expressiveness, which is pretty cool. So these three options specifically I would like to include in our frontend, such that the user can tweak these if you want to, for example, make the portrait more expressive or less expressive. So Sieve actually takes open source models already and also use closed source models. And then for the closed source models, they just use the closed source models APIs, I think. But for the open source models, they self-host the models and sometimes also tweak the code, as far as I'm aware, to make the models even better. So the models that you can use here in Sieve data are pretty decent often, or at least the ones I have tested are. So let's just go ahead and create the UI elements. We need to tweak both the enhancement, the resolution, and the expressiveness. And then we'll go ahead and integrate with Sieve data later on when we're ready to do that. First of all, just to make it fully compatible with our own self-hosted model, as you might have noticed, all the photos for this Hello Free model right here are square. As you can see, they're all square, and that is because the model accepts a square photo and also outputs a square photo. So you can't just take a photo that has the wrong aspect ratio and then pass that into the model. It won't really work very well. So therefore, I would like to create a cropping mechanism such that if you pick a photo like this, that is taller than it is wide, or the opposite, then it should be a cropping mechanism that crops it to a square portrait, and then you can then pick where it should crop and where it should not crop. And this should then only be applied whenever we use our self-hosted model, but whenever we use the Sieve model, because it supports any aspect ratio, we'll just go ahead and hide this cropping mechanism because it is not needed. So to do this cropping, I'll use a package called React Easy Cropping, like this, React Easy Crop. And as you can see right here, there is some cropping space that you can apply to a photo to crop everything that is gray away, and then you can choose whatever aspect ratio this cropping right here should be. First though, I would like to just copy the installation command, hop into the terminal under Frontend, and then paste this in. And now that the installation is done, I don't think we need to do anything else. You can just import it like this, and then there is both a component, but you can also store wherever the crop was applied to, and also the zoom, and then use that to perform the actual cropping yourself. You can also define the aspect ratio down here, so that is the width, I think, divided by the height, or if I remember correctly, it might also be the opposite. So that is kind of how this cropping mechanism works. You pass in a cropper component with your photo, and then you define some options, and then whenever the user has cropped, you have to do the cropping yourself, but you'll have the data about where to perform the crop at, based on this right here, for example. Good. So let's just create some use states. So if I just hop on the React Easy Crop again, we can see what we can configure down here. So going up, I would like to just store some of these things that we need to perform the actual crop in some use states. So I'll hop up here, and then I would like to say, I'll not even do this, I'll just say const crop and set crop, like this. That should be equal to a use states, where we have an x that is a 0 and a y that is 0 as well. Then we'll also define a zoom set zoom is equal to use states. We'll set the zoom to 1 by default, aka not zoomed in at all. We'll then also set an aspect ratio like this, and set aspect ratio is equal to use states, and we'll just define this as 1 by 1. So even though this is going to equal 1, we'll just set it to 1 by 1, just to make it very clear right here in the code that this is actually an aspect ratio. Then whenever this on crop complete right here is triggered, we're going to receive a cropped area up here, and that also has a type that is defined by this library. So we can say const cropped area pixels, set cropped area pixels, and then we can say is equal to use states. This can then be an area or null if no crop has been performed, and it'll just be null per default like this. Area we're going to import up here, so from React Easy Crop, so I'll say import type area from React Easy Crop like this. So now we have this type available. It has a width, height, x and y. Then going down, we can go ahead and implement this actual cropper component, so we can use that as well. And I actually also want to make a flag so we can toggle between the cropper and not showing the cropper and not showing the cropper. So the cropper should obviously be shown for our own model, but not for the Sieve data model. So we'll need some kind of state to switch between which one we're currently looking at. So we'll say const and then experimental model. You can call this whatever you would like to. I'm just going to call it experimental model. is equal to, and then use states like this, and we'll just set it to false per default. And then going down here, we can take this entire if statement right there, and then just copy the contents of that. And then I would like to replace this with if selected photo URL, and we are not on the experimental model. And this, of course, should be model, not modal. So model and model like that. And then we will show this actual cropper, which will just make a React fragment for now. Otherwise, we'll show the photo like we did before, like this. So right now, because this experimental model right here is set to false, or excuse me, because the selected photo URL is not selected right now, because this will equal true, because false negated is true, we're not showing anything. So I'll just go ahead and pick a photo like this, and now nothing is being rendered. So in here we can put in a div first of all. We'll then say class name, relative, heights 64 and width 64, like that. Then we'll put in the cropper component. The cropper will just need to import up here as well, so it can't figure this out automatically. Oh, it did actually. I think we just need to add the missing attributes. So first of all, I'll just give it some classes. We can say container, class name, give it rounded, medium, just to round the actual cropper. We can then say image is equal to selected photo URL. Let me just fix this. We can then also say crop is equal to crop. And if I just open it up now, select a photo. Let me just take this one that is taller than wider. Then we just need to also apply the zoom. We can say on crop complete. And then right now we haven't implemented a method for that yet. So I'll just go ahead and leave this as it is. And I think what it is complaining about is the aspect ratio, because I think that is the only thing that might be missing actually. No, we also need to implement the on crop change to set crop, and the on zoom change to set zoom like that. And then right here, let me just hop back in here. We are receiving the cropped area and the cropped area pixels. So this will be, we'll ignore the first one and then only take these pixels, and then say set cropped area pixels to pixels like that. Now if I then hop back into our code right there and open up a photo, so I'll just take this photo right here, then we should be able to crop it like this. So now we have a square crop because the aspect ratio is 1 divided by 1, so it becomes 1. And then actually if I just hop into hello-free again and just search for aspect ratio, we can see that the reference image must be 1 by 1, so square image, or 3 by 2, so kind of not a square image. And right now this is definitely not a 3 by 2, so we can then toggle or let the user toggle between which aspect ratio they would like to pick. So under the cropper I'll put in another button, and then I'll just close it like this, put in a ratio as well. So this is just an icon. And then for the button itself, we're going to go ahead and say class name, absolute, top 2, right 2, rounded, full, BG white, and shadow. And we'll put in a padding of 2 as well. And then we'll just need to take this icon and color it, because right now it completely disappears within the background. So text gray 600 like that. And we'll say height of 5 and width of 5 like we usually do. Then up here, this doesn't really do anything. So we can just switch between these aspect ratios. So I'll say on, click. And then I'll say if the aspect ratio is currently 1 by 1, so still 1, then we'll set the aspect ratio to 3 by 2, which was the other allowed one. Otherwise, I would like to set the aspect ratio to 1 by 1 again. So we can now toggle between these two. So if I click up here, we are able to toggle the aspect ratio like that, which works pretty fine. And then right now, when hovered, this turns to a completely different color, and I don't really like that. So I'll just say hover, and then maybe BG gray 200, just to make it a little bit darker, like this. And then also I'll apply cursor pointer as well. It's kind of weird how cursor pointer is not included in ShadCN on the buttons. It just doesn't work, and people are really complaining about it. But now it looks like this, so way better. Good. Also, as you might have noticed, the user is able to select a photo, but we can't really remove or replace this photo. So what I'll do is copy this button right here, and then copy it down right below, and then use a trash to icon from the seed React instead. So now we have two icons, and then right now they're of course right on top of each other. So we'll just move this top to 14, and now these two are stacked on each other. Cool. And then for this on click, it obviously needs to be something else. So we'll set the selected photo URL to null, and we'll set the selected photo file to null as well, like this. So if I click here, everything resets. And then right here, because it is square, we don't need to crop it, but if we want to, we can crop it like this. So if I just upload this photo again, it works completely fine. Then going all the way down here again to the bottom, we can put in some controls that allow us to select whether we should use the experimental model or not. So the experimental model in this case is going to be the Sieve model, even though it probably performs better than our own model. So if this experimental model is selected, we'll then be able to select some other controls, such as the resolution, the expressiveness, etc. So down here, so let me just check this diff. Right there, we should be able to put in another diff where we say class name flex gap 6. In here I'll put in another diff, class name flex items center gap 2. Inside this I'll put in a switch from ShadCN. So I'll just say ShadCN switch, and then just install this component. So I'll just click there, install it right here in the terminal. Good, and then we should be able to import the switch now. So I'll just say switch, import from UI switch. We'll check it based on whether the experimental model flag is set to true or not. And whenever we change the check, we'll say set experimental model. Hopping back in here, we now see this switch that then toggles whether the cropper is shown or not. And then we of course need to just put in a span as well. So we'll say span experimental model, save that, and then just style this text with text extra small, text gray 700. And then of course these flags over here, so the enhancement and also resolution, should only be shown if the experimental model is toggled. So hopping under this diff right there, we'll say experimental model, and then if that is toggled, we'll render out a diff with the class names flex items center gap 2. In here we'll put in another switch. This one should have checked enhancement instead. So we'll just need to go up and create another flag for that. So going down, we'll say const enhancement set enhancement is equal to use state, and we'll just set this to false per default. Or actually I'll set it to true, because I think most people would actually go ahead and use that. Then going down, we'll say enhancement on check change set enhancement, like this. And then we can just copy this text up here again and call this enhancement, like that. So now if we toggle this on, we are also able to see this enhancement over here. We can then also, if we hop down here, go ahead and add the expressiveness. So I'll say class name mt2 flex wrap, and we'll put in a gap of 6 between the elements. Then I would like to say if we have the experimental model selected, Then I'll render out the following div, like that. And then I'll say label expressiveness. And then this should be from 0 to 1. So I'll put in a span so we can style this differently. 0 to 1. Then I'll say class name ML1, rounded BG gray 100, like that. And then I'll also put in px1, and I'll put in text extra small, so it looks like this, kind of a little label if you want to say that. And this label up here itself will say class name text small font medium, so it looks like that. Under this label right here, I would like to put in an input field. So I don't remember if we have this installed from ShadCN already. It seems that we do. Good. So let me just inside this put in type is equal to number, like that. Then we also want to put in a minimum number, which is 0, a maximum number, which is 1. We'll put in a step value as well, 0.01. So you can only move up and down with 0.01 at a time, so that is each step's value. The value will set to expressiveness up here, so we'll just need to define that as a use state. So under enhancement, I'll put in another one. So I'll just say const expressiveness and set expressiveness is equal to a use state. And we'll just set this to 1 per default, so it's fully expressive. And while we're up here, we might as well just create this for the resolution and set resolution, like that. Is equal to use states, and we'll just set this value to 512 per default, and then scroll all the way back down here, and then set the value to the expressiveness, right there, like this. Then whenever the field is changed, so on change, we'll receive an event. So we can say set expressiveness to, and we'll just pass the event value to a number, either target dot value, like this, and this is a string, but the string contains a number, so we'll pass that number to an actual number in Typescript, an actual number instance in JavaScript, and then use that number to set the expressiveness value in the use state. Then if I go over here and turn this on, I can then also just say class name mt2, like this, and we can put in a width 24, like that. Then something else we can put in right now is this picker for the resolution. So if I just put in a div with the class name flex with full items center and justify end to place the picker over here on the right, we'll go ahead and say if we have the experimental model turned on, then I would like to render out the field, and this should be item center, we'll say select. So I don't remember if we have this installed already. I'll just say ShadCN select, and we can at least go ahead and install it in here. So it's going to look something like this, where you have the two resolutions where you can pick between these. Then I'll copy this to clipboard, install it down here, and then we should be able to import the select now from UI/select. Then closing down these tabs right there, we should be able to see the select in just a second. So we can just say value should be resolution, and the on value change, in that case we'll receive the value, and we can say set resolution to value, like that. And then what I would like to do is just restart the server here, because I think it didn't really register us installing this new component, so adding the new file. So I'll just go ahead and restart the server, and then hopefully we should be able to see something. So just refreshing over here, photo to video, experimental model, and I think we just have to put a couple of things inside of the select before we can use it, or before we can see it, sorry. We can start by putting in a select trigger, like that. In here, let me just save, we can at least see the trigger now. We can then say class name width 100 pixels to make it wider. We can say rounded and border. We can say padding x2, py1, and text extra small. Inside the select trigger, we can put in a select value like that. And I just want to import it from the correct place. This one should have the placeholder 512p, like that. And then inside, so right outside the trigger, we can put in select content. In here we can put in a select item, like that, where we put in 512p, and we can put in the value 512p as well, or just 512. Then I would like to just copy this, say 640, both places like that. And now we should be able to see it right here and pick between the different resolutions. Right next to this resolutions picker, we can also put in the actual button for generating the video. So if you put in a button and then say generate video like this, and then also right here say class name ML2 to space it with some margin to the left. Then we can say BG purple 600 to make it really clear that it's an action button, PX4 PY2 text extra small, text white like this. Then we have this pretty nice looking generate button. Then going all the way up here to the use states, we'll just add a little bit more. So we are definitely going to need some loading state. So const loading, set loading is equal to use state, set this to false. Another thing we can also do is say const handle, and we'll need to place this underneath our hooks. So const handle generate video is equal to an async function, like that. And right now we're just going to leave this function as it is. Then scroll down just so we can paste something in the onClick on this button. So for the button we'll say onClick, then we can say handle generate video, and then we can also tell the button to be disabled whenever the following conditions are met. So first of all, we only want to be able to click the button if we are not loading, so the button should be disabled if we are currently loading. Another case where the button should be disabled is if either the selected photo file is not true, so if it's null, or if the selected photo URL is null. So if any of these are null, the button should be disabled as well. We also want to make sure that we either have a selected audio or a script typed in right here. Otherwise the button should be disabled as well. So right here we can go ahead and say and script.trim.length is more than 0. So if nothing is typed in, then we'll disable the button as well. Or if the selected audio URL is null as well. Good. So in these cases the button should be disabled. Also we can just show a loading state down here. So we'll say if we are loading, then we can put in loader2 like that, and we'll then say update import, and right here I'll just say null if not, just to show nothing. Class name mr2 to make some space between this loader and the text below that. We'll then also say height of 4, width of 4, animate spin, and that is it. So going over here now, let's just try this out. First of all, we are going to need a photo. We're also going to need to type in a script or record some audio like this. So now it works as well. If I then remove the photo and then select one, it works again. Good. So those were the conditions that need to be met. Now we can just take this button right here and make the text larger. So we'll make it small instead of extra small. Otherwise, the UI for this modal right here is actually done. Also, when we do this, it works on mobile as well, because this is turning into a flex column instead of a flex row whenever we go from a wide screen to a smaller screen. Good. So now what I would like to do is go ahead and implement some of these functions up here, specifically the handle generate video, because right now that does nothing. So it is going to work something like this. Step 1 is going to be upload the photo like this. We are going to have a second step as well, And by the way, when I say upload, we're uploading from our states up here and then to the S3 buckets. Then we can upload the driving audio. So the driving audio is this audio right over here. And the driving audio is of course only uploaded if a driving audio is provided. Otherwise we just send along the script such that the driving audio can be generated on the server. Then in the first step right here, we can go ahead and upload the custom voice if a custom voice is provided. So right here, if you do upload a voice or record a voice, we're going to upload that. But if you just select one of these existing voices, what we'll do is just send along the S3 key for each one of these in the buckets that in the HeyGen bucket, such that we can just tell it where to find the voice that it should use instead. Next, these three things which we're going to need to generate the video is already in the S3 bucket. So we can go ahead and say step 4, call server action, and the server action will then add an item to the queue along with the S3 keys for these three things, such that Inngest can take care of generating this entire video in the background. So for each one of these uploads, what we're going to do is request a pre-signed URL for uploading to an S3 bucket from our own backend. So we're going to need some kind of method to generate these pre-signed URLs, which we can post to from the client right here. So we're going to need to do this 3 times because we have 3 separate uploads right here. And then first, after that, what we can do is then call the server action. Another important thing up here is that right now, as we talked about earlier, if you do have a cropped photo, it doesn't automatically crop the photo. So we're just going to need to implement something for cropping the photo. Because right now, if I do just select generate, nothing is cropped, we just know the coordinates to crop to. So that is a helper function, which we'll need to implement ourselves. Cool, so first of all, I would like to just say set loading is equal to true, because whenever we click generate, at least we can show the loading state. Then we'll create these 3 variables corresponding to each one of these different steps, where we'll store the S3 keys for where these 3 things were uploaded to, so we can ship those to the server action whenever we call that. So I'll say let photo S3 key be equal to null, and then it should be able to either be a string or null if it is not there. And then we'll just do this 3 times. So this will be the audio S3 key, and this will be the voice S3 key. Good. Hopping into this first step right here, we can say if the selected photo URL is not null, what we'll do is we'll create a variable file to upload that can either be a file or it can be null, and we'll just set this to null first of all. Then first we'll check whether we should crop, and that is based on whether this experimental model right here is toggled or not, and also whether we have this cropped area pixels you state up here available, so if it is null or not. So what I can do is I can say if not experimental model and cropped area pixels, then we'll say const, and then just get the actual cropped image from some helper which we'll create. So crop something like this. So we can just start by creating this helper function to actually crop the photo for us, because right now we do not have the cropped version. I will go under library, source, then say new folder, utils. We already have that, I can see utils right there. Then we can just say new file, crop image.ts. In here, I would like to first of all say export default async function like this, and we'll call this get cropped image, and then we'll pass in an image source, which is a string, and I would like to pass in the pixel crop, so where to crop the image to. This will be an area from the React Easy Crop, and then I would like to return a promise like this. The promise should contain a file of type file and a URL of type string, like that. It can also be null, and I'll just remove this, and we'll then open up the function. We'll only return null and get this null issue right here if something goes wrong and the canvas can be created or something. So right here, let me just see what it is complaining about. We are just returning nothing. So I'll just try and return null like that, just so we can return something. First of all, I would like to say const image is equal to, and then we'll just create a function for creating an HTML image element that we can use to draw onto a canvas, and then on this canvas we can then apply the crop. So first I'll say export, and I'll just say const create image is equal to, and we'll pass down a string, and then in here we'll say new promise resolve and reject like usual. Then I would like to say const image is equal to new image. In here we can then say image.add event listener load resolve image like this. Then we can say image.add event listener error, and then we'll say reject new error fail to load images source like that. Then I just want to say image.set attribute cross origin anonymous, and we can then also say image.source is equal to URL. So basically first we create the image up here, then we create the event listeners. So this event listener right here, load, is going to fire whenever the image loads. And then first after having defined these event listeners, we go ahead and set the things down here, which will then trigger these events. Hopefully not this error one, but the load one. So because we have defined this load event listener, down here when we then set this image.source, it is going to start loading the image now. And that is then going to trigger this load event listener. And whenever that has loaded fully, it is going to resolve the promise and then return this HTML image element. So now we can use this function down here. We can say is equal to await create image, passing in the image source. We'll then say const canvas is equal to document dot create element, where we pass in, where we say we want to create a canvas element. And then to be able to draw on the canvas, we'll need to pass in, we'll need to grab the context. So we can say const ctx for context is equal to canvas dot get context, and then we can say 2D as a string. We can then say if, because if we hover this context, we can see that it can be null. If not context, we'll then just return. I'll just put it inside this, return null like that. Otherwise, we'll say canvas dot width is equal to pixel crop dot width. We'll then say canvas dot height is equal to pixel crop dot height. Then we can say ctx dot draw image, and then we can pass in the image, the pixel crop dot x, pixel crop dot y. Let me just see. We also want to pass in the pixel crop dot width, height, and then the next parameters are just going to be the destination x and y position. So 0, 0. We would like to place the image that has been cropped with these coordinates on position 0.0. So we'll start from the top left up here on the canvas. Then we can just say pixel crop dot width for the destination width, and we can say pixel crop dot height for the destination height as well. So these right here are the source x and y positions, so where to start cropping. These two down here are the source width and heights, so how much to crop. These zeros and zeros right here are the destination x and y positions, so where to place this on the canvas. These down here are the destination width and height, so how big to draw. And now that we have cropped the image with on the canvas, we can go ahead and first of all, let me just see why it is. So this image right here seems to be the wrong format. So if you just hover it again, it says unknown. So up here we just might want to define that we are intending to return a promise of HTML image element like this. And then we shouldn't have a problem down here anymore, like that. Then we can turn this canvas into a blob and then the blob into a file, which we can then return. So we'll then say return new promise, like this. We'll say resolve canvas.toBlob. We'll then receive a blob when this is done. We'll then say if no blob, because if we have a blob, blob can be null. Console dot, and we'll say error canvas error, and we'll just return and not do anything. So this is going to be the case where we return null right there. Otherwise, if the blob does exist, we'll say const file is equal to new file, where we pass in the blob into an array. Then we would like to call this file cropped.jpg, and the file type should be image JPEG, like this. You can then just create a file URL for this file as well, so we have both the file URL but also the actual contents. So we'll say const URL is equal to url.createObject URL, passing in the file, and we'll then resolve by saying file URL. Also down here in this toBlob function, we also need to pass in what file format the blob should be in. So this will be image/JPEG, like this, JPEG. So this will first of all make a blob that is of this type, and then that is also why we can convert the file from this blob type into this specific file type right here as well. And then right now we don't really return anything, so I'll just hop into this place, and we don't want to return, we want to resolve, because we are resolving this promise. And then whenever I hover right here, you should be able to see that it can resolve to a file and also a URL. So just closing this down, this crop image, we can go ahead and try it out. So we'll say await, get crop image, like this, where we then pass in the image source, and the image source is of course the selected photo URL, and then the pixel crop as well. So that is going to be the cropped area pixels, which is of the same type. And then because we can return null right here, we just want to check that that didn't happen. So we'll say if cropped image like this, then we'll say file to upload is equal to selected photo file, like that. Otherwise we won't do that. Also, if this experimental model flag is set to false, is set true, which means that we do not need to apply this crop, what we can do is just skip this crop process. So I'll say else if, and then just selected selected photo file, like this. Then we'll just say file to upload is equal to selected photo file. So just to recap up here, in case the experimental model flag is set to false as it is right now, well, then we're using our own model where we need to apply this crop. So therefore we crop the image first right here, then we take this file and then set it to file to upload. In case the experimental model is set to true, like right now, well, then we do not need to perform the crop, so we can just take the selected photo file and set file to upload to that directly without doing the crop at all. And then we just need to do the actual uploading ourselves. So we can say if file to upload, then what we'll do is we'll get a pre-signed URL. So get pre-signed URL, and then we'll make fetch put request to URL to upload to S3. And then we can go ahead and set the S3 photo key, so this one up here, to whatever URL, to whatever S3 key this pre-signed URL uploads to. So as you might have guessed, we will need to implement a server action or a function to request getting this pre-signed URL. So that is what we'll do first of all. So I'll hop under source, and then we'll say new folder, actions, new file, generation, chatterbox-tts. In here I would like to put in use server in the top, and then we'll say export async function, and this will be get pre-signed URL. Then I would like to pass in the file name that the pre-signed URL should be called in the buckets. So that is string. We'll have the file type string as well. And lastly, I would like to put in something I call a purpose. So this is just some kind of flag to let us know why we are uploading this. So for example, if we're uploading through this modal right here, we would like to put it inside a specific bucket in the S3 bucket, or sorry, inside a specific folder in the S3 bucket that is related to the photo of the video. But if we are uploading something in regards to, in relation to this translate video, well then we'll put the uploads in that bucket, in that folder instead. So it is just to let us know where to upload the thing to. So right here I'll say purpose, and then I'll just put in PTV photo and PTV photo to video audio. And then later on when we implement other modals, we can go ahead and say TTS voice clone as well. We actually need this right now because otherwise we won't be able to upload these custom voices right here. But later on we're going to implement the video translation source, which is the video which we're going to translate, and then also something like the video and also the audio over here. We'll wait with doing these though because we don't really need to do these right now. So first of all we'll say let folder, which can be a string or null, be equal to null. So we'll just go ahead and say null like this. Then we can go ahead and say if the purpose is equal to PTV photo, and I'll just say or purpose is equal to PTV audio, then the folder will just be equal to PTV. So this is the folder which I'll upload the actual file to in the S3 bucket. And then I'll just copy this line right here and say if the purpose is, and then TTS voice clone, then we'll upload it to the text-to-speech folder. And then because this can be null up here, we'll just do a simple guard statement. If folder is null, then we'll throw new error, invalid purpose for pre-signed upload URL. And then we can go ahead and get the upload started. So first of all, I would like to get the file extension. So we can say const ext for extension is equal to filename.split, because the file name includes both the file and also the extension, also a name and extension. And we'll split this by the dot because a file looks something like that, like this, as you might know, file.wav for example. So we'll split this into two parts like this. Then we have the first element and the second element, and we'll then grab the second element right here. So we'll say dot pop to get the last element and return it, which is then the file extension. Now we can create a random file name, because if we upload two files with the same name, it is going to conflict. So we'll just create a new name for this file. So I'll say const uuid is equal to, and then there should be a function called random uuid from this crypto module. Then we can say const key, which is going to be the S3 key, which we'll upload it to. This will just be a string, formatted string, where you first pass in the folder slash, and then uuid dot ext like this. And then to upload to S3, we're going to need the library to actually communicate through the API. So I'll say npm and then S3 client. So we'll need this one. So I'll just copy the installation command, say terminal frontend, and we also need a S3 request pre-signer actually. So this one. So I'll just take that command too and install it down here. And then I'll hop back. Good. So let me just go down here and say const S3 client is equal to new S3. And then we might not be able to import this directly. We might want to have to do this manually because it's such a big library or something. So we can say import and then something S3 client. And then from at AWS client S3 like this. And we also want to import the get signed URL from the request pre-signer, like this. And now we have these two that we need. So to create this S3 client, we'll need to pass in a couple of environment variables. So region is one of these. So we can just import this from tilde/env dot, and we'll need the AWS region. We'll need to pass in credentials, which is the access key ID, env.aws access key ID, and the secret access key, AWS secret access key ID. Then we'll need to tell AWS 2 what the pre-signed URL should be used for. So in our case, it should be for putting an object into the bucket, and this is called a put object command. So const command is equal to new, and we might want to import this as well, put object command, like this. It imported it correctly. We'll need to specify the bucket where we'll upload to. So that is env.s3 bucket name, the key which we'll upload it as, and the content type, so the file type, and that is this one up here, the file type, like that. And then we'll just need to get the actual signed URL through this other library which we installed. So const URL is equal to await get signed URL. We'll pass in the S3 client in the command and how long the pre-signed URL is going to be valid for. So expires in should be 600, that is seconds as far as I know. So it's going to be valid for 10 minutes. But in theory, it should be used way quicker than 10 minutes. It is just in case something happens and it takes a long time. So I'll then say return URL and the key, because this way we can get both the URL and the key over here in the front end. So we can store the key to where we uploaded it to and also upload it at the same time. And then when we have done this 3 times, we'll have all the 3 keys where we've uploaded these 3 to, and also we know that we have uploaded the files. So let's now call this new function which we just created. So going down here in file to upload, we can get the pre-signed URL. So we'll say const, and then we get the URL and the key is equal to await get pre-signed URL. We'll need to pass in the file name, so that is file to upload.name. Also the type, file to upload.type. We'll also need to pass in the purpose, that is PTV, and that is going to be the audio, because it is the audio that we are uploading currently. This means that it is going to be uploaded to the correct folder. And now we have the key, but also where we need to upload it to, and then we can make the upload request directly from the client instead of through the backend to S3 now. So we'll say await fetch URL. We'll then pass in the method. That is going to be a put request. The headers will say content type file to upload.type. We'll also pass in a body which contains the file itself, file to upload, like this. Then down here, after we have uploaded it, we can say photo to S3 key is equal to key, because only when we know that we have uploaded the file, we'll actually set this key to the key, because otherwise we might reference something in a later step without the file actually existing, and then something later on is going to break. Also, if no file to upload is there, so if this file to upload is null, that means that we haven't either selected a photo, we haven't uploaded a file right here. So that means that probably a sample photo has been selected. So we'll need to take the S3 key from this sample photo and then set that S3 key to this photo S3 key, because then we'll let the later steps, which is going to generate the video, know that it should reference this sample photo instead of the one that we uploaded, because we didn't upload one. So going down here to the else statement, I'll say else const, and then we'll just figure out which sample photo actually was selected. So we'll say sample photos.find, and we'll just say photo, p for photo, and then we'll say p.url is equal to selected photo URL. Then we can say photo S3 key is equal to, if the sample is available, sample.s3 key, otherwise null up here, as it was initially anyways. Good, so we should actually be able to test these things out already. So I'll just make sure that my environment variables are set up correctly. So as far as I remember, we set these up with the correct credentials, and then it uploads to the bucket over here. So it's going to upload to, it's not the public bucket, it is the HeyGen buckets, PTV right there. So right now we have 2 files, then going into HeyGen, just refreshing, we'll just say photo to this, upload photo, and then I'll just take this one, portrait tall, open it up, and then type in hello just to make it work. Then I would like to say generate video, and remember we're cropping it to this area specifically, so we'll just make sure that that is also how it looks whenever we download it. Then I'll say generate video, and right now we get an issue actually. It says fetch. So opening up the terminal right here, we can set that we can see that we got blocked by some course policy. So that is likely something which we'll need to hop into the bucket to fix. So going into the HeyGen bucket right here, then under properties, permissions, we might want to change the cross-origin resource sharing and permissions right there. I'll just go ahead and add this course policy. So I'll say, you'll need to put it in like this, and then say allowed headers. This will be an array with, and I'll just put in this star right here. We'll then just put in allowed methods as well. And for upload, I think we're only going to need put and also head. Then for allowed origins, we'll need to put in the actual origin. So because we're just testing out right now, we'll just put in a star for anyone. Then we'll say expose headers like this. Here we can put in e tag. And lastly, we'll put in a max age seconds. This will be 3000 like this. Then I'll just go ahead and save the changes. And then what I'll do is just hop back into HeyGen right here and then just try it out again. So maybe it has cached something or whatever, but we'll just try it out anyways. So upload photo, portrait tall, then we'll crop it, type hello, and then say generate video. And then we still got this put forbidden right here, but at least we didn't get the actual course policy error. So going into our right here, we can see that our bucket is called HeyGen bucket. But going in here, what I just found out by checking it out for a couple of minutes is that if I go to the policy for our frontend user, which is the user that we upload this through, and going under JSON, we can see that we are trying to upload, or we have given it permission to upload to a bucket called HeyGen clone. So there is a name mismatch between HeyGen clone and HeyGen buckets. So we'll just edit this and then say bucket instead, because that is the actual name of the bucket. Then say next, save changes. And then let me just try again and see if that fixed the error. So I'll say upload photo, portrait, hello. And then I'll say generate video. And so far we haven't gotten an error, and also we haven't really set the set loading to false, so that is why it keeps loading forever. Going into the bucket again, objects, and then photo the video. We now have 3 objects as we can see. So if I just download this one and then show it in Visual Studio Code. So as you can see right here, the image was not cropped. So what we'll do is just, we at least know that the upload works, which is fine. But what we'll do is just check this out over here. And the problem is that regardless of whether we cropped right here or not, we still set the file to upload to the same thing. So we check, we even do this cropped image thing, but we don't really use it for anything. We just select this, we just use the selected photo file regardless. So we'll just set this to cropped image to .file, then try it out again. So now if I say photo to video, crop my image, portrait tall, say hello, generate video. Then going into the bucket again, I'll just download the new file. So that is the one right here. That is the newest one, that one. Then I'll say download and just open it up in VS Code like this. So this photo right here is cropped, which is great. So now we know that our cropping logic works, and also that we can upload things into the S3 bucket, which is very helpful. We can also upload the driving audio. So going out down here, we can say if selected audio URL and selected audio name. Then I'll say const response, and then we'll just fetch this selected audio URL. So it's equal to awaits fetch selected audio URL. We can then say const audio blob is equal to awaits response dot blob, like this, turn it into a blob, and we'll just need to await that. It's done already. Then we'll say const audio file is equal to new file. We'll give it the audio blob in an array like this. Then we'll say selected audio name, and we'll say type audio blob dot type, like this. Cool. Then right below this part right here, we can say get pre-signed URL. So we'll just do the same as we did up here. I'll copy this down to right there. Just remove the comments. And this will of course be the audio file. And right here, it should be PTV audio. So even though it doesn't make a difference, we'll just put it in this PTV audio, and then it'll be put inside the same folder as the PTV photo, which is the PTV folder. And this down here will of course also be the audio file type, and this will be the audio file. And then we can say audio s3 key is equal to the key right there that we got from the pre-signed URL as well. Then for the custom voice right here, we can say if custom voice file, then we'll say get pre-signed URL and fetch. So we'll do both things right here. This will then of course be custom voice file, and this will be the TTS voice clone key, and then we'll pass in this right here as well, and this right here, and we'll say voice s3 key is equal to s3 key, this key right there. And then what I wanted to do is that I wanted to say else if selected voice like this, then I would like to say voice s3 key is equal to selected voice dot s3 key. Because remember, you can both click select voice and then record a voice yourself like this, use this audio, and then we have a custom voice recorded. So this is this custom voice file, and this will of course need to upload to the S3 bucket before we can clone that. But in case you just click one of these default ones, then we'll grab the S3 key from this. Let me just see. We'll grab this S3 key right here, and then we'll just reference that in the Modal endpoint, so we can just clone one of the default voices. And actually, this right here should be it. So we just need to call the serve action now, but we can just try a full trial run to just test out this entire flow. So we can take this photo, which is right here, we can crop it to the top maybe, and up here we'll just pick a custom voice. So record audio, testing, record, use this audio. This is fine right there. And then we'll say generate video, and this will of course just go forever. So what we can do down here is we can say set loading, set this to false whenever this has been done. We can also just say on open change, set this to false to close down the modal whenever this finishes. And then what I'll do is I'll just refresh, just to refresh this right here, because the things should be uploaded. Then we'll have the new photo uploaded at least. And then we're also going to have the custom voice in the text to speech folder. And I'll just open up this one, which is the newest one, directly in the browser right here.
Record audio, testing. To record audio, testing.
So we now know that we can also play the audio and that it uploads correctly, which is great. We can just check out the photo as well. So hopping into PDV, then just taking the newest photo, which is this one right here. We'll then just say open, and then we can also see that it was cropped correctly to the top like we talked about. We can then get started with the actual server action right here. So where we then take these resources that have been uploaded and then use them to do something with. We do something with them. So I'll hop into generation.ts, then scroll down, and then we'll create a new function. export async function. It should be called photo to video, and we'll receive a generate request, which will just define the type for as well. So this is request like this. Oh, sorry, I just need to switch it to around request. Then up here, we can go ahead and say export interface, generate request. So in here, we can define whatever we want to receive from the server. So we would like to receive the photo as free key, which is a string. We also want to receive a script. So that is optional because you can also just select a driving audio. This is a string as well. We also want to receive an audio as free key, audio like this. We'll just make this audio as free key optional as well, and also make it able to be null because it can be null in the front end. The same for the voice as free key. We'll also need to set the expressiveness, so that is this field right here. So I'll say expressiveness, which is a optional number like this. Then we can set enhancement, which is also a boolean. We can set experimental mode, which is also a boolean. And we can set the resolution, which is a string, like that. Then we just gotta take this generate request and pass it into the server action right here. So in case you didn't know, a server action is basically an API call from the client to the server, where we define that something happens on the server whenever we call this from the client over here. So first in the server action, I would like to authenticate that the user is actually logged in. So you can say const session is equal to await auth.api.get session. We can say headers await headers like this, and then we can check if the user is logged in or not. So I'll say if not session, then we'll redirect. Let me just see we got the right import from Next Navigation. We'll redirect to /auth/sign-in, which is where you can sign in with BetterAuth. Good. And then next I would like to store this generate request persistently, because right now it is only just stored in memory, so it's just on the server as a variable right here. But we would like to add this to a queue, this entire job to a queue, and then the queue will need to be able to get this information at some point whenever it is ready to process the actual video. And therefore I would like to store all of this data in a database, just so the queue can just take all the data from the database and then process it like that. So to do this, we'll go into schema.prisma. So under Prisma, schema.prisma, and then we'll create a new table for storing this data. So I'll say model photo to video generation, ID string, that should be the ID field with a default value of a CUID, which is basically a UUID looking string. It should have a name that can be shown in the front end. It should have a photo as free key, which is an optional string, a script, which is an optional string, a driving audio as free key, which is also a string. We also want a voice as free key, string, expressiveness, which is also a string. Then we would like enhancement, which is a boolean, and this up here actually is a float because it is a value like this. Enhancement is a boolean, and we'll set the default value to false like this whenever the row is created. Then we can also set this experimental model flag, and we can set this to a boolean up here that is also false per default. And we can say resolution, which is a string that has the default value in 512, which is one of the options right here. So these properties right here are what are required to actually generate the video. And then we can also set a video as free key, which is the as free key to the finished video. This will just be an optional string, because whenever a row in this table has been created, this is going to be not set because it hasn't been created yet, the video. But whenever the video has been processed and created, then this field can be set to an actual value, so we know that it has been processed. We can also just set a status, which is a string with the default value queued like that. And then what I'll do is make this table right here multi-purpose, so we can make it we can use it for either generating a photo to video, so an AI portrait avatar with our own model, but we can also use the Sieve data model. So therefore I'll say Sieve job ID string like this. This means that if we use Sieve to do this, we'll just set this job ID to whatever Sieve tells us the job ID is. And then we can still store the same properties right here that are used for Sieve as well. And then other things we might want to use are the created at field. So let me just see if we have one of these already. So created at, and then we'll just say defaults. We can then put in this now, and we can just connect this to a user as well to make a one-to-many relation. So each user can have multiple one of these, but each one of these can only belong to a single user. So we'll say photo to video generations. So this is a column on the user. We'll then say photo to video generation, make that an array. And then down here, we'll just need to make the opposite relation as well. So we'll need to say user ID, and then that is a string. And we can say user relation. And I think we have a relation like that defined down here somewhere, like this. So this will now make sure that every user can have an array of these stored on them, and each one of these can only be connected to a single user, making this a one-to-many relation. Then what I'll do is I'll just hop into npm scripts and then push this new schema to the database, so db push. And then that is done. So we'll just close this down now, hop back into generation.ts, and then go ahead and create a record of this type right here whenever this server action is called. So I'll say const photo to video is equal to, and we'll await the database, which we can import, dot photo to video generation dot create with the data name generate request dot script. So if this script right here is available, then we'll use a part of the script as the name. Otherwise, we'll just use the date as the name. So we'll say generate request dot script dot slice. So we'll take the first 32 characters of this script and use that as the name. Otherwise, if the script is not available, we'll use a new dates like that. And we can say dot to ISO string. So we have something that is kind of human readable. Next, we basically just got to take all of these properties up here and then pass them into the database. So we'll say photo as free key, that is generate request dot photo as free key. I'll just copy this down. We'll have the script and the script. We'll need the driving audio as free key, which is the audio as free key. We'll need the voice as free key, which is the voice as free key as well. We'll need expressiveness, which is expressiveness here as well. We'll need the enhancement flag. We'll need the experimental model. We're also going to need resolution. Then we can put in the actual user ID to connect this specific row to a user. This will be the session.user.id, because remember when we authenticated that the user is logged in up here, we got both the session right here and then also checked if the user is logged in. We can then reuse the session because it contains information about the user. So we have the user ID up here. So we can then use this to connect this row to the logged in user. We'll just set the status to queued like this as well. It is done automatically, but we can just do it just to keep it visible to us programmers that when created, the status is going to be queued. Then right now we do not have any queue created, so we'll go ahead and do that in just a second. So down here I'll say queue the job, and lastly we can then say revalidate path, and then we can revalidate the default path like this. So this means that whenever we create a section down here, we can see all of our pending jobs. These are obviously loaded from the database. So if we really revalidate the path right here, all of these database queries that fetch these jobs are going to be rerun. So we'll see the new updated job instantly whenever we click create as well. To create this queue, we'll go ahead and set up Inngest. So what we can do is we can hop into the browser, just search for Inngest, go to the documentation page, Next.js, and then we can just quickly install this. So we'll say terminal, frontend, install Inngest. Then down here we should be able to run the Inngest server in just a second. What I usually do is hop into my npm scripts and then just create a script down here. So if I copy this line, I can put in this one and then just say Inngest, just so we can run the queue locally as well. So what I'll do right here is just say override, and then let me just make sure that we actually got this working down here like this. And then we first need to create an Inngest client. So hopping under source, new folder, Inngest, new file, client.ts. We'll just paste this in and then call this HeyGen clone, or whatever you want to call your project. Then we'll just need to create this API route as well. So under app, API, we'll create a new folder called Inngest right there. Then we'll say route.ts, like that. Then scrolling down even further, we can create a file with functions. So source right there, new folder, Inngest. So we already have that actually, I just created this. And then we'll say functions.ts. In here we can create our actual functions. So these functions are what are going to be triggered by the actual queue. So I can copy in this function, for example, and then we can call this function photo to video. And then we can call the event that triggers this function photo to video event, like this. Up here we can just say photo to video. Then we can take this function which we just created, hop back into the API route up here, so this one, and then pass in the function. So we'll just need to import this from Inngest functions right there. If I follow the import, it is going to take us to this one right here. And then that should be all we need to get started actually. So I'll close this down, and then we can run the local Inngest server. So I'll just open up Inngest by running this command right here. We'll press Y to install. And then we can open up the following URL, which would take us to the Inngest development server. Then clicking apps right here, we can see that we are connected to our localhost server, which is the server running the Next.js application. So it all seems to be working just fine now. Then what I can do is hop back into HeyGen and then go ahead and define the actual function. So what should happen whenever we click generate. First of all, as we talked about in the theory, every single event in the queue should contain some specific things. So we'll say const photo to video ID. This will be contained within events.data, and we'll just define the type for this as well. We'll say photo to video ID, that is a string. Each event should of course also contain the user ID, like this, so we know which user to save the generated video for. Then first of all, because this function right here is being triggered by, let me just hop into generation, is being triggered by the following server action right here, we will also be able to get the actual information needed to create the video from this database record right here. So right here we created this database record, and then inside the function we can go ahead and fetch it. So I'll hop into functions.ts, and then first of all create a step that does this. So const photo to video is equal to awaits step dot run, and then we'll say get photo to video. This will be an async function that will return awaits database dot, and we'll just need to import the database dot photo to video dot find unique or throw. We would like to find this unique record where the ID is the photo to video ID. So this will get us all of the different properties which we put into the database right here, just inside of the function. One more thing I would like to get though is the amount of credits that the user has. So we can join on another table. I can say include the user table, where I'll select specifically the ID of the user and also the credits that the user has. So right now actually we haven't created a credit system for the user yet. So what we can do is just hop into schema.prisma, go up to the user record, and then we'll just add a new property. We'll say credits and then integer, defaults 100 credits. And we just need to synchronize this database change with the actual database as well. So I'll say go up to db push right there. And then because we have a default value, it shouldn't break anything in the database. So then hopping into Neon, for example, and refreshing, we should be able to see that the user that we created earlier now has this field with 100 credits. So let me just see what went wrong. If I say schema.prisma, we have a default value and we have the field. If I just do a full refresh over here, let me just see, we have 100 credits now. So that is working just fine. Good. And then inside of functions.ts, we can then go ahead and fetch the credits field from the user as well, like this. And then I would like to say if photo to video.user.credits is more than 0, then we'll go ahead and process the video. Otherwise, we'll just set a flag that says no credits on the status. So going down here, we'll say no credits for this status right here instead of queued, so the user knows that he can't process anything because he has no credits left. The first thing we can do when a user does have enough credits is that we can set the status to processing, because in here we set it to queued. So the dashboard right here is going to say queued for a while until the queue determines that this job is ready to be processed. But then when it is ready to be processed, we want to let the user know that it is currently being processed. We'll say awaits step.run, then we'll say set status processing. This is an async function. In here we'll return awaits database dot photo to video generation dot update, where the ID is the photo to video dot ID, and we would like to update the row status and set the status row to processing like this. And now the user knows that the job is currently processing. Next, we can, based on whether the user has uploaded a custom voice or not, do the actual text-to-speech with voice cloning. Or more correctly, if the user has typed in a script, we're going to do the text-to-speech, but if the user has uploaded an audio or recorded some audio, then we're just going to use that straight away. So to do that, we'll go down right here to after this step and then create another one. We'll say if photo to video dot driving audio as free key is equal to null. Then we'll say const text to speech response is equal to awaits, and then we'll call our server to do the actual text to speech. So we'll say await step dot fetch and then offload this fetch request to the Inngest server. Then we can say environment dot text to speech endpoint, and we would like to make this a post request like we defined earlier on. We'll like to pass in the headers content type and also application JSON like this. We can also pass in a specific body. So we'll say body, that should be JSON.stringify. We'll pass in the text, which is photo to video.script, and we need to pass in the voice as free key, which is photo to video.voice as free key like this. So these two parameters correspond to the text to speech parameters required by the endpoint. So we have the text and then the voice to as free key. So what I would like to do is just change this name actually, because it didn't match with how we wanted to send it. Sorry, with what is required by the schema right here. We need to spell it exactly the same. So therefore we'll just need to correct this. But now it should be just fine. So after making this request right here, what we can do is say const data is equal to awaits text to speech response dot JSON, and we can then say as, and going back we see that we get this S free key back. So as s3key, which is a string, we can then go down here and say photo to video dot driving audio s3key is equal to data dot s3key. And now we have the actual s3key for the voice we want to use for the AI portrait avatar. Now we are at the point where we can differentiate between wanting to create one with Sieve or one with our own model. So we'll say if photo to video dot experimental model. In that case, we'll create with Sieve data. But otherwise, we'll just create with our own hello free model. So that is what we'll implement right now. So we can go ahead and create a fetch request. So I'll say const video response is equal to awaits step.fetch to our photo to video endpoint. This is also a post request with the headers, content, type, and application JSON like this. So let me just find this endpoint up here. So under photo to video, this is the one. So we're going to send along transcript, photo as free key, and audio as free key. So down here we can say body, that is json.stringify. Transcript is going to be photo to video id.script. The photo is free key. It's going to be photo to video dot photo as free key. Lastly, we can also pass in the audio as free key. That is photo to video dot driving audio as free key. And then I'll just copy these two lines right here to right after the response. Then say video response, and then this will also just contain an s3 key. It is just called video s3 key instead. And we can then say const video is free key is equal to data dot video is free key like this. And this is then the end of processing, because now we have the finished video. So what we can do is just update the database with this is free key so the user is able to play the actual video. So we'll say wait step.run. So we'll do this inside a step, update db with video like this, and we'll say async, and then return awaits db.photo-to-video-generation.update, where ID is photo-to-video.id, and we just want to update first of all the video is free key to video is free key, and we want to update the status to completed like that. And let me just see what we have done wrong. So we're just missing the data property right here, and then it should be all good. Now the user should be able to actually play the video. So the one last thing I would like to do is just deduct credits from the user's account. So we can say awaits step.run, and we'll run the deduct credits step. This is also an async function that will return awaits db.user.update, where ID is photo to video.user.id, and the data should be credits, and we'd like to decrement the credits by one single number, and this should then take one off the user's account up here. So just deduct the user's credits by one, which is great. And we do this in the end of the function because we want to make sure that the user actually got his video before deducting the credits from his account. And then going all the way up to the if statement up here that checks for credits. So that's this one. We can go ahead and add on an else statement, and then we can take let me just find one of these where we update the status like that, and then just copy it down. We'll then just say no credits so that the user know that he has 0 credits left, in case that is the status. And then we'll say no credits right here as well. And then going all the way up to right here, I would like to set a couple of things as well. We can set something called concurrency, and concurrency limits the user to be able to process a specific amount of videos or a specific amount of these jobs at a time and it is based on a specific key. So the key I would like to use is the event event.data.user-id, and that is going to be event.data.this user ID right here. So whenever we pass in an event into the queue, we're going to also include this user ID, and this is what Inngest can use to determine how to actually limit the user's concurrency. This means that every single user, because every single user only has one user ID, can only process 5 of these jobs at a time. And then if the user clicks on the generate button 6 times, for example, then the job number 6 is going to be queued while 5 of these can process at a time. So that is basically it. We can also put in an on failure. This is an async function which will receive an event and an error. In here we can say awaits, and we'll just use the same kind of status update as we did down here. So let me just paste this up without the return. So we can say ID, that should be the events dot data dot event dot data as photo to video ID, that is a string. And then from this type which we just got, so I'll just need to put this inside a parenthesis like this, we can go ahead and say dot photo to video ID. So we need to kind of do this weird way of getting out the photo to video ID, because it isn't as simple as just doing it down here within the step, or sorry, within the function. So if something fails in any of these steps down here and it retries a couple of times and they still fail, this is when we'll set the status to failed up here. So for the hello free model, so the one we host ourselves, this right here should be a fine implementation for actually doing this. And then whenever we have tested out our own model, we can go ahead and also implement the Sieve data model down here, just so we're able to use that as well. Good. Hopping into the generation.ts, we just need to queue the job. Then the Inngest is going to take care of the rest with queuing the actual job and then running this function whenever the queue has availability. So basically what we need to do is say awaits. Then we can take this Inngest right here, dot send. And I'd like to send the events photo to video events. We can then say we'll send the data photo to video ID, that is photo to video dot ID, and also a user ID photo to video dot user ID like this, because these two properties match whatever we wanted to, or sorry, whatever we defined in here, photo to video ID and the user ID. Then if we go into Inngest right here, so the development server, and then just refresh, we should be able to see our function right here, photo to video. And then whenever we click generate, it should add the function run up here, so we can see that it's been queued, processing or processed. So let's just try and go ahead and do that. So I'll refresh this as well, and then say portrait to video, and then we can put in hello, my name is Andreas. Then we'll upload a photo. I'll just take this one, crop it, and then I'll say generate video. And now we don't really have a way implemented yet to show the actual jobs that has been queued, also processed, but we can see it in here in the Inngest dashboard if we at least have something that works. It didn't really do anything right there, so let's just hop into the terminal to see if we got any errors. Scrolling up, don't see any errors here as well. Now we can just try and hop into the database too, just to check if the job was created. So photo to video generation. Let me just refresh right here. Nothing is in there as well. So I think what we're missing is actually calling the server action. We likely forgot that. So hopping into photo to video modal, and then going down to call server action, we can just say awaits photo to video from actions generation, not ingest function. Then we'll pass in the photo as free key. That is just the photo as free key. And right here, this can be null, but it should always be provided. So we'll just set this to, or sorry, we'll just define it as always being there. Then we can pass in the script, which is the script. We can also pass in the audio as free key, which is the audio as free key. We can pass in the voice as free key. We can also pass in expressiveness. We can pass in enhancement, we can pass in experimental model. Right now it says experimental mode. It should actually be experimental model. Right there. And then also back here, experimental model. We also want to pass in the resolution. And then up here I can just remove these keys. So we just use their own names already. Good. Then what we're going to do is just put in a toast that lets the user know that it was successfully added to the queue. So we'll say toast.success. And we'll just need to import toast, then say .success, photo to video job queued. You will be able to see the status on the dashboard. Something like this. Good. Then hopping back into our application, we can just try it out again. So I'll say upload photo, take this one, crop it, say hello, and then Andreas, something like this. We'll just take one of these that we know works actually, because we did test out this photo that didn't work in the start of the video. So I'll then just click generate video, and then we get an issue down here. So we can just check out what the issue is. So maybe the server just needs to be restarted after making that many database changes, file changes, etc. So I'll just restart both the Inngest and development server. So I'll say dev and Inngest. Then I'll refresh over here and also over here. Before actually creating the video over here, what I would like to do is just hop back into functions, because we have forgotten one thing. Right here in the headers, we've forgotten to put in both the modal key, like this, which is environment.modal key, but also the modal secret. So modal secret. So these are the proxy auth tokens that allows us to authenticate the requests. So I'll say modal secret like this. We can then take these two values and copy them into the other fetch as well down here. So in both fetches that we make to modal, we'll have to provide these keys as well, like this. And now we won't get an authentication error whenever we make the request. So clicking here now, picking one of the photos, saying hello, Andreas, and then generate video. We should then be able to hop into the dashboard in Inngest right here, then see it running. We can see that we have the first 3 steps where we contact the database, which works fine. And then this step.fetch is then currently running. Going into our apps, we should then also be able to see this request under chatterbox-tts generator. So we can see that it is currently pending right here. And then in a second, whenever this is done, it is going to trigger another step. Inngest is going to trigger another step, which is this one, hello free portrait avatar one. So we should be able to see that in just a second when it finishes in here. And now the text-to-speech just finished and it didn't give any errors. So now this next step is running. So going back into apps, we now are able to see that this portrait avatar server is running. Like this, it is currently running. So when the full result is done, we can go ahead and check out that. The Inngest run has now finished and we can go ahead and just check out what happened. So it seems like everything was done as it should be and we have 1 credit less, which is fine. Now going into the database, into the S3 bucket, we should be able to see the result as well. So hopping into right here, the bucket, then just clicking refresh, should be able to find one from today. So if we just click last modified right here, this should be the one. So I'll just try and open this up. And here is the results.
Hello, I'm Andreas.
So that obviously works fine. Let us just go ahead and implement the Sieve as well. Sieve data. So hopping on to functions.ts, right now we just want to implement this just so we can test out Sieve data as well. And then whenever we have tested out this, we can just implement the rest of the functions, just because then we can get all the integrations with Sieve over with before building out the actual UI. So to get started here, I would like you to first log into Sieve if you're not logged in, and then click settings up here. I won't do it right now because it'll expose some of my deep details. But the first thing you should see on the page is the API key. So just go ahead and copy the API key. Then we'll hop into environment variables. And then we'll create one down here called Sieve API key is equal to, and then just paste in that API key right here. Then after doing that, I want you to hop into the environment.js file. Here we'll also create this Sieve API key right there. It is not going to be a URL. And then down here, if I just copy the name of it, we'll go down and then just reference it down here in the runtime environment variables like this. And now we should be able to contact Sieve right here. So we're obviously wanting to use this portrait avatar model right here. So you can find this under Explorer and then portrait avatar down there. And then under the API, we should be able to see how we can contact the API instead of using the dashboard. So basically, we'll need to provide Sieve with what we want to call. So this is the portrait avatar function. And then we need to provide it with a source image and a driving audio. And instead of uploading them like we do in the dashboard, we'll need to provide Sieve with URLs. So what we can do is create pre-signed URLs, which are URLs to our S3 bucket, which Sieve can use to access these files. So we'll create one of these for both the source image and also for the driving audio. Additionally, we can pass in these configuration options such as the enhancement, resolution, and expressiveness in configurations. First though, we'll just create these pre-signed URLs. So hopping under library right here, and then we'll just go ahead and say s3.ts, and then just create a little helper for creating these pre-signed URLs. So we'll say export async function get pre-signed URL. We'll say key string. In here we can say const, and I think we have already created one S3 client like this, where we can just copy a lot of this logic from. So if I just copy this right there and just paste it in right here instead, we should be able to import the S3 client, the environment like this, and then instead of a put object command, I would like a get object command instead. And then we just need to specify the key for what we want to expose through the pre-signed URL. And then the getSigned URL down here we'll need to import as well. And then expires in we'll set to 3600. This means that Sieve data will have an hour to process the video, because it'll only be able to access these files down here for about an hour. So this should be plenty of time, but that is just so you know if anything breaks later on, just so you can debug that. But otherwise, the rest of this pre-signed URL function should be fine. We pass in the key, then we create a client, then we tell AWS through this getObject command that we would like to create a pre-signed URL for this bucket, for this specific file. So you can only access this file through the key, through this URL, and that is that. Now hopping back into functions, we'll go up here and then we'll say awaits step.run. I would like to call this create pre-signed URLs, and then this function should be an async function. First we'll get the pre-signed URL for the photo S3 key, so we'll say photo is equal to await get pre-signed URL, and let me just check we got the right import. We do. We'll need to import it from library S3, so the file which we were just in. In here we can put in the photo to video dot photo S3 key, and because it can be null, we'll just go ahead and assert that it is not null, because it is not going to be null in theory, because you can't even submit the form without it being filled out. Then we'll just go ahead and do the same for the audio. So down here I'll say audio, and we can say driving audio S3 key. Lastly, now that we have these two values, or two pre-signed URLs, we can return the photo and the audio just as an array like this, and then also access them outside this step, photo URL and audio URL. Was just an equal sign like this. And now we have a step that then creates these pre-signed URLs, and we can then pass those into this API request that we can see right here. So that is the next step, const, and then something like Sieve job response is equal to awaits step.fetch, because we are fetching some external source. So we don't know how long it's going to take, so we offload the fetching to Inngest's platform, just so we don't have to hit these serverless timeouts. So first of all, we'll need to fetch to this URL right here, and then we can say we want to make it a post request. So where is it? It is down there. So we can say method post. We can say headers. We can specify the content type. that is application JSON. We can specify the X API key like this, that is this one. And then you have your actual API key right there. So what we'll do is just say env dots and then Sieve API key instead, because we put this API key into our environment variables. And then we just want to pass in the body as well. So body, this will be JSON.stringify. And then we'll need to specify the function, and that is Sieve portrait avatar. We also want to specify the inputs. Those are the source image. In here we'll need to specify URL, photo, URL. We also want to specify the driving audio, and this is then the audio URL. We want to specify the backend. So this is the lemon slice 2.5, this one right there. And then also this enhancement property. So we'll say enhancement, and then we can say if photo.video.enhancement is true, then we'll set it to code former. So that is the one right there. Otherwise we'll set it to none. Cool. Then lastly, in the body here, we can also specify the webhook. So whenever it is done, it'll send a webhook back to us. So we just specify where this webhook should hit. So we'll say webhooks. In here we can put in type job.complete. You can find a full list of which type of webhooks Sieve can send, but this job.complete is just whenever it is finished. We can then specify the URL as well. This will be a formatted string with https // and then I'll use process.environment.vercel URL /API/Sieve like this. Because whenever we deploy to Vercel, this environment variable Vercel URL is automatically going to be set by Vercel. We can also go into our environment variables and then set this ourselves. So we can say Vercel URL is equal to, and then the environment variable, we're going to use a proxy because it can't just send a webhook back to localhost because it doesn't really know what localhost means. It is a local server on my local machine. So we're going to proxy the request of the webhook through a proxy and then to our localhost on our machine. So whenever we test out Sieve, we're just going to set that up right before. Otherwise, let's just save right here, Vercel URL, hop back into our functions. And then over this else here, we can say const Sieve job is equal to awaits Sieve job response.json as ID string. So just hopping back in here, we'll receive back the job ID right there, and that is just a string. And this job ID we can then save right in the database, so we can figure out which webhook corresponds to which job in here later on. So let me just say awaits step.run, and then we can call this step update database with Sieve job ID. Make this an async function. We can say return awaits database.photo-to-video-generation.update, where the ID of the row matches the photo to video.id, and we can say update the data Sieve job ID where to Sieve job.id like this. Then we can define the API endpoint, which it'll send the webhook back to. So hopping under API right here, we'll create a new folder called Sieve. Inside this, we'll put in a route.ts file. And the reason we put it inside a Sieve folder is because we defined the endpoint to be API/API/Sieve. So going into this route.ts, we can start by defining the interfaces, aka the types that we expect from Sieve. So I've worked with Sieve data as API before, or at least webhook it sends back. And I know the types are going to be Sieve output data item. So whenever I received a webhook back from Sieve, I then just printed out all the data just to see what format the webhook would be in. And this right here was it. So first of all, we have this one. It has a key, which is a string, and a value, which is a string. We can then say interface, Sieve output. We have the data, which is a list of these Sieve output data items. And then we also have the webhook body itself. Like this, we have the job ID, which is a string. We have the status, and we just need to make this an interface. Status is also a string, by the way. We also have the outputs, which are optional, and Sieve output list of these. Cool. Lastly, we have the interface called Sieve webhook payload. The body in here is Sieve webhook body, and that is it for what we're going to receive from the Sieve endpoint or Sieve webhook. Then we can define the endpoint itself. We can say export asynchronous function, and this is a function called post. We'll receive a request like this, and inside this we'll first of all say try and then catch to let Sieve know if something wrong happened, because if any error happens, well, when we are processing the endpoint, we'll then send an HTTP response back to Sieve to let them know that they should retry the webhook. So first we can get the payload from the webhook. We can say const payload is equal to, and we'll say await request.json to turn the request into JSON as Sieve webhook payload like this. So we just define that whatever we receive from Sieve is going to be of this type right here, and we know that it is of this type because I've tested it out when working with it before. Cool. So we can then grab the job ID. So we can say const job ID like this, and status and outputs is equal to payload dot body like that. Then we'll say if the job ID is not there, we'll then return next response dot JSON error, and then missing job ID with the status 200 like that. So this will just be a next response like that. And we'll just need to import this from next server. And now we have the job ID of what job was finished when we received this job.completed webhook. So we can then look in the database to see if we have anything that matches this job ID right here. So I'll say const photo to video generation is equal to awaits database, which we'll just import, dot photo to video generation dot find first, where Sieve job ID is the job ID. Good. So if this is found in the database, it is going to contain a record, otherwise it is going to be null, as we can see down here. So we can now just check whether it is null or not. So we'll say if photo to video generation, and if the status is equal to finished, then we can say output const output data is equal to outputs dot element 0 dot data. We then want to find the property inside the output which we received from the webhook that contains or that has the key URL. So we'll say const URL data is equal to outputs data dot we'll say dot find, and then we'll get the item dot key is equal to URL. So we're looking for this specific key called URL because this is the URL which we can use to access the file. Then we can say const video URL is equal to URL data dot value, because this is only the actual key where we can find the property. We want the value of the property. Then if this URL for some example also for some reason isn't there because it can be undefined, we'll just update the database to say that something failed. So we'll say if not video URL, then we'll say awaits database dot photo to video generation dot update, where ID is PTV generation dot ID, and I would like to update the data to status failed like this. Good. And then we can also just throw an error, just so we get an error in the system. So throw new error, and then webhook payload missing output video URL, like this. And the reason we do this check right here is because we just use this outputs data dictionary to then just put a .find on top of this. So it's not even guaranteed that this URL property right here is there. We just know it is there because we have seen it from whatever they sent to us. But in case it isn't there for some reason, we're just going to handle it like this. If the video URL right here is there, that means that we can now access the file through this temporary link, which will then expire at some point. And we also made this endpoint up here called Sieve to S3, which takes a temporary URL like this and then adds it to our own S3 container. So S3 bucket, sorry. So we're going to just create a function for calling that endpoint. So we'll say async function import and then Sieve video to S3. We'll pass in the video URL, which is a string. We'll then say const, and let me just copy one of these fetches from in here. So we can just copy this one, for example. So we can say const and then results is equal to, and we'll just say fetch environment dot Sieve file to S3 endpoint. It is a post request. We'll still need to pass in the modal key and also secret, but this content type right here is just fine. For the body, we'll need to pass in the video URL. So if you just hop in here again, it receives a video URL and returns an S3 key. So video URL is just going to be video URL like this. Then after calling this endpoint, we can say if not result.ok. Then we can say const text is equal to awaits result.text. And then we can throw a new error where we say Sieve import failed, and then we'll just pass in or just put in the text right here so we know what the error actually is. Then we can say const data is equal to awaits result.json as S3 key, which is a string, because we know we're getting the S3 key back from the response right here. And then we can just return this S3 key. So we'll just say return S3 key data.s3 key like this. And now we should be able to transfer our file from the temporary file from the response to our own buckets. So that is what we'll do up here. So if the video URL does exist, we'll say const S3 key is equal to awaits import Sieve video to S3, passing in the video URL. Then we can await database.photo to video generation.update where ID is photo to video generation.id, and we'll just set the data to video S3 key, and we'll set this video S3 key from in our database to the one that the temporary file is now put into, because remember this temporary file is transferred to some specific S3 key in our own bucket. So we'll just make sure to store that S3 key somewhere so we know where the temporary file now is. Then we'll also just set the status to completed, just so we can show that in the dashboard so the user knows that he can play the video now. We can also in this if statement right here say that if the status is not finished, so we can say something like else if status is error or status is failed. Then we'll just copy this one right here again, that one down here, and then we'll just update it to failed again. And then after going down here, we can then acknowledge that we received the webhook. So we'll return back a next response dot JSON like this, and we'll just pass in the message webhook processed successfully for photo to video like this. If we can't find the job, so if this is not true, that means that we didn't match the Sieve video ID. In that case, we'll return another response that tells Sieve that we don't really know what is going on. So we'll say error and then I'll just remove this. Generation, record not found for Sieve job ID, and we'll put in Sieve job ID. So that is the, where is it at? Job ID, right there. Like this. And we'll then say status 400 as well. So that is right there. Status 400 there. Also, if something goes wrong, it'll be caught inside this catch. And then we'll just say status 500. And then internal server error. And then we can also pass in some details. So we'll say details. And this will just be the error message from up here. So we can say error. And when hovering up here, this is going to be unknown. So we'll just need to say const error message is equal to, and then we'll put in an if statement. If the error is an instance of error, then we'll take error dot message. Otherwise, we'll just say unknown error like this. And then we'll take this error message and then just pass it in to the details like this. And of course, this just needs to be this instead of a question mark. Good. So this should actually take care of the full flow of getting Sieve data to work or integrating with Sieve data. We just need to set up the proxy now so we can actually receive the webhook, but we can at least start the processing of a job if we would like to. To get started with the proxy, what I'll use is ngrok. So if you hop into ngrok, click login, and then what I'll do is I'll just log in with GitHub. And now I'm logged into the dashboard. So what I've done is I've taken this command brew install ngrok, and then I've ran it in my terminal right here. So I can put in brew install ngrok, it's already installed. Then what you'll do is you'll take this authentication token and then also paste this command into the terminal. And lastly, you'll be able to start up a proxy, which will then just run in your terminal right here. So what we can do is we can just take this command after you have done this, of course. So run these two commands and then do what I've done, what I'm about to do. Then hop into your npm scripts, and then right under something like Inngest, we'll put in ngrok, and then we'll put in our commands, and we'll say localhost at port 3000, because that is where our application right here is running on, port 3000. And what we can actually do is just remove this right here. So it just says ngrok http, and then followed by 3000. So let's just try and run this. So if I close this one down right here, we can go into npm scripts, and then we can scroll down to find the ngrok command, run this, and now we should be able to see this proxy that is happening. So every single request that is made to this right here is then also forwarded to our localhost server. So this right here acts as the URL which we should send the webhook to. So we'll go into our environment variables now, and then paste this in as the visual URL. In production, this of course would just be the actual URL of your application, because in production, you have no trouble receiving the actual webhooks. It is only because we are developing locally. And then let's hop back into our normal terminal right here and close this down. Then what I would like to do is just test out the flow. So if I hop under jobs, we should be able to see that the last one was submitted 7 days ago. So then if I hop under HeyGen, and then say photo to video, and then I upload a photo, and I'm just going to take this one that is tall, and then we can turn on this experimental model right here, and then say, hello, I'm Andreas, put on enhancement, and set the resolution. We'll just leave it as it is. Then I'll try and click generate video, just to see if we get an error. Going into Inngest now, we can see that it is running. So this step right here has been queued. Let me just see what happens inside Sieve job right here. So if I refresh, we aren't able to see any jobs running yet. Going back into Inngest, I'll just wait for this to finish. So what is going on right here is that we are running the text-to-speech generation, and that is running on Neon. So it might take about half a minute or so just to run the text-to-speech in here. So this will just have to finish first, and then Sieve is going to be called. So I can see that it finished up right now after about a couple of seconds. So the two pre-signed URLs were just generated as well. And then we can see that we have this step.fetch, which then fetches to Sieve data. And we also get a 200 response back from Sieve, which is great. And then we update our database with processing as the status. And then now everything is left over to Sieve. So over here, we can now see that it says processing for this right here. And whenever that is done, it'll send a webhook back to our end, which we can then use to check on the status. So right now in the Neon console, if I go under tables, for example, and then I just look at this, we should be able to go under this one right here, which has experimental model set to true. And right now the video as free key is just null. So this one right here should update to an actual value whenever it finishes over here. So I'll just wait for this to finish and then we can check it out. Great, so it just finished right here after about a couple of minutes. Then what I'll do is I'll just check out the terminal to see if we got any errors. It doesn't look like we got any errors, which is great. Under Inngest right here, we also don't really see anything actually. So I'll just hop into Neon now, and then we can refresh and then see if it worked or not. So I'll refresh right there, and then we can see that it still says processing actually. So it didn't do anything. It seems like the endpoint wasn't properly received maybe. I'll just try and refresh, and then it is this one. See if anything happened. It is still processing. So let me just try and dig into what actually happened here. I just figured out what the issue is. So the issue is that we have HTTPS both right here, but also right here. So whenever we deploy this to the cell, the URL is not going to contain HTTPS. Therefore, we should assume that this does not contain HTTPS, and it's just a bare URL like this. So we'll need to prepend HTTPS ourselves over here in the webhook. Therefore, if I save this now, it should actually work. So let me just try and test it out again. So I'll just refresh, say hello, upload a photo, use the experimental model, and then what I'll do is just test one of these photos instead. Expressiveness, I'll try set it to 0.5, and I'll also set this to this resolution right here. So now let's try and generate the video, and then I'll come back whenever we have something that is done. I just want to make sure that it actually starts in here, and it does. Great. It just finished over here in Inngest, over here in Sieve. So we can see that it finished. Then if I hop into the Neon dashboard right there and refresh, I just want to check whether we have one with 0.5 that also has the video as free key and is completed like this. Good. So now we can take this video as free key and just try and check out the results, or just see if it at least is there. So we go into Sieve, and then we have the video right there. Good. We can also hop on the Sieve right here and just check out the results ourselves. So this is the photo, and then we can play it right here as well.
Hello, I'm Andreas.
And we can see it worked perfectly fine with these lights in the background, even though it was red. So this Sieve model is likely way better than the model that we self-host. But now we know how it works behind the scenes. Good. Let's go ahead and set up the next two features in Inngest or from Sieve data, which is the lip sync and also the dubbing. So translate video and also change video audio. The second feature will be dubbing. So if I hop under Sieve over here, go under explore, we want to do dubbing like this. And with dubbing, you put in a source file, so a video, and then also a target language, and then it translates from this
perhaps the most
to this.
quizás.
So you see how it looks the exact same, but the mouth movements and audio is also different. Well, that is what dubbing does. So under the API, we can see how this can be done. Luckily, we've already defined the basic structure of how this function should look, because we just defined this one up here. So what I'll do as a starting point is just take this entire function, copy it down, and then this one I'll call translate video. Here I'll call it translate video as well. And then we of course can't use this photo to video generation table, because that is for that specifically. So I would like to create a new table for both dubbing but also the lip sync. So hopping under schema to Prisma, We can start by copying this one right here. So I'll copy this down and then remove the things that are specific to photo to video generation. I'll just say video translation generation like this first of all. Then we can just remove these, and then I would like a name that is correct. Source video is free key. I also want a target language. I also want some kind of status like we had up here. We have that down here though. We have the output right there. We also have the Sieve job ID and the created ad. So now I just want to create a reverse relation from user down to this one, because we already refer to the user over here. So we'll just say video translation generations, and I'll say video translation generation as an array like this. We can just go ahead and do the next one as well while we're in here. So if I say explore, we hop under lip sync. And for lip sync, we want to provide a file like this. So this is an audio, so this is a video file. So if I just play this,
a number of models.
we can see that it is in English, but down here,
Hay varios modelos que se ven.
we can see that the same is just in Spanish. So I guess that someone uploaded this video file right here, and then uploaded a Spanish or sounding audio like this one.
Hay varios modelos.
To then sync the audio with the video. So we can just go ahead and create the table for that as well. If I just copy this video translation generation down, we'll go ahead and call this change video audio generation. We'll have the source video as free key, but also the new audio as free key like this. And that should be it. I'll just go ahead and format these tables like this so it looks decent. And then also just indent these so it looks a little cleaner. Like this and like this. And then I'll just create a relation between this one and then the user. So this will be something like change video audio generations, and then change video generation as an array. And then we should be able to push this to the database, db push. And that is all good. Now let me just close down the terminal, hop back into functions, and then we can start by implementing this translate video. So here we'll need to have translate or video translation generation, but we will not pass in the photo to video ID. We'll pass in a video translation ID instead. Then we can use this right here. And that is also what we're going to pass in from the generation file. Generation server action. So first we can get the video translation. So we'll say video translation generation. Up here we can say get video translation. Down here we can then say video translation ID. And then down here we'll not want to use this one. We'll want to say video translation, and then I think that was it from up here. We'll need to say video translation.id right here as well. We can remove this text to speech part because that is not relevant for this particular feature. I would like to keep this pre-signed URL though. So I'll remove this if statement first of all, because we do not have an experimental model. We do not have our own model. We only have the Sieve AI model. So I'll just go ahead and remove this else statement and also the if statement itself. And then we'll only want to create a single pre-signed URL, and the pre-signed URL should be for the source video. So video translation dot source video is free key like this. And then we'll just return the video URL right there, and also up here, which we'll then be able to use in our request right here. I'll just hop back into Sieve so we can see how the API looks. So it looks like this. We'll need to push to Sieve /lipsync right there. Or actually this is the dubbing feature. So we'll just hop under dubbing API and then push to Sieve /dubbing. So that is the correct one. Then I want to push the source file, which is the video URL like this. I also want to push the target language, and that should be video translation dot target language. The translation engine right here we can also just set, so let's go ahead and remove this one. So translation engine we can just set to the default one, Sieve default translator right there. Below this we can also put in the voice engine, Sieve default voice cloning. We can also put in the transcription engine, that is just the default one as well. We can also put in the output mode, this should be voice dubbing. We can put in the preserve audio background, for example, and this will be true. We can put in enable lip syncing. We'll set this to false because it is false down here as well, so we'll set it to false. The lip sync backend we can put in, this will be the sync 2.0 like that, and we can put in the lip sync enhance, which will just have the value default like this. The webhook should just stay as it is, that is completely fine. The Sieve job is completely fine as well, but this down here shouldn't be photo to video generation, it should be video translation generation. We'll also have the video translation ID, and down here we also are going to need video translation generation and video translation.id, and that should be it for this function. I'll then just hop back into the lip sync instead, and then just copy this right here, and then we'll just create another function for this last one. We'll call this one change video audio. This one will be change video audio, and here it will be change video audio generation. I can also see that we forgot to put in the correct event up here. So right here, this photo to video event is used both in the first one, but it should actually be something like translate video event. Good. Then going down to the one we were currently doing, we can also set the event for this one. This one should be change video audio event instead. We'll then have the change video audio ID, which is what we're going to store inside the events. This one right here will then be change video audio generation, change video audio dot ID, or just ID like that. Here we'll just call it get generation record, and then just continuing down we can see that we have this video translation. That should of course be something else. We'll set it to generation.user.credits. This one will be change video audio generation.id. Down here we'll have the generation.source video s3 key. Here we are going to need two pre-signed URLs though, so what I'll do is just copy this line twice, and this one will be the video URL, this one down here will be the audio URL like this, and we'll then have the new audio s3 key. Then we'll return the video URL and the audio URL, and up here we'll just say video URL and audio URL like this. Good. Then going down, we can just hop into the API, and we would like to push the Sieve lip sync. So that one right there. Then down here we are going to need the file, which will be the video URL. We're going to need the audio, which will be the audio URL. Then I'll just remove all of these, and then I would like to add the backend and also enhance. And enhance will just be default. You can add whatever you would like to if you want to test out some of these different options. I'm just adding the most common options. For the backend we'll use Sieve sync 1.1. So that one right there. And this down here is completely fine. And sorry, this webhooks down here is completely fine. Then for this, we'll need to say change video audio generation.id. Then down here, change video audio and generation.id. I think that if we scroll up to, so up here, this is video translation ID, which is what was used up here as well. We might want to use the correct one, which is change video audio ID, like that. Another thing I found before was that we only deduct credits up here. So if I just copy this deduct credits just into my clipboard, right now it was inside this else statement, and this else statement is the else for this experimental model. This means that you would only have credits deducted if you used this one right here, but not if you use the experimental model. So it of course should be outside this if statement and not inside of it. And then for the two other functions down here, the translate video and also the change video audio, we do not need to do any credit deduction because that all happens inside of the route here. And we are actually also going to need to update this just so that works as well. First though, we can just take these two new functions and paste them into the ingest routes, I think it is, right here. So we can paste in the change video audio and also the, just hop all the way up, translate video function. So this one and this one. And we'll of course just need to import this and this. And now they should be available in the Inngest dashboard to use. So let's just hop into the route.ts here and just implement what should happen if we receive any of these other kinds of events. Because right now we are only able to find this one and handle this one. So the way we do this is that we receive this job ID and we don't really know what kind of job it is. So first we can check whether the job ID is one from PTV generation. And then if it is one from PTV generation, then we handle that. But else, if it is from another generation, we'll just need to check that. So therefore I'll copy this down. And then this one should of course be video translation generation like this. And then we can say video translation generation instead of the other one. So if it's not in the first table up here, then maybe it's in the second table. If it's not in the second table, well then it has to be in the third table. So that is what we'll check after implementing this one. So now I can say video translation generation. Down here, we'll then need to say video translation generation as well, and video translation generation. We'll still need to transfer from this transient URL we got from Sieve to our own bucket, so we'll just keep this as it is. But this photo to video generation can be switched out, and this will be VT generation like that. And right here, it is also going to be video translation generation and VT generation like this. And then we'll just say webhook processed successfully for video translation, just so we have that in the logs as well. And then the last kind of webhook it can be is the following one down here. So change video audio. So we'll say change video audio generation, change video audio generation, CVA, and we'll just need to change out the table right there, and right there. And this CVA will then need to be put in these places as well, like that. So I think this should be it. I'll just check the message down here. So we have PTV, VT, and change video audio. And then otherwise the handlers should be done now. So we just need the UI to be able to test this out, because everything backend wise is set up to work with these different Sieve features. So that is fine for us. Now, one thing we can do before actually implementing the UI for both translate video and also change video audio is to build this list of our recent creations down here, such that we'll be able to see the videos that we actually start creating instead of having to go into the Inngest dashboard, into apps right here to follow the progress. And we would have to build this anyway at one point, so we might as well just do it now, just so it makes debugging easier or just testing in general easier whenever we build these other features. So if we hop into the page.tsx here, we should be able to see that we have this server component where we can query the database, and then we build it purposefully with a client home right here, which is a client component that can have use states, because in this way we can query the database for our recent creations right here, and then pass them down as properties to this client component, such that we'll be able to render out the recent creations somewhere down here. So going in here, we already authenticate the user as the first thing. And we also in this session is able to get out the user ID. So what we'll do now is say const user is equal to awaits database.user.find unique or throw. And then we'll find the user where ID is session.user.id. Then we'll also say I would like to include these tables, photo to video generations. I'd like to take 5 of these records, and I specifically would like to order these records by created at, and then descending like this to get the 5 newest ones. We'll just need to put in this one right there. And then what I would like to do is take 5 from each one of the categories. So we have the video, translation, generations, and we also have the change, video, audio generations like this. Then we can also, for each one of these, convert them into something with a type on. So I just want to change how the structure of each one of these generations look. So I'll say const ptv creations is equal to user.photo for the video generations.map like this, and we'll then get the creation. Then we can say we'll destructure all the existing properties out, but I would like to add this new property called type, which should be photo to video, and that is just such that we can render out photo to video right here, such that we will be able to tell all of these different generation types apart. So now I'll copy this down 3 times. This one should then be video translation creations. This one should be change video audio. Here it is going to be video translation and change video audio generation. And then we'll just say translate video, and we'll say change video audio like this. And then we can create a list of all of these put together in a single list. So we can say const all creations is equal to, and then we'll create a new array where we're going to take all of these PTV creations and then throw them into this list. We'll do the exact same for the video translation creations, and we'll do the exact same for the change video audio translations. So these are 3 different lists which we combine into a single list. And then another cool thing we can do is we can sort between all of these different ones. So you can say .sort, then you'll get A and B. So these A's and B's will be 2 given elements from this list, which we can use to sort the list. So for example, this is the first element and the second element, and then we can define how we should sort the list based on this. So we can say b.createdAt.get time minus a.createdAt.get time, and this short little algorithm right here will then help us sort out this by time, sort this list by time. Then what we can do is we can say const recent creations, and then is equal to awaits. And then what I would like to do right now is to get the pre-signed URLs for all of these different creations. So each one of these are going to be videos, but before we can actually play the videos, we'll need to generate pre-signed URLs for them. Luckily, we do have a helper method to do this, but we'll just need to do this for these 15 different videos right here. So I'll say awaits, and then instead of doing this sequentially, so waiting for one, then waiting for the next one, we can do all of these different ones at one time. So we can say premise.all, and then we can say all creations.map async creation. In here we can say const video URL, and then do the logic that is required to obtain this pre-signed URL. So we can first of all say creation.video s3key and creation.status is equal to completed, because we can only get the pre-signed URL if it is completed, so if this is even set. So if that is the case, what we'll do is say awaits get pre-signed URL from lib_s3, and then we can pass in the creation.video s3 key, and then we'll say otherwise we'll just set the value to null, because then we won't be able to get the pre-signed URL and we won't be able to show anything out here anyways. Then what we can do is say return, and then we can return the ID. So we'll just standardize all of these different ones because they have different properties. So we'll say ID should then be creation.id, and then title should be creation.name, date should be, and we'll say format, distance to now. Let me just see if we can import that. So this comes from date functions, so we can say import format distance from now from dates functions. So we'll just need to say npm date functions, and then we'll need to do this to just install the library. So I'll hop into the front end, install this library, and then we should be able to import it. So going down here, let me just wait for this to finish. We still can't find it. Well, then we'll have to do it manually. Import format distance from now from date functions, and then format distance, and it is actually to now, not from now. So that is likely why we was not able to import this. So what this does is that instead of being a date like August 1st, then it is going to say maybe 1 day ago. So it'll format the distance to now instead of just an absolute date. Cool. Then we can say creation.created@, and we can say @suffix true. And this is going to look pretty good when we render it out. Then we'll say type creation.type, and we can say video URL, the one up here. We can also say status is creation.status from the database. Cool. And now we can take these recent creations and then pass them down to the client home component. So we'll say recent creations is equal to recent creations. Then what I'll do is just take this dictionary right here, object, and then copy that, hop into client home, because right now it doesn't expect us to pass this down. So we just want to let it know that it should expect this. So we'll say type creation is equal to this one right here. Then we'll make this a string, this a string, this is a string as well, type 2, video URL 2, it can also be null as we just determined, and the status is going to be this as well. Then we'll say recent creations with the type recent creations, and that is a list of creation, like this. And we can then render these out. So just hopping back into right here and scrolling down to the HTML, we'll say if recent creations.length is more than 0, then we'll render out the following HTML. We'll put in a React fragment, and then we'll put in a div with class names margin bottom 4, flex items, center, and gap 1. In here, we'll put in an h2 that says recent creations, like that. And I think I just have to refresh over here and maybe even restart the server. So I'll just go ahead and do this. And the server is now restarted and works fine. So right now, this is very close to this recent creations. So we just want to make sure that there is some margin bottom 12. I think I put it in incorrectly at one point. Then going down here again, we can say class name, text, large, font, semi-bold, save that. Then right below this, we'll put in a refresh button. So I'd like a refresh button where we can click and then it will refresh the page, because the status of these recent creations are going to change over time. So whenever you click this for the first time and click generate, it is going to say queued or processed, for example, but then you would like to refresh it such that you can update the status and see what is actually going on. So I'll put in a button from ShadCN. I'll put in a refresh CW icon, and for this button we'll just need to import that as well. Then we can say on click like this is equal to, then we'll define a function inside of this. We'll then say class name, and actually we'll just take this button and make it variant ghost like that. So now it looks pretty decent. Then to be able to refresh, I first of all want the router hook, so use router from next navigation. I also want a use states that says is refreshing, set is refreshing is equal to use states with the value false. Then we can scroll down to right here and then say class name. We'll just need to do this, and then we can say if, let me just do this, if is refreshing is true, then we'll put on the animate spin class, otherwise we'll put on no classes. So for example, it is going to look like this right here. So this is what it is going to look like if it is loading, and otherwise it'll just stand still. Now if you actually click this button, we'll say set is refreshing, set this to true. We'll say router.refresh. We can also say set timeout to at least keep the spinning animation for about a second, because it might take way less time to actually reload, but I would like the user to get the impression that we're actually reloading and not just doing nothing. But it might be too little time for the user to pick up on this. So we'll say set is refreshing to false, and we can say keep this for one second. So now if I click up here, it reloads for about a second. Perfect. Also, if we're currently refreshing, we'll just return and do nothing, like this. Then below this, we can go ahead and actually put in the recent creations. So I'll put in a div with the class names flex wrap, because it is going to be a list of, or sorry, a grid of these recent creations. So making the page smaller, for example, should make the creations wrap to the next row to then not overflow the width of the screen. So that is why we put in flex wrap. I'll then say gap 6 between each creation and padding bottom 4. In here we can put in recent creations.map, and we'll say item, and then put in a div like that. We'll then say key is equal to item.id. We can also put in a bunch of classes, so we'll say class name, relative, width 64, flex, shrink 0, like this. We can also put in cursor, pointer, overflow, hidden, rounded, small, peep, padding 2, transition, all, duration 300. Whenever we hover it, we're going to lift it up just a little bit, just like we lifted up a little bit over here. So we'll say hover minus translate, and then y1, and hover shadow empty like this. So right now we aren't able to see anything, but we can kind of get the idea that something is right here. And then inside this div, we'll put in another one. We'll say div, class name, group, relative, age 36 with full, rounded, small, BG gray 900, like this. So now we're able to see the actual creations and how they kind of jump up whenever we hover them. Then inside this, I would like to make an if statement. So I'll say item.status is equal to completed, and item.video URL In that case, we can go ahead and show the actual video. So I'll put in a React fragment. In here, I'll put in the video tag. We'll then say source item.video URL like this. And then this is the if statement. So we just want to put in the else as well, like that. And now we're able to see that two videos appear, this one and this one, because these are the two that are actually completed. Then I would like to be able to actually play these videos, because right now we aren't able to. So going up to the hooks, we can add in two different hooks. First of all, I would like a use state to keep track of the ID of the currently playing video, just such that we can change the state right here, or change the UI based on which video is playing. So we can say const playing video ID and set playing video ID is equal to use states. It can either be a string or null if nothing is playing, and we'll then just set it to null. I also want to keep track of all the different videos refs, and this way we'll have a single array full of the refs for all the videos, which we can use to play and pause the videos when we click a button. So we'll say const video refs is equal to use ref. This ref should contain we'll just need to import the ref. It should contain a record with a string and an HTML video element. This string right here is then the ID of the video, and this HTML video element is the ref to the specific video. This means that if we have the ID, we can then play a specific video through this video refs variable. So it can also be null right here, and we'll then say an into dictionary like that. So first we can go ahead and set the ref down here. So going down to the video, we can say ref is equal to, and we'll get the element. We can say video refs dot current, and then item.id, because it is a record, is equal to the element like this. Then we can also go down and say class name, and then we can put in height full, width full, rounded, small, transition, all, duration 300 on the transition. We'll then put in a conditional where we'll say if the playing video ID is equal to the item.id like this, then we'll put in object contain, because right now we are only able to see part of the video because of the width and height of these boxes, just because of how they're built. But if I actually want to play the video, I would like to be able to see the full video, aka the video should be contained within the box instead of filling it out completely. So if we are currently playing, then we'll set it to object contain. Otherwise, we'll set it to object cover, like it is right now, and we'll say object top, so it goes to the top. If we say object bottom, for example, let me just say object bottom, you can see how it looks now. Then it'll align it in the bottom. We'll just say top, just because that is where the face usually is. You can also go ahead and say center or middle or something. Middle, center, and then it is going to look like this. I'll just go ahead and say top. Then down here on the video, we can also say on, play. And we can then say set playing video ID to item.id. Then on pause, we'll set it to null. And on ended, we'll also set it to null. This way we can keep track of which video is currently playing and which is not. We can then also just close the tag like this, and then right below it we can put in a condition. We can say playing video ID is not equal to item.id. So if the video is not currently playing, then I would like to show a play button. So I'll put in a div, say class name, pointer, events, none, absolutes, inset, 0. We'll say flex, items, center, justify center, and then BG black at 20% opacity. So it's going to look like that. And then we'll also put in opacity 0, transition, opacity, and we'll put in group, hover, opacity 100, like that. So now when I hover it, we can see the black background appearing like that. Then inside of this div now, we should be able to put in another div where we say class name, flex, height 12, width 12, items, center. We'll also put in justify center, rounded full, BG black at 60%. So we now have this round one in the middle as well. And you can see how it kind of looks like a play button pretty soon. And that is just what we're going to put in now. So we'll put in a play icon from the seed React. So play, save that. And now we just need to color it white. So we'll say class name, and then we'll put in text, white, age 6 and width 6. So it's going to look like this now. We still can't play it though, and that is because we haven't implemented anything to start playing the video. So let's just do that. Hopping up to where we have the code, we can go ahead and say const handle play pause is equal to an async function taking an ID, and this ID will then be used to match up which ref we should start playing. This will be a function where we say const video is equal to video refs dot current, where we try to find the ref for this ID. But then of course, if the ID is not there, which it probably always should be, but it can be null undefined, so we'll just do this for the types. We'll then say if not video return. Then otherwise we can say if video.paused, like this. Then we'll start playing. So we'll say if playing video ID and playing video ID is not the current ID, because if the video is already playing, we shouldn't just start playing it again. We should then pause it. So if it is playing and we click it again, then we pause. If it is paused, then we play. So what we can do is we can say video refs dot current playing video ID dot pause, and then right outside of this we'll say await video dot play. We'll also say else video dot pause, like this, and then we can take this handle play pause, hop down to the group right here, so that is right around here, and we can then add the on click, which we then call handle play pause with the item.id. And now if I click a video, it should first of all play, but it should also become object contained instead, so we can see the entire video. So let me just play this for example.
Hello, I'm Andreas.
And this one, I can also try and pause it.
Hello, I'm Andreas.
So we can see that that worked fine as well. Oh yeah, we can also just put in the download button. So I'll put in a button and then say download to just import this from the seed React. So now we have a little button down there. Then we'll say class name, absolute, top 2, right 2, and set 10. And now we're able to see the icon up here. We'll say flex, height 7, width 7, items center, justify center, rounded, full. We can say BG black at 60% opacity, text, white. So now it looks like this. Opacity 0, transition opacity, like this, and group hover, opacity 100. So now if I hover it over here, it is going to look like that. And then the icon is obviously way too large, so we'll just scale this down by saying H4 and width 4 on this specific icon. So now it looks like this instead.
Hello, I'm...
Also, the button doesn't really do anything, so we'll just need to make the button do the downloading. And then to do the downloading, we're actually just going to say window.open, and then it is going to be item.video URL like this, and we'll just put in the bang right here just so we let it know that it is there. We'll then say underscore blank, just to open it in a new window. Because opening a file like this from the S3 bucket, just pasting in the file into the bar right here, should download the file automatically. So for example, if I click right here,
Hello, I'm Andreas.
it then downloads. And as you could hear, it also started playing when I clicked download because we clicked this entire group. So to prevent this, we're just going to say event right here. And then we can say e.stop propagation. Then if I click download again, then it didn't start playing, and down here, it also doesn't start playing. So now it works. Then the next part is probably implementing this down here. So now we have implemented the state for showing the status whenever status is completed. But what if the status is processing, for example? So I'll just hop down here and then say diff. And I'll say class name flex, age full, width full. We can also put in flex column, items, center, and justify center as well. We'll put in another div and then say class name, flex, items, center, gap2, rounded, full, bg black, 50% opacity, px4, py2, text small, and text white like this. Then we can put in an info icon from the seed React, and then just say age 4 and width 4. And then we just need the actual text, and we can base the text off of the actual status. So right over the info, I'll put in this again. So I'll say if item.status is currently processing, then we'll write out the text currently processing like this. And this will of course need to be 2 of these. So now these ones say currently processing because these were some of the jobs we used for testing earlier on. So if I, for example, want to put in some of the other ones, we have queued, and then we can just say in line for processing. We can also put in failed. This one is generation failed. We also have the no credits, where it says no credits. And this last one I'll just go ahead and delete. So now we can just take some of these different ones. So we can take this one, say queued. This one can say failed. And this one can say no credits. Then if I save these, hop back up here, it is going to look like this. Generation failed, in line for processing, and no credits. Another thing we can put in are the durations of each one of these videos. So going down right here, we can say playing video ID is not equal to item.id, because we don't want to show this little box with the duration of each video while the video is playing, because that means you can't see the entire video. But if it is not currently playing, then we'll render out this React fragment. So we'll say and. In here we can put in, first of all, a span with a languages like this, then say class name age free with free like this. Inside the span we'll put in bg opacity 60. We'll put in absolutes, bottom 2, left 2 like this. We can also put in rounded, bg gray 800, px2, py 0.5, text extra small, and text whites like this. So we have this little symbol down here showing what kind of video it is now. Then if I just copy this span and then just paste it in right below, but instead of left I'm going to say right. Then what I can do is I can put in a little duration thing here. So if I say 0005 for example, and then just make this a string, you would then know that the duration is 5 seconds long if this is something, for example. So we just need to measure the actual duration of the video because right now it's just hard-coded. So we'll use a little trick to do this. First, we'll hop up to the use states. Then we'll say const durations set durations. And then this is going to be equal to a use states with a record and then a string. This is the ID of the video, number, that is the duration of the video, and the default value, which is going to be an empty object like this. And then as soon as the page load, we're going to use a use effect to do some logic. So we'll say use effect. This will allow us to execute some code as soon as the page load. And if recent creations change, then we're going to redo this calculation of how long the duration is of a video. So we'll say recent creations dot for each creation if creation dot video URL and creation dot status is equal to completed. Then we'll say get video duration and then just implement this function right here. So we already have something like a get audio duration. So get audio duration right there. So inside this same file, we'll just paste in this one again, call it get video duration instead. This one will of course be a video and it'll not say audio, it'll say video. These places instead. We also do not need this, and I also want to pass in a URL, URL, which is a string. I then want to say video.preload is equal to metadata, because the metadata is going to contain the length of the clip, I think. And we'll then just remove this and resolve to video.duration. Otherwise down here, we'll remove this as well, and then say fail to load video metadata. So this right here should then get the video duration. So I'll go ahead and just copy this, hop back in here, import that. And then we can call the function with the creation.video URL, say dot then, and then we can put in the duration. Then we'll say set durations, and this should be durations with an S. And right there, because this should contain the durations for all the different videos. So we'll say set durations, then we can put in previous like this, say dot 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 previous to leave all the existing duration of the videos as they are. But then we can, for this specific video, say creation.id duration like this. And then down here, we can go ahead and say dot catch. In case anything happens, we'll just say console.error as the function. And then it is going to be printed out to the console. Now this duration should then contain all of the durations of these videos. So going down here, we should be able to paste it in. So we can say math.round durations item.id and then postfix it with a S like right here that says seconds. And we also only want to show this because as you can see over here, it says not available seconds. So we only want to show this if durations item.id is not undefined like this, because then we won't get this error as we saw over here, because right now it doesn't know if it is undefined or not. But because we make this check up here as well, we can just put in the bang to let it know that it is always going to be there. And the reason we got this not a number error, or not a number of seconds error, is because if it says no credits, for example, or generation failed, then we aren't even going to have a video source file to play, let alone find out the duration of the video, because there is no video. So now we have the duration of each video here. Then I also want to show the actual title of the video, and then I also want to be able to let the user change the title if you want to. So going up here, we're going to need to define a couple of use states before the user can do that. First we'll say const, and then editing ID, and set editing ID is equal to use states, which is a string or null if nothing is currently being edited. We'll also create a editing type and set editing type. So we want to know which database table we should update. So if you just hop into right here, we have these three types: change video audio, translate video, and photo to video. So if the type is this one right here, for example, well then this is the table that we're going to update and not these other two ones. So that is why we are tracking this type as well. Then we also want to have a editing and then title. So what we're changing the title to, like this, and this is just going to be an empty string, like that. Then we can just create the functions which will need to actually change these things. So we'll say const handle title update. This is triggered whenever you want to actually change the name. So for example, if you type in a name, press enter, or leave the field, it should then just update. This will be an async function, since we'll call a server action to perform the mutation in the database. First of all, I'll say if not editing ID, because this editing ID can be null, or not editing title, because that should be filled out as well, or not editing type. Then we'll say set editing ID to null and just return and do nothing, because all of these should be set before we can even do anything. Then we just want to create a server action for doing this. So I'll just go ahead and hop into actions, new file, creations.ts. Then I'll say use server, and I'll say export asynchronous function update creation name, and it is function like that. We'll pass in an ID, which is the string. We'll pass in the name we want to change it to, and the type in the database which we want to update. Cool. Then we can say const session, and we might as well just copy this part from somewhere else so we don't have to type it in ourselves. So if I just copy this one right here, it is just going to let only authenticated users use these server actions. So we'll need to import auth and headers and redirect, and then we're done. Down here we'll say const and then updates data is equal to, and the things that are going to vary in between these different types, things that are going to stay the same is the where clause. So ID, user ID, session .user.id, and we also want to always change the data to the new name. So regardless of what type it is, we are always going to edit it with the specific ID where the user owns it and set the new name. Then down here we can say if type is equal to, and then photo to video, which is what we also defined in here, photo to video. Then we'll say awaits database.photo to, let me just import that, photo to video generation dot update data. So that is the first case. Then I'll just put in two else ifs, else if and else if. The second one is going to be translate video, and the third one change video audio. This one is translate video generation. This one is change video generation, and then we'll say else throw new error invalid creation type. And lastly, because we are changing the name, we can say revalidate path to make sure that the frontend sees the new name by invalidating the database queries, so they'll be refetched immediately. Cool. So I'll then take this update creation name, hop back into the client home, and then we'll hop down here and say awaits update creation name, editing ID, editing title, and editing type like this. Let me see, we just gotta import that. ID, name, and title. Sorry, ID, name, and type. Then we can say set editing ID to null and set editing type to null as well, just to make it a clean slate. Then down here, right below the actual video, so down here, let me just see, yep, right under each creation, we'll put in a div, This div should have the class name, padding 3, padding bottom 1 specifically. Then we'll say if editing ID is equal to item.id. Then we'll put in an input that is of type text. So we'll say type text like this. And then let me just see what goes wrong. We just need to put in the else statement. The else statement will just be a div containing the item.title, like that. So now, because we aren't editing any of these, we just see the title. And we can then start by just styling this div. So I'll say class name, cursor, pointer, text, small, like that. Then we'll say on click, because if we do click this text right here, it should toggle the editing feature. We'll then say set editing ID to item.id. We'll set the editing title to item.title, and we'll set the editing type to item.type, so we know which database table to update. Now, if I click this right here, nothing really happens because we only show this input field right here, which we can't see, but we're able to see that we can click this and then type something in if we would like to. So that is kind of what we're going for. Now, this input up here, we can then say value should be editing title on change. We'll say event set editing title e.target.value. We also want to put in an auto focus. So once it appears, it immediately focuses on the field. So let me just try and click right here. Sorry, right here, for example. Then it immediately focuses on the field. Also, if I say class name, we can say width full, rounded, border blue 500, BG whites, padding of 1, text small, and shadow small as well. So it looks like this or this. Great. And then whenever I click the field right here, type something in and leave the field, that event is called onBlur. So onBlur is just leaving the field. It is the opposite of focus. In that case, we'll call the handle title update and actually update this. So if I say hello, I'm Andreas, to leave the field, then it should update the entire thing. So now the name is hello, I'm Andreas 2. If I refresh here, it's still hi, hello, I'm Andreas 2. Then I can say on key down, and then we can do a function inside here as well. So I'll just say we're going to receive an event. Then I'll say if event.key is equal to enter. Then we'll say awaits handle title update. And then we can say else if e.key is equal to escape. Then we'll say set editing ID to null, like that. Now we just need to make this async before it works. Then going back in here, I can just rename this again, hello, and then I'll press enter, and now it immediately saves. I can also say hello, I'm Andreas, press escape, and then it immediately exits. We can also hop down to below here and then put in another div where we say item.dates like this. And then because this is the date from now, it says about 5 hours ago, etc., about something hours ago. So we'll say class name empty1, text extra small, font light, tracking white, and text gray 400 like this. And then I'll just find the dot symbol. So this one maybe, and I'll just try and copy this dot right there, paste it in right here, and then continue with item.type. So it looks like this, about 5 hours ago, dots, and then photo to video, or whatever we might have, translate video for example, whenever we create one of these. Now let's get started with these two other modals, translate video and change video audio. We already have two of these. We have the translate modal open and change video audio open. So we can take these and then just use these to render out two more components down here. First, I'll take the photo to video modal and just copy this. And I would like to call this video translation modal, like that. Then in here we can put in video translation modal, and then just copy the name, hop back in here. I like to just copy this down and then say video translation modal, and then we should be able to open this up now. Or actually we need to say video translation modal open. So it is translate modal open and set translate modal open. Good. And now we should be able to open up this one and this one. They look the same right now, so we just gotta change it up. First of all, we can go ahead and remove these sample photos. Then we can remove most of these right here actually. So I'll just go ahead and remove all of these use states and this one. And then I would like to go down and just comment out this entire handle generate video for now. Then down in the HTML, we'll go ahead and go into the dialog header, right here, and then remove everything inside the modal. So right here and all the way up. Good. Then we'll just take this audio upload modal as well and choose voice modal, just remove those. And now we have a component that at least looks pretty bare bone. So we can put in video translation, and then we'll just remove this. In the description, I'll then say translate with original voice and lip sync to, and then I'll put in a span where I say, I forgot the up to, and then I'll say 3 minutes in length. Cool. Then what I'll do is just take this span right here, say class name, text, purple, 600, like this. And then for the use states in this component, we can go ahead and I'll just remove this actually, because it's quite a lot and quite annoying. So I'll say const step and then set step, because this will be a step-based component. So we'll have a step 1 where we can upload a video, and then we can also have a step 2 where we can select a target language. So this will be a use state with the value 1 for the first step. We'll then need to have the user select a video file, set video file to. This can be a use state, which can be either a file or null. We can also have the URL for the same file, which we can use for previews. So this is the file we actually upload, the video file containing the file, and this is the video file URL. So just video URL and video URL like this. And lastly, we're going to need the target language and set target language, which is equal to use state, string or null. And I'll just set this to null because by default no language is selected. We are likely also going to need a loading state. Loading, set loading is equal to use state, and then we'll just set this to false like this. And then if we are in step 1, so down here in the, and I'll just remove this div right there like this. Then down here below the actual header, I'll put in an if statement. If step is equal to 1, then we can show a drop zone. Right now we only have an audio drop zone like this, but I just want to create one for videos as well. So if you just go ahead and find this audio drop zone, copy it, then call it video drop zone. Then hopping into the video drop zone, we can just say video drop zone and import that instead, like that. And then this just needs to be a little bit different. So instead of audio, it should say video at least. And down here, we can say Supported formats, we can just say browse local files like this, and then we'll say upload a video, and then we will accept video MP4 like that, and just remove this comma as well. Oh yeah, we can also put in a video icon right there instead of just the normal upload cloud. Cool, so this should allow us to upload a video specifically. Then in here we can say on file select, and we'll just create a handle of this because it has quite a lot of code. So I'll say const handle file select is equal to an async file of type file. Here we can say async like that. In here we can say try, and we can say catch, and then if any error happens we'll just say toast dot error could not read the video file like this. In the try we'll say const file URL is equal to URL dot create object URL, passing in the file because we need both the file and also the URL for the preview. Then we can get the duration of the video because we can only upload up till 3 minutes of length, remember. So I'll say const and then duration is equal to await get video duration, which we created earlier, so that's pretty neat. File URL. Then we can say if the duration is more than 180 seconds, aka 3 minutes, then we'll say toast.error, and then video must be 3 minutes or less. That sounds better. Then we can say URL.revoke object URL file URL, and we can say return like that. Otherwise, if it is under 3 minutes or 3 minutes, we'll then say set video file to the file. We can also say set video URL to the file URL, and we can advance to step 2, so set step 2, because now the video has been uploaded. So I'll take this handle file select, paste it down in the on file select, and then if I click here now, we should stop seeing something. Or actually we won't be able, or yeah, we will be able to because we rendered this based on the step. So if I right here just select one of our videos, this one for example, then we are on to step 2. Step 2 is going to consist of a grid showing the video over here, and then the target language over here on the right. So we can say if step is equal to 2, then I would like to render out a div, class name grid calls 1. Then we can say gap 8 between the grid columns, md grid calls 2. And then we can say div, class name flex column, and gap 4. And here we can put in an h3 saying source video like that. And we'll just go ahead and style this with font semi-bold. And then we can just put in a div with relative, so we can put in both the video and also an icon absolutely positioned to then remove the video with the trash icon. So we'll put in a video if the video URL is set. So if video URL will render the video like that with the source video URL controls to pause the video, for example, and then also the class names with full and rounded large. So it will look like this. Now the button right below this will have variant, ghosts, size, icon, and it'll have a trash 2 icon inside of it with the class names height 5 and width 5 like this. So we'll just need to style it a little bit more. Class name absolute. We can say top 2 and right 2. And because we have it inside a relative, which the video fills out entirely, we can then place it right there. Then we'll say rounded full, text white, BG black 50 and hover BG black at 70% as well. So it's going to look like this. Now when I click this button right here, what should happen is that we should clear the video file that has been selected and then go back to step 1. So we can say on, click, like this. We can then say set step 1, set video file null. So if I click it right now, then we're taken back to the first step and we can select the new video.
Hello, I'm on.
Oh, that was... Now if I right here click or hover this, sorry, I would like the icon to be cursor pointer. Like this, cursor pointer. Also, it changes color to become dark. So this one, I'll just say text white, and hover, I'll also just say text white, just in case. So now when we hover it, it just looks like this. And let me just see which one it is. Can I just remove this? No, I need to remove the hover text white. Great, so now it looks great, both when hovering and when not hovering. And then down here, we can put in another div, class name flex column, and gap 4 like that. So this is going to be the right side of the grid. In here, we'll put in an h3 saying translation settings. And right now, if we make it larger, it should then take up 2 columns instead of just 1. So let me just see if we did something wrong up here. Grid columns 2, great. So it should look like this. And then only on mobile, it should break down into a single column. So now it works. Then we'll again just say class font semi bold to make it look like the other one. Beneath this, we'll put in a div with a label. The label should say target language, and I'll just make this lowercase, class name, and then text small, font medium. And then below the label, I'll put in a select from ShadCN. So we have this one. In the select, I'll put in a select trigger. In the trigger, I'll put in a select value. This value will have the placeholder choose language like that. And we'll just need to make sure that this is imported. Or actually, I forgot this quote symbol right there. And then below this trigger, we can put in a select content with the class name maximum height 64, because this will be quite a long list of different things to choose between. Also, I think this trigger is pretty close to the actual label. So I'll hop under trigger, say empty1, and with full, so it looks like this now, which is better in my opinion. And then for the actual languages to choose between, I have generated a list of languages with ChatGPT. So you can just go ahead and head to the GitHub and then copy this entire list. And only some of these, all of these are supported, but only some languages are supported. So hopping into lip sync right here, we should then be able to see, and it's not lip sync, it is dubbing. We should be able to see the supported languages in the README down here. So going down, we have all of these languages, and these are the supported ones, which I've then made into a long list, which we can use to render out the picker. Good, so going down to right here, we should hop in and then say languages.map, language, and then for each language, we'll render out a select item with lang.label being shown. We'll just add the missing attributes. The value will be lang.value, and we'll also have a key because we're inside a map that is lang.value like this. So now we should be able to choose between the different languages, And the max height right here comes in handy because otherwise the list would be huge and probably overflow the bottom of the screen if you have a screen that isn't that tall. Good. So now we have step 1 and step 2, and now we need a back button and also a way to actually generate the video if you're ready to do that. So going down here, we can put in another div with the class name mt4 flex and justify between mt4 like this. Then we'll put in a button that says back. The button should have the variant outline like that. And we should have an on click. And that's, in this case, we'll say if step is equal to 1, then we'll on open change and set this to false to close down the modal. Otherwise, we'll set step 1 if we're in step 2. Good. So now we're in step 2. So if I click back, we go back to step 1. If I click back, it closes the modal, which makes sense logically if you are a user. And then in here, we can say if step is equal to 2, then we'll render out an arrow left icon like this with the class name mr2 h4 and width 4 as well. So it's going to look like this on page 2. But on this page, we know we're going to close the modal, so we won't show a arrow back icon. Good. And then if you're on page 2, we can show the generate button. So right under this, we'll say step is equal to 2 and button translate. Cool. Then we'll also just say on click. And we don't have a way to actually do this thing yet, so create the video or translate it. So we'll just go ahead and put in an empty function right now. But we can at least say class name bg purple 600 text white and hover bg purple 700. So it looks like this now. Then I'll just put on cursor pointer as well, so we can hover the button. And I'll put in the loading state. So if loading, then we'll put on loader2, class name mr2, height 4, width 4, animate spin like this if we do click it. The button should be disabled though if no target language is selected. So disabled if no target language or if we are already loading. So right now nothing is selected. If I select English, then we should actually be able to click it right here. So maybe loading is set to true. It is not set to true. So I think this target language actually doesn't synchronize with the use states. So going down here, we have the set target language. It has never been being used. So going up to the select, we can say on value change, set target language. Now if I pick a target language, it works. If I click translate, and nothing will then happen. So going up here, we can say const handle translate is equal to an async function. In here we can say if not video file or not target language, then we'll say toast.error. Please select a video and target language. Shouldn't happen ever though. Then down here we can say set loading to true to signify to the user that something is happening. And we can then get a pre-signed upload URL for the source video right here. And actually it says source voice. It should be source video like that. Cool. Then down here we can say await const hello is equal to await get pre-signed URL. We'll pass in the video file.name and the video file.type, and we'll just need to create a new purpose. So it is not this pre-signed URL actually. It is this one from actions generation, and then the purpose which we'll create should then be video translation source. And then hopping into this one, we can say if purpose is equal to video translation source, and then the folder will be set to VT for video translation. Good. Then we can just set the purpose here as well, video translation source, and then we get back the URL and key. So we'll get a URL and a key back, and we can then upload our file to this URL. So we'll say awaits fetch to URL with the put method with the headers content type, and that should be the video file dot type, right? And then we'll pass in the body, which is just the video file itself. Cool. And that should take care of the uploading of the video to the S3 bucket. Then we just need the server action under generation to actually enqueue this job. So going down, we'll take this right there and copy it. Then down here, I would like to call this translate request. And the things we are going to need are the source, it's the source video S3 key, and also the target language, like this. Cool. In here we can then say translate video, and then translate requests, and here we'll then say translate video generation, video translation generation, and then the user ID and status are fine, but we'll remove all of these and maybe just keep these two. So the name, we can still use the same method to determine, except that we'll create some kind of split between the dates. So let me just use the date right here, and then also the target language to determine the name. So something like this, translate request dot target language. So the name will be the date and then also the target language. And then we'll have the source video as free key, translate request dot source video. The target language will be translate request dot target language. And that should be it for this. We also just want to send it to the correct event, and that is translate video events. We'll have the video translation ID. So this is video translation, like this. And I just want to make sure that this is actually what we use, and it is. And we also have the video translation ID, so that matches up as well. Cool. So this is what we need to actually enqueue this type of job right here. So going into the modal, this is what we can do. Awaits translate video, import this from actions generation, then say source video as free key, that is the key. So the key right there. And we can also say target language, which is the target language. And then as we did in the other modal, we can say toast.success, translation, job queued. You will be notified upon completion, like that. Then we can say on, open change, set it to false to close the modal, and we can say set loading to false because we aren't loading anymore. And then what I'll do is take this handle translate, hop down to the button which we created earlier, and then just put it in right there. Cool. Then I just want to do one more thing. Down here we can just put in a use effect that resets the state of the modal whenever we close it. So we can just say if not open, then set step 1, set video file null, if video file URL.revoke object URL, video URL. So let me just see if video URL actually. Then we can say set video URL to null. We can set the target language to null, and we can set loading to false like this as well. And it depends on the video URL and open. So we'll add these to the dependency array, open and video URL like this. Now if I then hop over here, I'll just refresh and then say translate video. I'll upload this one and just play this.
Hello, I'm Andreas.
And then I would like to translate this to, let's say, Danish. Hit translate. Translate job is cute, spelled incorrectly though. Cute like this. Then we can just see that it is in line for processing. If I click right here, it says currently processing, so it looks pretty great. Then hopping into Inngest development, I just refresh. We can see that it completed up here, and then we should be able to see it in Sieve. So it is currently processing, so whenever this is done, I'll come back. So it just finished here, so we're hopping back into this place. Let's just try and refresh. And now we can see the video, so let me just try and play this.
Hej, jeg hedder Andreas.
So that is definitely Danish, and it works end to end. It's also pretty cool that we set up this before. So we set up the following, where we check both for the photo to video generation. If that is not it, we check for the video translation. If that is not it, we check for the change video audio generation. And if that is not it, which it should be one of these, it'll throw an error. So we have covered all of these three features in the webhook already. And now we just need to implement the last one, which is change video audio. Let me just try and download this as well. And we're definitely able to do that too. So good job with the video translation modal. We can now get started with the change video audio modal right here. It is actually very similar to the translate video modal, because in both cases we'll need to upload a video. In this one we just need to specify the target language though, whereas over here we'll need to either upload some audio or record some audio with the modal that we created for doing exactly that. So because they are so similar, I'll hop into this video translation modal, and then I would like to copy this component and just call it change video audio modal.ts. Then we'll go ahead and just remove this big array of languages. And then down here, we can just remove this part as well. So I'll just remove all the contents of this inner div. Then going up again, we can just rename the component. So we'll say change video audio modal like that. And then I'll just go ahead and copy this, hop into client home, and then down here, we'll just go ahead and copy the component. And actually now I'll need to copy this again. And then import change video audio modal like this. Then up here, we'll just need to use the correct state variable. So change video audio right there, and then set change video audio open. And now I should be able to open up this component right here, and then just change the contents of that. So one thing we'll need to do is definitely remove this target language, because that is not at all what it is supposed to do. We are going to need a video file though, and then also the video URL, because we are going to upload a video anyways. One thing we'll need to do right here though, that is new, is upload some audio. So I can put in audio file and set audio file. And then down here for video URL, we can put in the audio URL just so we can make a preview of the audio as well that has been uploaded. And lastly, we can also put in audio name and set audio name like this. And this is simply just for setting the audio name if you, for example, go ahead and record some audio. Now, one more thing we can do, because we're working with audio, is use the hook which we used earlier on, called use audio player, because this way we can actually play the audio for the user if he clicks a play button. So I'll say const and then hello is equal to use audio player. And then this hello right here destructures to playing source and toggle play. So toggle play like this. Then let's go down to where we return the HTML. So actually we can leave this up here as it is. and then just go down to here. And then the dialog title should say change video audio. The description should say replace the audio of your video with a new track. The video can be, and then we'll say up to 3 minutes, in length. I think this is completely fine. Up to 3 minutes in length. So we'll need to put in a space like that, and then it looks good. I'll just put in a dot right there though, like this. So the video drop zone and step 1 right here is completely fine, because we'll need to upload a video first of all anyways. So what I can do is just upload a video now, so we can check out the next step, and then we see target language is not defined. So let me just go ahead and remove everything target language related. So I'll just go ahead and remove these lines, just so we can move on. This I'll just go ahead and comment out. Up here, I'll remove this as well. And then we'll go ahead and refactor those places in the code when we get to that in a second. So now we're able to see that we have the source video, and now just need to put in a place where you can upload the actual audio. So going down here to step 2, the source video is all fine. I can also click delete like we were able to last time. So going under this part right there, we want to implement this part over here. Or actually this part right here, because that is what is on the right side of the modal. So in here I'll put in an h3 that says new audio, save that. Then we can style this with the class names font, semi-bold. If we hop onto this, we'll put in an if statement. We'll say if audio URL and audio name. Then we would like to show the actual uploaded audio. Otherwise, we would like to have a button that allows you to actually upload some audio. So I can put in a div, then we'll say class name, and then flex. And I think we might already have an upload thing, or a drop zone it is called. So what I'll do is just take and search for H48, like this. Then take the audio drop zone right here. Just copy this, and then we'll change it a little bit, because what we have right here shouldn't be functional. It should only open up something else. So I'll paste this in, import the upload cloud from the C direct, and then I'll remove these right here. I'll actually keep the on click like this. I'll just comment it out, sorry. Then I'll remove this input. Then under upload a file, let me just do this. So I want it to look like this right here. Then under this on upload file, we'll say upload or record audio, like that. We can also say click here to select an audio file or record a new one, like that. If I do click this upload right here though, I would like it to open up a modal. So we just need to keep track of whether the modal should be open or not. So we'll say const audio modal open, and set audio modal open is equal to a use states that is false per default, like that. And we can then set that variable to true down here if it is clicked. So we'll say on click, and then we'll say set audio modal open and set it to true, like that. Cool. So if I save this, click upload a video, and then we can now click right here, it doesn't do anything, and that is because we just need to put in the component down here for actually showing the recorder and uploader. So going down under this dialog right here, we can put in an audio upload modal, like that. And I'll just say wrap in JSX fragment, because we can't have 2 root elements at one time. So we'll need to wrap both of these elements, this one and this one, in a reg fragment like this. Good. So let me just see if we use this anywhere else that I can just copy from, like that, for example. So here I'll just copy this entire implementation, paste it in right here, and then this will just be set audio URL instead of selected audio URL. Here we'll have set audio name, like that. In this example though, we aren't really getting the file which we need for set audio file. audio file right here. So I would like to create a file up here so we can set this variable. So what I'll do is go down and say const file is equal to, then we can say audio blob instance of file. If that is the case, then we'll say audio blob. Otherwise, we'll create a new file where we pass in the audio blob and also the name of this. So to get the name, we can do something like we did right here. So we'll just pass that in as the second parameter. And for the third parameter, we can pass in the type and audio blob dot type like that. Then we can say file, copy that, head down and remove this. And then the audio name will just be file. Sorry, the audio name will be file.name. The audio file will just be file, and this is just perfectly fine. So now if I go over here, we should be able to open it, upload a file that is audio if you would like to. And then right now this is gone because we aren't rendering out the case where it is selected. So to do this, we can put in a div, for example, then say class name flex column, justify center, rounded XL, border, BG, gray 50, and padding 4, like that. Inside the div, we can put in another div. We'll then say class name flex items center and gap 3, like this. Then we can put in a play or pause icon. So I'll put in a button first of all to trigger the playing or pausing. In here though, I can say playing source is equal to the audio URL. In that case, we'll say pause because it is playing. So I'll say pause like this. Then we can put in an else statement where we say play. And just import this as well. So now we have the play icon because it is not currently playing. So if I hop into the button, then say on click. So on click, we can say toggle play, pass in the audio URL to start playing. And also we can just say down here, class name height 5, width 5, and text gray 600, like that. And we'll just do this for both icons. So both right there and right there. Then right below the button, we can put in a div. And we can put in a span where we say audio name. And we'll then say class name flex 1, flex column. And for this span, we'll say class name text small and font medium, like this. And then what I'll do is just space these apart a little bit more. So hopping up at the bottom, I'll say class name, margin right 2, so they're a little bit more spaced apart. Cool. Last, we can just put in the trash button over here to actually discard and record or upload a new piece of audio. So what we can do is hop under this, create a new button. Here we'll say trash 2, and I'll just say class name height 5, width 5, and text gray 600. And then for the button itself, we'll say on click, and then something like set audio URL to null. We also have the set audio name, which we can set to null, and we can also set the audio file to null as well, like that. So that should clear up everything. Now if I click play right here, first of all,
Hello from Modal.
we can see that it works. If I click delete, we can see that we're also able to do that. If I record some audio like this, use the audio and just play this. If I record some audio, we can see that it works completely fine as well. So it all seems to be working as it should. Well, I'll just select this as well. Yeah, so it seems to be working just fine. So hopping down to the button right here, we have this translate button. I would like to call this generate instead. And then it should be disabled if it is loading as well. Sorry, if we don't have the audio URL. So if we are loading, so this is actually wrong. So if we are loading or the audio URL is not provided, then we should disable the button. And then the rest right here seems perfectly fine. So I can click back, upload a video again, and this works completely fine. Then if I remove this, we can't click generate anymore. So that works fine as well. Going all the way up to these methods up here, we have the handle file select. All of this is actually completely fine because we specify here that the video can be up to 3 minutes in length, and that is the requirement we had for this translate video modal as well. So we'll leave this as it is, hop down to handle translate. I'll just call this handle generate instead. Generates. Go down to this, call the handle generate function instead. And if we then go back up, we'll say, instead of not video file, we'll say if not video file or not audio file, please select a video and an audio file, like that. Down here at the pre-signed URL, we actually are going to need a pre-signed URL for both the source video and also for the new audio. So hopping into this get pre-signed URL, we'll just add 2 new purposes. We'll add one called CVA video and one called CVA audio, like that. Hopping in here, we'll just copy down this, say CVA video, or purpose is equal to CVA audio, like that. In this case, we'll put it into the CVA folder. Then I'll hop into change video audio modal, and then I would like to say awaits promise.all, and then put in these 2 fetches. So this one is the first one. So we'll just remove the awaits, and also this one down here. Then we can say comma, and then put in this one. So this will be CVA video. Down here we'll have CVA audio. This one will be the video file name, video file type. This will be the audio file .name, and we'll also have audio file .type. Then down here we can also put in these fetches into a promise.all. So first though we'll need to say video audio and video upload, and also the audio upload, like that. Then we'll take this fetch down here and just say awaits promise.all, put in an array with a fetch and another fetch. This will then be the video upload.url. Down here we'll put in the audio upload.url. This will be the video file type, video file. Here we'll just need the audio file and the audio file down here as well. Another thing is that right now we commented out this one right here. So we'll need to hop into this server action and then just create another one for the change video audio. So I can just copy this, call it change video audio, and we can call this change video audio request. And this will be just request to make it simpler. We'll have the source video S3 key. We're also going to need a new audio S3 key for this one over here. We'll also need the video name, like this. Then what I'll do is hop down here and then I'll say change video audio generation. The name will be the request dot video name. We're also going to need to pass in the source video S3 key, so we'll have request dot source video S3 key. Then I'll just copy this line down, remove the target language, and then I'll call this the new audio S3 key, both right there and right there. Then we'll just need to change this to, if I hop into functions, we can see that we have the last one down here, which is change video audio events. So I'll copy this into the event, and then we are going to receive the change video audio ID and the user ID. So change video audio ID, change video audio, like that. So we authenticate the request up here in the start, and then we are going to receive the following properties. We then create a record in the database, and then we send off the job to the ingest queue. Lastly, we revalidate the path down here as well, such that it updates over here under recent creations. Cool. Then closing down this generation.ts, we can say change video audio from actions generation. We'll need to pass in the video upload.key. So that is from the pre-signed URL we generated up here. We have that property right there. We can do the same for the new audio as free key, which is the audio upload.key instead. Then we lastly just need to put in the video name, which is video file dot name, like this. So this means that this video file, which we have right here, will have the original name of the video file that was uploaded. So that is what it does, in case you were wondering. Now let me just hop over here and refresh, and then I'll say change video audio, and then I'll take this one for example.
Hello, I'm Andreas.
Say upload, and then let me just find some audio. So
Hello from Modal. This is a test of...
So I'll take this one just for testing, say open, use this audio, and then I'll click generate. And now we see the job is queued. So let me just return whenever this is done. So I've waited a couple of minutes, and now let me click refresh and check out the results.
Hello from Modal. This is a test of Chatterbox.
So as you can see, the video audio was successfully translated from whatever it was to this new audio file, which we picked. Going down here to this use effect, I can see that we forgot something. So we have both the video URL, but also the audio URL. Then I'll say if not open, so if it is closed, we'll return to step 1, set the video file to null, revoke that URL. But we just want to do the exact same for the audio. So we'll just say set audio file, and then audio file right there, or it's actually the audio URL, both there and also right here. And then down here, it's going to be audio URL. And now I actually forgot to do the video one. So set video URL to null. And then doing this with the audio URL, we'll need to do it after revoking the URL. And then lastly, we can just say set audio file, set it to null, and then we should be good. So what it means is that if we just hop in here, pick a few things like this, close down the modal, then what it should do in theory is just replace all of these things. So it's all brand new, no audio was picked, and also no source video was picked. So that worked completely fine. Good, so with this done, I'll go ahead and move to the next part, which is setting up the payments. So right now, we are not even showing the credits of the user down here. So what I would like to do is just start out with doing that. First, let me hop under components, then say new file, and I'll actually put it under the sidebar right here. New file, credits.tsx. In this file, I'll say export, asynchronous, and then function, credits, like this. In here, we'll say return, and I'll just return a React fragment, and I'll make sure that this is a server component by saying use server, because otherwise we won't be able to query the database to find out how many credits the user has. So what we'll do first of all is just authenticate. So I'll say const, and then session is equal to await auth dot, and then we'll need the API dot get session. Then we can say headers is equal to await headers. Down below we can say if no session will return null, render out nothing. Headers will just need to import like that. Otherwise, we can query the actual database by saying const user is equal to await database dot, which we'll just need to import dot user dot find unique or throw, where the ID matches session dot user dot ID. And then we'll say I would like to select the credits column specifically. Select credits where also select credits by saying true right there. And now we should be able to access this credits field on the user object. So down here, we can put in a span that says user.credits Right below the span, we'll put in another one that says credits in text. And then we can put in class name, font, semi-bold, and we can also say class name, text, muted, foreground, like that. And then hopping into the app sidebar, we can import this credits right there by saying credits, importing the component, and then it should show up down here whenever we refresh or something like that. So 99 credits. Then what I'll do is say class name, margin bottom 2, and then we can also say flex, width full, items center, justify center as well, gap 1, text extra small, and now it looks pretty good like that. Then before we can put in this upgrade button and also the customer portal, we'll need to just set up payments, and we'll do this with Polar.sh. One thing I've just noticed though is that we have 99 credits left, but we have made all of these different generations, which means that we should have much less than 99 credits left. So we'll just hop into the functions.ts and then find this deduct credits function. And we can see that it is only here once. So what I'll do is just copy the function declaration, then hop down to this next job, and then we'll paste it in as the last step. So right there, we'll paste in the deduct credits. It should be called video translation right here though. Then going down to the last events or last function, we'll just need to paste it in right here as well. So pressing enter twice, going down here, taking the generation. So we have generation up here. Let me just find the generation. Generation has user like that. So I can say generation dot user dot ID, and that should allow us to update the credits. Or actually, that is not it at all. I'll just remove that change we just made. And then it is up here, generation dot user dot ID. And now we should have credits deducted regardless of what function we're using up here or what feature we're using. So that was just a small bug, but that is fixed now luckily. So now we can move on to payments. We already have BetterAuth installed, so we'll just need to integrate with Polar.sh to actually use payments. So I'll first of all say Polar.sh and then BetterAuth, like this. And then just find the official documentation right here. So we'll need to install these npm packages, hopping under the terminal. Then going under Frontend, we'll need to install these. We need to use npm, not pnpm, or at least in my case I do, because I use npm. Then going down, we just need to have this Polar access token. And before we can get this, we'll need to hop into the Polar dashboard and then set that up. Therefore, I'll just hop into Polar.sh, log in. So I'll just go ahead and use my GitHub repo or GitHub account. And now we are in. So if you are logging in for the first time, you might need to set it up by just specifying your first workspace. I've already done that. So after doing this, I'll hop to the sandbox mode because we just want to test it out for now. Continue with GitHub again. So this will allow us to create an environment where we can't really do anything that affects the real life, affects the real world. We can create fake products. We can also purchase these fake products with fake credit cards, but nothing will happen to our real money. So going down, we can create a new organization. Organization name should be something like HeyGen clone. At least in my opinion, at least in my project right here. Feel free, of course, to call this whatever you would like to. Then going down here, I'll say I understand and create. And we'll just skip this right here. Good. And then we can hop under settings, go down and create a new token. And then I would like to select all, say no expiration, and create this token. I'll just say app development, create, and then we have the token right here. So hopping under environment right there, I'll just say Polar is equal to, and this right here. And let me just see what it actually was. Polar access token, like this. So now we should be able to successfully connect to the sandbox environment whenever we create the integration. Cool, so I'll just search for this right here. Auth is equal to BetterAuth. Hop into the auth.ts file. Then we'll need to create this Polar client. So we'll just paste this in right here. And we'll just need to import Polar. So Polar will need to import from the following path. It's right there. And also we can just make this type safe just so we always have it available. So I'll copy this Polar access token, hop under server, say that this is a set.string. And then down here we can say Polar access token process.env.polar access token. And then we can replace the process.env with env.polar access token. So it is type safe because now we can see that it is a string and we always know it is going to be there. Then I'll just remove these comments like that. Going down here to under email and password, we can then see that we can put in the plugins like that. So I'll put in plugins, which is an array, and then we'll import Polar right here. So, or not import, we can, or actually it is an import. We'll just need to take this line, paste it in right there. And then down here, we'll say Polar, and we'll need to specify the client, which is the Polar client. We'll also say create customer on sign up. So whenever we create a user in BetterAuth, it is also automatically going to create a user in Polar instead of us having to do this manually through a webhook. And then we can put in this use right here. So I'll say use, and then I would like to use the checkout, for example, and also the portal. Usage we do not need, but webhooks we are going to need as well, because whenever the user pays for something, we can then add the credits to the user's account. So under checkout, right there, we'll call this as a function. Then we can put in the products, and then we'll just need to actually create some products in Polar. So hopping under the settings over here, going under our products within our test environment right here, we can then create a new product. I'll then call this first product small credit pack. In the description, we'll put in 10 credits for creating songs, like this. And then under pricing, it should be one time and then fixed price of something like $10. And then that should be it. Going down, we do not need any of this. So we'll just create the product. And just do this 2 more times. So if I just copy the description, new product, and then medium credit pack, description, and we'll just make it 25 to incrementally make the reward for buying a bigger package bigger. Then we'll say fixed price, 15 USD. Going down, we can create the product. And lastly, we can say large credit pack, put in 50, and then make it only $20, like this. Going down, we'll just say create product. And now we have these 3 products right here. Good. So hopping back into the documentation, we'll need the product IDs and also a slug for each product. So I'll take each product's ID and then put them into the environment variables. First of all, I'll hop under env, and then down here under Polar, I'll say next public, and then small credit pack ID is equal to, then we'll click right here, finger this, copy the product ID, copy the line twice, call this medium, and then we'll need to call this large. And the reason we prefix these with next public is to make them available on the client as well, because to redirect the user to a checkout, for example, we'll need to specify which products should be shown on the checkout page, and this request is being made from the client. So these will need to be available from the client. Good. So hopping under this medium pack, we'll copy the product ID. For the large pack, we'll copy that as well, like this. Then we can hop under environment.js and just paste in these names. So we'll have next public small credit pack ID, and we'll need to put these in on the client object, into the client object right here, because they should be available on the client and not just on the server. So this one should be a set.string. And for these next 2 ones, We'll just put in their correct names, this one and this one. Good. Then what we can do is just add them down here in the runtime environment. So I'll paste this one down, copy it twice, paste the medium one down, right there, and we can paste in the large credit pack at last. Good. Then we should have these available in the environment variables now. So I'll hop back into the documentation. Then under products, we'll specify the first product, which has a product ID of environment dot small credit pack ID and a slug of, and we'll just call this small right here. Then I'll copy this line twice, call this medium and large. This will be the medium credit pack, and this will be the large credit pack, like that. We can then also put in a success URL like this, and put in this authenticated users only right after the products right there. So the success URL should just be the root, so the dashboard root, and then we'll just say purchase success is equal to, and we'll just set this to true like that. And this one will just be true as well, because only people who are authenticated should be able to purchase anything in the checkout. Then we can allow access to the portal by putting this under the checkout right here. And we should be able to allow people, also we should allow these webhooks as well. So I'll put in webhooks, just so we can define these webhooks whenever a user pays for something. So to actually use this webhook, we'll need to get this Polar webhook secret. So hopping under the dashboard, going under settings and webhooks, we can add in an endpoint. So I'll say, we'll just need to grab this down here, terminal and grok, because this is where we need to post the webhook to. So I'll make the terminal larger here just so we can see the URL. Then just copy this one, paste it in right there. And it's very important that we put in /API/auth /polar /webhooks like this to make sure it is sent to the correct location in our application. So this means that under our API, auth, and then it is down here, API, auth, well, this route right here is then going to catch the following Polar webhooks and then make sure that the webhook is handled in here correctly. Good. So we would like to listen to order.paid like this, because only when the order is paid, we know that the user paid for something, so we should only give the credits at that point. Then I'll say create, actually I'll just say raw up here, creates, and then we'll just need to grab this webhook secret, hop into our environment variables, and then we'll say, I'll copy this line, put in the webhook secret, then say Polar webhook secret. Then I'll hop into my environment.js as well and paste it in right here. The Polar webhook secret, and down here we'll put it in as well, like this. And now we should be able to receive these webhooks in just a second. So going into Auth.ts, we can say, I'll hop into here, we can say secret, and we'll just make this environment.polar webhook secret. And then the specific webhook we're listening to is the on order paid. This will be an async function receiving an order. And we can first of all get the external custom ID. So this will be the ID of the Polar user in our database. So we can say external customer ID is equal to order.data.customer.external ID like this. And so an internal ID, for example, would be the ID of the customer in the Polar database, and the external ID is the ID of the customer in our own database, so in the database we have a neon. So it's very important to note this distinction, because these IDs won't match, because they are from two completely different systems. Cool. Then we can say if, and let me just hover here, it can be null. If not external custom ID, we'll say throw new error. No external customer ID found, like that. Then we can say const product ID is equal to order.data.product ID. Then we can say let credits to add be equal to 0. And then based on what this product ID right here is, we can change this variable to determine how many credits the user should have added to his account. So each of these products that we just created can then have an auth ID. Hopping around here. Each of these products right here have a product ID. So if the user bought this medium credit pack, for example, then we'll receive this product ID right here back in our webhook, and then we can identify that the medium credit pack was purchased. So that is how it works. So now we should add in a switch statement, say product ID. So we can then define different cases for if this is one thing or another thing. So if in case this product ID is environment.nextPublic small credit pack, well, then we'll say credits to add is equal to 10 and break the case. And we'll just do this for the two other cases. We'll have the medium and the large credit pack right here. And this was then 25 and 50. So now we can identify which product that the user bought and then give the user that amount of credits. And now we just need to update the database with this new amount right here. So we await database.user.update, where the ID matches the external custom ID, because remember, this is the ID of the customer in our database. And then the data we should update is the credits. And I would like to increment the user who bought the credits, amount of credits, with credits to add, like that. And that is really all there is to it backend wise right here. To make sure that these credits are handled correctly, we just need to set up a few more things in the configurations elsewhere. So for example, right here, we have this auth client where we just need to put in these Polar client under plugins. So I would like to say plugins, put in an array, say Polar client, like that. And then going down, let me just see what else we have. So that seemed to be it for setting up this basic integration. So then we can go back into right there. And then let me just see what it is complaining about. Polar is not defined in auth.ts right there. So what I'll do is just restart the server actually, just because we installed the new packages. So that might not have been registered correctly. So if I hover here, for example, we can see that it should be available. So let me just refresh, restart the server. And now we are all good. So one thing that we, for example, defined, which we'll need to set up now, is this success URL. So on this dashboard right here, so just the root page, if we see this search parameter purchase success is equal to true, then we'll need to show some kind of toast down here that says purchase successful, so the user knows that the purchase was registered. So the way we can do this is by hopping under our source app, and then we'll go under main and page.tsx. In here, we'll just find the client home, and this is the first client component which will hit down the tree. So we have the router already. We'll just need to put in the path name as well. Const path name is equal to use path name, like that. Now we can put in a use effect that just listens for changes in these two right here, and then just checks if this search params, if these search params up here contain what they should. So we'll actually just put in search params and then use search params as well, because we'll need all three. So first, let's put in a use effect. So this is going to run whenever the page loads first time, and we'll just say search params and router and path name, because all of these three are being used inside this use effect. So then I can say if search params dot get, and we'll just grab purchase success right there, and we'll say if that value is equal to true, then we can say toast dot success purchase successful, and then your credits will be available shortly. And then also something like please refresh the page to view your updated balance. Because if the webhook is delayed by a couple of seconds or something like that, maybe the page doesn't really show the updated amount of credits before the user refreshes the page. So that is just for noticing the user about that. And then what I would like to do, since we have this much text, is also just to put in the duration, set this to 10 seconds, aka 10,000 milliseconds. And then after showing this right here, I would like to remove this parameter from the page up here, because let's say that this page loads and the toast is shown. Well, then if you click refresh right here, so if you click refresh up here, then it's going to show the exact same thing because this is still there. So after showing this, I would like to go ahead and remove it from the router. So we'll say router.replace and then just put in path name like this. So now we can test this out. We can say / purchase success is equal to true, press enter, and then we can see how it disappears up here. And now it says purchase successful, your credits will be available shortly, please refresh the page to view your updated balance. Good. We can also, if we hop under here, create a button down here that allows the user to buy more credits, such as an upgrade button. So this one right there, I'll just remove. So what I'll do is hop under the sidebar, so app sidebar right there, and then create this component right here. So I'll hop under components, and then under sidebar, I'll say upgrade.tsx. In here, we'll just say use client because it is a client component, export default function. Upgrade, we'll call it. In here, we can, this is kind of weird, I'll just remove that. In here, we'll say const upgrade is equal to an async function. We'll then just say awaits auth client right there, dot, and then checkouts, and then we can pass in the products that the user should have available for purchasing. So that will be environment dot, and then small credit pack. We're also going to need the medium credit pack and also the large credit pack like that. Cool. So whenever we call this should automatically redirect the user to this page or to this checkout with these products available for purchase. So what we need to do now is just return the actual HTML. So that is going to be a totally regular ShadCN button that says upgrade. And if I just take this component actually and then paste it in right there, we should be able to see it in just a second. So opening this up, we can see the upgrade button. Then I'll go ahead and say variant, outline. We can also say size, small. And we can say class name, margin left 2, just to space these apart. Text, purple, 600, like that. We can also say on click, and then upgrade, like that. Then right now, if I click this, it isn't going to work as we want it to, because as you see, the email field is just blank right here. And that is because inside our auth.ts, we see that we have this create customers on sign up set to true. This means that whenever we create a new user inside our system, it is also going to create a user in Polar.sh. But hopping into Polar.sh, going under customers, we can see that we have 0 customers right here. And that is because we made this user, which we're currently using in here, way before actually making the Polar integration. So the customer in Polar was never created. Therefore, I'll hop into Neon, go under my user table right there. I'll then go ahead and delete my user, then hop back into my application, and then go down here and then sign out. Then if I sign up again, and say create an account, we should now be able to see the Polar customer in here. So just refreshing our customers, we now are able to see the customer being created. And also if we do click upgrade right there, we should also be able to see the email being pre-filled, because the user shouldn't even be able to change this. It should be fixed. And then if I put in a random credit card number, so you need to put in 4242, And then for the expiration date, just put in a date in the future, put in a random security code, and pick your country. Click pay. Then we'll just go ahead and see if it works out like we expect or whether it doesn't. So purchase successful. Going in here, we can see we have 110 credits now, and we had 100 whenever we signed up. We also are able to see that this search parameter up here is gone. So if I refresh right now, we don't see this toast down here again. So everything is working as expected. Then for accessing this customer portal right here, we'll need to go ahead and just create that as well. So under app sidebar, we have this user button. So I'll just remove the to do. And right now the user button, if I click it, only shows settings and sign out. I would like it to include an additional link though to a customer portal, but because we can't embed what we actually want in here, but only a link to a page, we'll need to create a page that then redirects to the customer portal. So the way we'll do this is by going to main, say new folder, customer portal. This will create a route up here that says app and then / customer portal. And then whenever we navigate to this, whatever is inside this page.tsx will be shown like this. So in here we'll say export default async function, call this page. In here we'll just need to authenticate, so const session. So I'll just copy what we have done over here, import headers, auth, and also redirect down here. Then I'll say return. I would like to just create a component for this though. So hopping under components, we'll create a new file called customer portal redirect.tsx. In here we'll say export default function customer portal redirect. And then we'll make sure that it is a client component, because we'll have a use effect in here that immediately redirects the user to this customer portal. So we can say use effect to do this redirect, which means this is going to be run whenever the page loads and not any time else, because we'll put in an empty dependency array. Then we'll say const portal is equal to an async function. We'll then say awaits auth client. And we'll say .customer.portal, and calling this function will automatically redirect the user to that page. And we'll just need to call this function right now. So we'll say void portal like that. And then what we're going to do is just render out some HTML. First, I'll just return this component though, customer portal redirect, comment out this use effect, and then say return, and then something like a div hello. Then in here, if we navigate to the customer portal, we now see hello. So now we can just now we can just see what happens whenever the user is redirected before this use effect works. So we'll put in a div with flex age screen with full items center justify center. We'll put in a div with class name flex items center and gap 2. In here we'll put in a loader 2 like that, which will have class name height 5 with 5 as well, and then animate spin, so it's going to look like that. And we can then also put in a span that says loading customer portal ... And if I then just say text muted foreground, then it looks like this. And if I then remove this comment right here, and then press save, it should then immediately take us to the actual customer portal up here. So that is essentially what we did. This only shows, this HTML right here only shows until this use effect has finished and then does the redirect. So I just put this in basically just so the user doesn't see nothing, but such that the user can see that the customer portal is loading in case he is wondering why he isn't already on the customer portal. Good. So now redirecting the user to this customer portal URL should then let him see the customer portal. So going down here, we can add this link to this button right there. So we can say user button, and then after this variant outline, we'll just put in size, defaults, and we'll put in additional links. So under additional links, I would like a link with the label customer portal. I also want the href to be the customer portal like this, and I would like the icon to be a user icon from the sheet React. So we should be able to see this in just a second. We have the customer portal right here. So in a perfect world, we wouldn't have to create a page that then redirects to the customer portal. In a perfect world, we would be able to put in an additional link right here, where we would then be able to define some specific function that should be called, instead of us having to only define this href. Because as you see inside this component right here, what we are able to do on the client is just call auth client.customer.portal, and then this will redirect the user to the portal. But because we can't just call this in here, such as this, for example, well, we'll have to create this workaround where we then redirect the user to this page, and then that page calls the actual function that takes the user to the portal. So that is just the background for why we're doing this in the first place. So clicking on the customer portal down here, that takes us to the customer portal, and the entire flow looks something like that. There are no more features I would like to build out now, and I just want to get ready for deployment. So to do this, we'll start by running the linter. So we can go into npm scripts, find the lint command right here. So this one, you can also run nextlint in the terminal if you would like to do that. And that will then check, the linter will then check if there are any errors in the code. So for example, different syntax errors down here that will work but are not good practices. So that is kind of what the linter checks. And we'll just need to fix these errors right here, because if there are any linter errors in the compile step, the build of the application is going to fail whenever it builds on the cell. So we might as well just fix them now to avoid that problem. So that was the first one right there. We can also go into this component right here, and then it says promises must be awaited, end with a call.catch. And by the way, right here, what happened was that we went from this right here, which it doesn't support very well, to this escaped character, which just renders out the same thing, but now the code knows the difference between these two. So over here for the next one, we can say promises must be awaited, and then right here we do not need to handle it, so we'll put in void right here, which tells the linter that we're intentionally ignoring this promise, because if we hover this, we can see that it says promise. So we can just put in void just to let it know that nothing will happen, because we know that it works. Cool. Then going down here to the audio uploader, down here, we have another apostrophe. Oh, sorry, that was the same one. If we hop into providers, we see this one, avoid referencing unbound methods, which may cause unintentional scoping of this. So what we'll do here is call the functions like this instead. And then that should be all of the different warnings or errors it actually is. So running the linter again. Let's just see if it works out now. So we got these two errors still actually. So I just forgot to put in, so navigate right here receives some kind of URL. And the same for replace right here. So I just forgot to put in these into the function calls, and that should then fix the linters. So I'll just go ahead and run it again. And here we have the results. Scrolling up, we now see that all of the errors are gone, which is perfectly fine for us. Good. Now we should be able to deploy the application. So what I'll first do is hop in and initialize new GitHub repository. I'll do this under the frontend folder. So what we can do is say file, open folder. Then we'll hop into our repository right here. Then go into frontend, open up the repository. Then we can just close down these pop-ups. And then what I'll do is go into this source control option menu right here, say initialize repository. And then I would like to make a commit. So I'll just call this commit initial and make sure that everything right here is what it should be. So we aren't committing anything that shouldn't be committed, as I can see. For example, this environment, the .env shouldn't be committed, but this is already handled by the getignore file right here from the tier 3 stack, which we use to initialize the project. So as you can see, this file right here ignores some specific files that shouldn't be pushed, such as the node modules, the dsstore files for MacBooks, for example, and then also this .env file, which shouldn't be pushed to the source control. So now we should be able to click commit, publish the branch, call it something like HeyGen clone, or whatever you would like to call the project. I'll make it a private repository right here. And then we should be able to say open on GitHub. And over here, we now are able to see the project. Next, I would like to go ahead and set up the Vercel project. So we'll deploy it with Vercel and then say login. And I would like to log in with my GitHub right here. And then we can say add new in the dashboard, project. Then we can say HeyGen clone right there. And then we'll go into the environment variables. And then we need to copy in the environment variables we have from our local repository as well. So what we can do is just copy all of these actually, like this. And then you can paste them in right here. And that will then fill out all of these different values to be the same as it was over here. We'll need to take this Vercel URL and just remove this because as you can see, it is populated by the system. So that is also why we had to define it over here ourselves, because we are using it in the program. I would like to just change the BetterAuth secret just to be something different from the secret over here in our local environment. The BetterAuth URL I'm going to remove because we didn't really use that anyways. So just copying it in and searching for it in the project, we can see that we didn't use that. So I'll just go ahead and remove it. And then we also would like to connect to the production database. So hopping into Neon over here, we can just hop under branches, production instead. Go into the overview, say connect, then we can say show password, and then just grab the password for the production database and use that instead of the password for the development database. So down here under database URL, I'll just replace this value with the new value. Then another thing we might also want to do is change this development sandbox access token to Polar to the access token that is not the sandbox, but that is the real environment. So right now over here, going into Polar, we can see that we are inside the sandbox mode. So we can see that over here, we can see sandbox.polar. This means that everything we do right here doesn't really affect your live account. So in real life, we would, in the production environment, like to create a new organization that is not inside this sandbox.polar. And this would then mean that we could test with the sandbox when we develop over here. But then whenever we would like to deploy, we then are connected to the real Polar environment. But because I want to not use my real credit card to test out the application, what I would like to do is just keep the access token and also the webhook connected to this sandbox environment, just such that we can test things out in production without having to use our own credit cards. One thing I want to do though is to just reroute the webhook to the correct place. So going under settings, webhooks, we just need, whenever we have deployed to Vercel, to change this URL right here to point to our actual Vercel application instead of this proxy, which will then reroute to our local development server. But we can change this value before we have deployed and before we can actually see the URL. So hopping into Vercel again, I'll deploy with the following list of environment variables, and then we'll see if anything is missing or if the build fails for any reason, and then correct that if that happens. So let's try and click deploy. And then whenever this finishes, I would like to take a look at the result and then see what happens. After a few minutes, the project was deployed without any errors, which is pretty nice. So we can then continue to the dashboard, then grab the domain of the application, hop into Polar on the webhooks, go to details, and then change out the actual URL over here. So this is the URL we use in the sandbox for testing. So the URL we send webhooks to, and instead of sending it to this proxy, we will go ahead and send it to our production system, which has the following URL. Therefore, I can go ahead and say save. And then we should be good with this updated webhook. Cool. Now we have the application deployed and we also have the webhook fixed. And I would then like to set up Inngest as well, because Inngest is another server that has to run for itself, which will then handle all of the background processing. So far we have hosted Inngest down here in the local terminal, But in production, we'll need to use the Inngest platform to actually run Inngest. To get started with this, I'll hop under the dashboard right here. So just a regular dashboard, hop under integrations, and then go to browse marketplace. And I'll just search for Inngest and install it right here. This will set some of the environment variables which we'll need to connect to the Inngest server, so schedule the jobs that should be processed, etc. I already have an account for Inngest. If you do not have an account, you can go ahead and search for Inngest. Just say sign up, and then I usually just sign up with my GitHub or something like that. So whenever you're signed up, you should then be able to hop back in here and then say link to an existing account. You can of course also say create a new Inngest account straight from this page and then follow the steps after that. I'll just link to an existing Inngest account and click continue, say specific projects, HeyGen clone, and connect my account. Then I would like to say sign in with GitHub. Click right there, say save configuration. Then we can see that the Vercel project will have the Inngest sign-in key and also Inngest event key environment variables set, which means that it'll automatically be able to connect to Inngest. And then it also says the next time you deploy your project to Vercel, your functions will automatically appear in the Inngest dashboard. This means that since we have already deployed our project, we might have to redeploy a project before it is able to connect to the Inngest. Therefore, we'll just say continue to Inngest Vercel dashboard. Like this, and now we should be good. And then what we can do is just hop into our project again in Vercel, so overview, and then find our project. So I'll just refresh over here, click my project, and then one thing we'll need to do for Inngest to work is to disable deployment protection. So hopping under deployment protection, we'll just disable it right there, say save, and we should then be able to go into integrations again. Click Inngest, then say manage access, configure, and that will then take us to Inngest right here. So this is the Inngest dashboard under app.inngest.com. So as you can see, this is their official website and not just the localhost one we were running over here. Good. So now we should, for example, be able to say environments, production, and then see our apps. So right now we're not able to see our app right here, but we should in just a second whenever it connects. So what I'll do, first of all, is hop back into Vercel and then go into my application. Then just find the deployment up here, deployments, and we can see already that it is building. So I'll just wait for this to finish building. And then what I'll do is just try and see if it connects. Otherwise, I'll wait 5 minutes and then just try and build it again. And then periodically it should check for whether the deployment is deployed or not, and then connect automatically. So I've deployed now. What happened, by the way, is that the deployment that was happening right here kept on going forever. It took about 10 minutes and it was still deploying. So something was wrong with that deployment. I don't really know what that is. But what I did was that I clicked these three dots right here, and then I clicked cancel deployment. And then I just went to the one down here, and then I said redeploy right there. And then I checked off this one, so I do not want to use the existing build cache. And then I clicked redeploy. And that gave me this deployment up here that only took about 2 minutes, like we're used to. This redeployment up here should then also have the new environment variables. Hopping into settings, actually, environment variables, we should be able to see these Inngest event key and sign-in keys right there. So these environment variables should now be available to this new deployment. Now let's just hop back into the Inngest platform and just refresh over here. If I go under my archived apps, we can see that I have this HeyGen clone right here, which is a project in Inngest that I've previously had and then archived. So this URL right there should then match this URL for the deployment in here, and they do. So this means that everything was working just fine. It was just that I have archived a project with the same name previously. Therefore, I'll take my archived project, unarchive that. So in your case, it probably should already work because you haven't archived anything previously. So now that I'm able to see the project right here, it should work fine. So I can, for example, go under functions. Then we're able to see our functions. We can see the event types under events and runs. We can see that it looks fine, but we don't have anything yet. So let's just try and test it out. If I hop into the Vercel dashboard and then I go to the domain right here, one thing we just want to do is And before we do anything, is just to make sure that the production database is set up. So right now, actually, if I go under Neon and then hop into production right here, and then say tables, we see that we have 0 tables in here. So we just want to make sure that we have all the same tables like we did during development. So what I'll do is just hop into the environment variables first of all, and then just replace the database URL from development with database URL for production, like that. And then I'll say npm scripts, and then database push, like this, database push. And that should then push all of the tables to the production database as well. So going on the tables now, we should be able to see these. Then it is very important that you remove this production environment URL, because we of course only want to connect to the development database during development. Cool. So now we should be able to create users, etc. Because we are testing in the way we are doing right now, where we are connected to the sandbox during production, we'll need to make sure that only the users created during production is also the ones created in Polar. So right now we, for example, have a user in development, in the development database that is connected to a user in Polar right here. So that would not work, for example. But if we create a user in the production database that is then connected to a user here in Polar, well, that would work completely fine. So to avoid any problems, we'll just go ahead and delete the customer, and I'll copy the email right there, paste it in and delete that. And then I'll hop into our deployment, and then we should be able to create a user. So I'll click sign up, put in my name, email, and also my password, say create an account. And now that I've created an account, then if I hop into Polar again, just refresh, we now see the created user in here, or it is a created customer. Going into Neon again, so that should be over, all the way over here. We should be able to go on the user in production, and then also see the created user over here, which is great. Now going into our application, so I think I'll just need to close some of these down because I have way too much open right now. So I'll just close a lot of these things down, this one, and also just go into the cell again, hop into my application, go to the domain. We can then see what we are able to do. So first of all, this seems to work completely fine. If I click upgrade, for example, we can just try and buy credits first of all to see if that works. And then I'll say pay. And this of course will need to be set as well. So let me just see what happens whenever we have paid. So purchase successful. So it redirected back to the correct page. And then we have the 110 credits as well. Now if I then spend some of the credits on some of these features, we can just try that as well. So I'll go ahead and click photo to video portrait URL. With portrait avatar. So here we'll upload a photo. I will just take one of these. I'll just try out this one, for example. And then I'll say upload or record audio. Upload an audio file.
Hello from Modal.
So I'll say open. That is fine. Generate a video. So that should push this to Modal. Then we can also try out the experimental model. And I'll just say generate video as well. Then we can try the translate video feature. So this one, for example, says,
Hello, I'm Andreas.
So I'll take this one, say target language, Hindi, translate. Then I'll just take the change video audio.
Hello.
Open that up. And then the new audio should be something like,
I got the idea.
This one with the Bezos. So I'll say use this audio, generate. Then what we can do is we can just hop into Modal right here, for example. Then we can see how the different containers are running. We have this portrait avatar server, which is running right now, for example. And if we hop into the Sieve dashboard, we're able to see that we have these 3 jobs that are being processed right now. Portrait avatar, dubbing, and lip sync. So everything seems to be working so far. So what I'll do is just wait for these to finish, and then we can check out the results. So I just waited for the job to finish over here in Modal. So it finished after about 18 minutes of execution time. Hopping back in here, we can just refresh our recent creations. And then we should be able to see these in just a second. So we have these 4 right here. And then we can just try and play these. So the first one is,
Hello from Modal. This is a test of Chatterbox.
and the second one,
Hello from Modal. This is a test of Chatterbox.
It's pretty cool how we can see that these are 2 different models, of course, with the same purpose. But for this model over here, we'll then see some movements of these plants in the
Hello
back.
from Modal. This is a test of Chatterbox.
And these kind of movements in the back we don't see on this other model. I think this is the Sieve model, and this is the model that we self-host. So that little nuance is pretty cool. Let me just try out the translate video.
Namaste. मैं Andres हूँ.
And this one.
I got the idea to start Amazon 16.
So all of these different features seem to work out just fine. So now we have successfully deployed the application to production. Let me just check out the settings and also the customer portal down here. So I'll say customer portal. Just wait for this to load. And we're able to see the customer portal as well. I'll just hop back into the application. Good. So everything is working just fine. And we have now successfully deployed the application to production. Before ending the video, I just want to walk you through some exercises that we can, that you can make to become even better at building systems like this. So here are the exercises. For this video, there will be 3 different exercises in different difficulties. These 2 orange ones are the easiest ones, and this last one is a little bit harder. So for the first one, I would like you to create a menu called Voices, where you can upload or record voices. You should then be able to use these voices instead of having to record these every single time you would like to use them in a video. So right now, you just need to upload a voice every time they generate something. So what I mean by this is that if I click right here, for example, then upload a video, and then I go right here, I'll need to record some audio. So I record some audio, and then I say use this audio, but I have to do this process of recording or selecting audio every time I use one of these features. Instead, I would like you to create a menu out here called Voices, and then another page that says something like Voices right there. And this page should then contain all these voices in boxes like this. So for example, it could look like this right here. So this big page would just have these small boxes with the different voices. And then there is both my voices, which are the one that you have recorded yourself, but there is also the HeyGen library with all the public voices. So it should basically be a full voice overview, and then whenever you add a voice to that, then the voice should then pop up under my voices over here, instead of you having to upload a file every single time. Good. The next exercise is creating a page called Projects, where users can see the generated videos, create folders, and also order the videos. So right now the recent creations are just shown right here, and I think we show 5 of each of these types of recent creations. But the problem, for example, is that let's say you have 100 different recent creations, well then you'll have to scroll down or something like that, or this will overflow the page if we didn't have flex wrap. So we would need some way to either paginate between all of these recent creations or to like order the files. So over here, if you made a menu called Projects, which would then lead to a page called Projects like this. And then in this page, you would be able to see every single recent creation, and then also create folders, which you would be able to drag these recent creations into. So that would just be a pretty cool feature for users to be able to order their their videos. And lastly, you could try and find an AI model that you think is cool and then implement that into the system. So for example, you can use a FastAPI, which is a service kind of like Sieve, just with more models. So FastAPI has a bunch of different models which you can try out, so I'd recommend trying that out at least. But you can also try and see if you can find some models from Sieve data which you would like to use, or if you want to do it totally hardcore, you can go to GitHub and then just search for portrait avatar models, and then pick some of these models and try and self-host them on Modal, create endpoints for them, and then try and integrate them into the system. That is probably what will teach you the most about these kinds of programs, because you'll then have to do everything end to end, so both finding the models, which is a big challenge in itself. This, for example, includes having to look through the GitHub issues, seeing if people are talking about something that makes the model bad or good. For example, a lot of people talk about how good the video output is, but also about how slow the model is to generate, to run inference. So for example, for our model right here, you can see that it takes about 18 minutes to run inference, and that is way slower than it takes for Sieve data over here. where we also have portrait avatar. Here it only takes 2 minutes and 32 seconds. But as we saw in the video results over here, the results are pretty similar, and Sieve, I would even say, are even better. Therefore, finding these models is really a big task, because you have to look for a bunch of different models, see what people are saying about them, and sometimes you won't even know how the model performs until you have tested it yourself, because oftentimes these models are marketed as way better than they actually are on the researchers' web pages. So that is a pretty cool challenge. Just go out and find the model, and then try and self-host the model, and then build it into a feature right here with a modal, and then put in a button on this, create something new. So that was it for this video. Thank you so much for listening in and then following along. I really hope you learned something, and I'll then see you in the next video.